Gentlemen, colleagues, friends, I'm Hannu Toivonen, the Program Chair of ICCC 2015, and I'd like to welcome you to the meeting. It's going to be an exciting event. With a global history, we've been around, and it's not only the conference that has been around. We are also very proud to have actually participants from all over the world. From Mexico to Colombia, from Indonesia to Australia. Just shortly some highlights of the conference. So we have 41 contributed talks selected after a careful peer review. Each paper was reviewed by at least 3 PC members, some of them by 4. We have an exciting keynote, I'm looking forward, by Emily Short. We also have short talks. Sorry, there's a typo, there are only 4 of them, my mistake. And actually the conference got started already yesterday with a workshop on computational creativity and games, and that seemed to be a great success already. And then, in addition to the scientific program, we of course have an exciting social program with a reception tonight. We have a chairlift and hike on one of the evenings, a banquet, and so on. And of course, as we all have noticed, the location here is very special, so a great thank you already to Dan for organizing the conference in such a beautiful and exciting and fun location. So what's in front of us? Here's a quick outline of the program. You see the session titles. As usual, we have a huge variety in topics, from creative autonomy to music, conceptual blending, and so on and so on. We have a very simple structure here. We have coffee always at 11, lunch at 1, coffee almost always at 3:30, and then social program in the evening. It's going to be exciting. The 41 papers have really high quality. I'm really proud as PC chair of the work that you as authors and PC members have done to come up with this program. So again, already now a big thank you to all of you for your contributions as authors and program committee members. Now let's get to some more practical instructions for all of us in different roles, in audience, presenters, session chairs. First, a reminder, we do have a number of different types of papers. So unlike in computer science conferences where many of us mostly visit, we don't only have technical papers here, but we also have system and resource description papers, cultural application papers, study papers, and position papers. So in the audience, please keep in mind that these different types of papers have different goals and different merits by which they've been chosen to be presented. as authors, or presenters, it would be nice maybe if you indicate about the nature of your presentation, of your paper, because that's not explicit in the paper anywhere. Each paper has been allocated 30 minutes, but that's the total time for one paper, including questions and answers, and including the handover to the next speaker. So as presenters, please use absolutely no more than 25 minutes for your talk, so there's at least a couple of minutes for questions and for the handover to the next speaker. Session chairs have been assigned for each session, and their duty, of course, is to keep the time. You all know this already, how it works, but I'll just make sure that everybody remembers. So we have these signs to show to the speaker how many minutes she or he has got until the 25 minutes are used. But you are most welcome to use a bit less, so there's more time for discussion. As tradition goes for ICCC, there usually is lots of good discussion after the presentation. So let's reserve time for that as well. We have this specific device here. Those of you who have been attending ICCC before might remember this. So the session chairs will use this to remind the speaker when it's time to sit down and stop talking and leave some time for questions. So you've been warned. What else? One practical point. Quite opposite to what we announced before the conference, we do not have VGA connectivity. Instead, we have HDMI. So I guess Mac users should be mostly okay, and some others as well. And now everybody's okay because we have an adapter. Thank you very much. So please check before your session, and the session chair should check with the presenters that everybody can show for sure their slides on the screen. But it seems we have the adapter now, so also VGA should work. Okay, at this point I'd like to welcome you all again, and I'm very happy to see many new faces here, people who didn't attend ICCC before. Very special welcome to all of you to this meeting. Now I'll hand over to Danvi and Tura, the local chair, for some local announcements.
Oops, I went the wrong way. Thanks, Hanu. Just a couple of quick things to let you know about Park City a little bit. First of all, thank you very much for coming. If you go back a couple slides and look at this list that Hanu showed, one of these doesn't look like the others. Right? There's some of the great capitals of the world and a little mining town in Utah. So thank you all for coming, making the trip. I know for some of you it's a very long trip. It's a fun location. I think we'll have fun, and I'm very excited to welcome you all here. I'm very happy that you would all come. You may have noticed that we're quite high up. For some of you, it might be hard to breathe. There's nothing we can do about this, really. It's about 7,000 feet. Really, I mean, blood transfusions maybe. We're about 7,000 feet right here. When we ride the chairlift on Tuesday, we'll get up another 1,800 feet beyond that. The smaller numbers are in meters in case that works better for you. One thing you can do to help altitude problems a little bit is to keep hydrated. It's easy to get dehydrated at high altitudes, and then you get headaches and you feel worse. So drink a lot of water. That's about all we can do. Most of you been up and down Main Street. There's lots of fun restaurants and boutiques, and there's a lot of art galleries. In a square mile here, there's like 25 art galleries. Some of them I think are atrocious. Some of them I think are fantastic. Sorry, I just do. Some of them I think have some really cool stuff too. So hopefully you'll find some time to wander up and down and poke your nose in a few of them and check it out. Maybe you and I will disagree about which ones are atrocious. I don't know. Anyways, it's a really fun little street, and there's lots of great places to eat, from very reasonably priced to outrageously priced. Whatever you're looking for, it's there. The social program, I'll say more about this each day so that because some of them have a little bit of logistical considerations to talk about. Tonight's the reception. It's at 6 o'clock. It's just in the courtyard between the buildings out here in the back. It should be very lovely. It's just going to be some beverages and finger foods and a chance to socialize. All of this social program is very important. We eat together at this conference because we value the connectivity that happens and the networking and the friendships that we make. You can't do it at a large conference, but with a small one you can. We're conflicted because we want to grow, but if we grow too much, we'll lose that. But right now we haven't lost it yet, so please take advantage of all these opportunities to mingle and meet new people, start new collaborations, and all that kind of stuff. It's really good. So the reception will be tonight. We'll have a little music. We'll have a little finger foods and stuff and just get to know each other a little more. The hike is on Tuesday. There's a little bit of logistical issues for that. I'll explain more on Tuesday. That's tomorrow, I suppose. How to make that work. We'll ride the chair up. We'll wander around in the mountains. If you don't want to do that, you can ride the chair right back down. And for most of us, we'll probably eventually ride the chair down anyways because it's about a 5-mile walk from the top back down. If you want to do that walk, that's great. If you don't, you can get back on the chair and come down when you've had your fill of the mountain air. The banquet is at the bottom of the hill at a restaurant called the Mustang on Wednesday night. Don't eat at the Mustang unless you want to eat there twice because we're going to eat there on Wednesday. There's a lot of other options, so just pick something else between now and then. I think that's it. My name's Dan. If you have any questions or need any advice or any help or anything, please let me know. I'll be wandering around Glazed all week. I know a lot of you already. For those of you that I don't know yet, please introduce yourself. I'll try to get to know everybody. And thanks very much for coming. I think there's one more slide. Mike is going to say a little something about this, I think. Mike's our publicity chair. He's the other guy you should know. Do you want to say something? Do you want me to just say it?
Sure, you can.
All right. Mike is streaming this to YouTube and also archiving all of the talks. If you are not comfortable for any reason with having your talk streamed or archived, just say something. He'll turn it off. We hope you'll do it, but if you're not, that's completely fine. Just let him know. Also, we have a Twitter hashtag if you want to tweet or do anything else that you do on Twitter, I guess. Use that hashtag right there. And I think with that, we're ready to go, right? Thank you.
All right, excellent. So we are ready for the first session. And the topic of the session is creative autonomy. The first talk will be by Martin Mumford. So please.
Thank you. Shall I
just like this? All right. Thank you. Okay. Very good. All right. Perfect. Oh, thank you.
I can hold one when you attach the other one.
Oh, thanks.
Yep.
Never use this, so something like that. All right. Thank you very much. Fantastic.
Okay, so Martin, whenever ready, please.
All right, very well. All right, so I am Martin Mumford. I'm from Brigham Young University, working with Dan Ventura. I'm a master's student. I think we traveled the least possible distance to be here today. It's about an hour drive, so not too bad. And today we're going to be talking about skepticism, particularly as it relates to creative autonomy. Now, first of all, there's an interesting issue with artificial intelligence and creative intelligence in general. There's kind of a dual perception. Oh, absolutely, I would. Thank you. Oh, thank you. Perfect. Let's try this thing out. There we go. All right, fantastic. So there's a bit of a dual perception. First of all, there's this fear of artificial intelligence, a little bit sensationalized, I think, and a capacity to overstate the potential of AI at the current moment. And then at the same time, there's a bit of an understatement as well. People are skeptical at the same time. So we're going to be focusing on the skepticism. This is a recent DARPA event. It didn't go so well. Yeah, so you can see the dual nature of artificial intelligence. People often have both of these in their heads when they think about it. So what we're going to be talking about, first of all, will motivate why do we care about public perception? Why don't we just focus on the science and ignore the public perception? Then we're going to talk about, as a field, how do we personally judge creativity? And then we're going to introduce a few case studies that help us analyze how the public perceives creativity. And then we're going to get to a few uncomfortable questions. And that's where I hope there will be lots of good discussion. All right, so first off, why should we care? The perception of creativity itself doesn't inherently mean that our machines become more creative by enhancing the perception of them. One reason is we do have a responsibility not just to make machines that are theoretically sound, but also they need to be convincingly demonstrable, and they should also be socially acceptable. So there's that small reason there. More importantly, though, I think that looking into an outsider's perspective into our field, we can maybe gain some new insights and directions, maybe a reevaluation of our goals as a field, or perhaps our direction of where we're going, and how it might jive with the public opinion in the future. There's also, of course, the danger of worrying too much about the perception of creativity, which is means that we may end up focusing on trickery or trying to deceive people into thinking that a machine is creative. We don't want that, of course. So that's the opposite extreme. So first of all, here are our goals of our field, grossly simplified, but we want to make programs that exhibit creative behavior, and people would, reasonable, unbiased people, of course, would deem to be creative. Also, there's co-creativity, which we're going to hear a lot about later. So first of all, we wanted to find out how does the public opinion differ for ours? Is it in contrast or overlapping? In what way are these two related? First of all, in our own field, now this is of course a review, we can analyze the properties of the artifacts generated to find out, in order to judge creativity, of course, quality, novelty, and originality, things like that. We can also look inside the machine and judge the process, of course. Is it appreciative? Does it have style? How does it fare in a context of a larger society of creators? Right? And these are things that have been discussed in great detail before. There's also a few interesting tests of creativity. There are many more than this, but I've picked these for a reason. There's the Torrance test for humans, which involves a lot of writing and drawing, so it's a little bit out of reach of computers for now, due to natural language processing and image processing limitations. But then we have some very unusual thought experiments and tests, such as the Loveless test, which is extremely difficult to pass. One of the components is that a programmer should be unable to explain how the artifact was generated, even given ample time to do so. So that's an extremely difficult task to do for a program that we've designed. Also, there's, of course, the Chinese rule argument, which, you probably all know, but it is the idea that no matter how complicated these programs we are building, it can always be argued that the machine itself doesn't understand what is happening. It is just mindlessly manipulating symbols, and to an outside observer it may appear intelligent, but on the inside it may have no actual understanding of what it's processing. And we will actually dive into this a little bit later. All right, so how does this fare? So we introduced, first of all, we wanted to give out a simple survey to find out what people's expectations are among different groups. We wanted to see how people thought about the idea of a creative computer in the sort of tech-literate public, which was given out on Reddit, which is a social online bulletin board site. We also gave it to a group of software engineers who code for a career, and also specifically computer science academics, graduate students and professors. So an interesting diverse group here. And our expectation, of course, was that as you learn more about code and its potential, you would, of course, be more inclined to believe that computers can be creative. That wasn't exactly the case. All right, so first of all, we measured the general sentiment of, on a simple Likert scale. Are they currently capable of creativity, and will they ever be capable of creativity? Right? And we also wanted to do sort of a free response to get some opinions on what is required for creativity, and also what would it take to push you over the line to believe that a computer is being creative? What specifically would it have to do to convince you fully. Now, this is actually kind of interesting. So here's the general sentiment about, are they now creative and will they ever be creative? And this is actually really interesting. The software engineers were surprisingly very optimistic about this. And the academics were sadly very, very pessimistic on the subject. I'm sure you've noticed this as you've spoken to your colleagues and your friends and family, but there's a lot of gut reaction skepticism that appears. While this is very interesting, it could be because as you see how the sausage is actually made, maybe you're put off a little bit about the potential, or maybe as grad students struggle to make their artificial intelligence do anything useful, they might give up hope, perhaps, that it is advancing as fast as we want to claim it is in media. All right, but the requirements are what's actually really interesting. What people said they thought were required for creativity. And mostly they actually were very much in line with our creative behaviors that we've defined as a field. Lateral thinking, flexibility, aesthetics, novelty, analogy, and transformation. These were, all the responses were summarized as 8 broad categories of the most common types of answers that appeared. Also, human emotion was interesting, including courage and bravery, and self-improvement and autonomy. And we'll get to these in a minute. Lateral thinking, we can skip this, although it's interesting. Now, these were some very specific responses about autonomy, and this was probably the strongest, most opinionated point from all groups, especially academics. But they said that they demanded, in order to convince them that a machine was being created, they demanded independent thought, unique intelligence, having its own mind, agency, and to choose for itself. These were very common, these code-specific responses, not a result of programming. That's a little difficult for us. Not based on algorithms, create its own code, create its own programs, no explicit code willing to do, and write the program on its own. Now, the problem is these are also from CS academics, so this is not necessarily a misunderstanding of what code is or what it can do. These are also from professors who study machine learning and know of their capabilities to expand and grow. So it's interesting that these showed up quite frequently. And so we've correlating these with the actual sentiment of skepticism, we found that the optimists, the ones most likely to believe, actually favored the standard measurements that we use, originality, skill, aesthetics, things like that. Whereas the skeptics were very intensely focused upon this idea of independent thought. They wanted some outside entity to be able to put the responsibility on, and without that entity, they could do nothing. And that begs an interesting question: are we optimists, or should we be more skeptical of our own programs? All right, so here's an interesting case study that was run, and we'll go through this briefly. What if a computer could match the human skill at a creative task? And we doubtless will eventually get there, but right now it's a very difficult challenge. How would people react? We might be able to see, we might be able to perform some experiments. The problem, though, is that we didn't actually have such a machine. And so we devised a test. This is an example of an analogy-making program here. It's a simple interface, and all it does is the user will come up and type in their question and the question or the analogy to be made. So, for example, dating is like pizza, and the computer will tell you why. In reality, it's actually going behind the scenes to a human who is typing in, improvising an answer on the spot. Again, now this is not complete trickery. This is benign trickery. We wanted to see if they already believed that the computer is generating these responses. That's interesting, yeah. They would be impressed. So we wanted the quality to be human level, and we did that by inserting a human. But we wanted to mess with other attributes of creativity to see how, if the quality was not an issue, there we go. If the quality is not an issue, then what could we experiment with outside of quality? So let's try this. There we go. All right. Fantastic. So it actually had 3 stages. Oh, did you want to see what it said? I'll give you a few guesses if you've ever seen the movie. You never know what you're going to get. All right. So we did it in 3 stages. First, we held everything independent and it messed only with interactivity. So the first one, you could push a button and it would generate a human-made analogy. They didn't know it was human-made. The second one, they could pick between 2 words, and it would create an analogy between them. And the third one, you could type in anything you wanted in the whole world, and the human would create the analogy. So different levels of interactivity, the quality was held the same. So obviously we couldn't do this without the human in the middle, but we wanted to see how interactivity affected perception. let's see. And actually, the results were very interesting. So before we get to what this found, here's another one that messed with the process instead of interactivity. So this was the same artifact. The task was to generate a video game-esque lava dungeon. And it was the same artifact both times. This one was created instantaneously when you press the button. This one was created sort of piecewise. So there's an obvious logical progression to it, so more computer-like. And this one was created in a way of adding and subtracting and expanding different elements to make it seem like there was a lot more thought behind it. So exactly. The same quality, though, but just different perception of the process. And so these are just small case studies to see how those particular elements mattered. And so what we found, we would ask the people to evaluate what they thought, who was responsible for the creating of the task for both the analogy and the level generator. Now, 1 was all programmer, 5 was all program. And what was interesting is, as we, of course, allowed people to interact with the machine more, they would dig in and try to find edge cases and try to look for patterns. They wanted to find patterns. But in each of the 3 tests, the perception improved. And when we ran a single person through each of the 3 tasks consecutively, the perception improved even more. This is probably because they had to reassess their own evaluations. They might have been breaking down that skepticism piece by piece as they went along, as you were able to interact with it more and more. Also, in the process experiment, the perception would go up as well as we tried different levels of exposing a human-like process to them. But going back to that survey about autonomy, this is very important. There seems to be an extremely high emphasis on autonomy from an outsider's perspective. So we're going to talk a little bit about that autonomy. And here's where we get to those uncomfortable questions. Is autonomy necessary for creative attribution? And by the way, I do know that autonomy is a very ill-defined word, and we'll get to that in a minute too. But is autonomy necessary for creativity in general? Can we have a non-intelligent, non-autonomous agent that is being creative? And that's a very interesting question. If so, I think there's a lot of artists that will be out of jobs. To what extent are we still responsible, despite our best efforts, for the creativity of our programs? All right, so particularly about this autonomy, our goal is essentially to shift the cognitive burden from ourselves onto our programs. We want to claim their creativity. We want this. And oftentimes it's very convenient to think of ourselves in a sort of parent-child relationship or a student-mentor relationship. Because we are, of course, still socially responsible for what our programs do. We need to be aware of their capabilities in case they do something unexpected and bad. But we do not want to be responsible for the artifacts that they produce or the creative process in their minds. However, what tends to happen is we actually have much more of this creator-creation relationship with our programs. We are architecting their minds and thoughts rather than simply training them. And so the relationship is subtly different from that of a mentor and pupil, even though we're using things like machine learning to teach them things that we ourselves don't know. And so this lack of autonomy can actually bind us to our creations, unless we can somehow justify that they are independent in thought as well as independent in creation. Now, again, to that very fuzzy word, autonomy. Intelligence, autonomy, and independent thought, those are all very poorly defined words. But in thinking, how can we separate ourselves from our machines better, I'm going to build up a bit of a spectrum, at least. And I'm going to use some analogies to help you envision this spectrum of autonomy, so we can talk on the same terms when we discuss this. So the orders of ignorance is a concept in software engineering. The 0th order is I know something. First order is I know what I don't know. So I know the language Finnish exists, but I do not know how to speak it. The second order might be I know that there are languages that I do not know, but I do not know what they are. So this can keep going, but obviously it's similar to psychology and metacognition, where you have thinking about thinking, and so on and so on and so on ad infinitum. Now, what's actually really interesting here is we as humans don't spend a lot of our time on the first level. As academics, we actually spend a great deal of time on the second level because we're trying to design minds, right? And we have brief flashes of inspiration on this third level, but we don't operate in this space very often. And in fact, anything beyond that, we can repeat this, but it is extremely painful, and it's arguably not very useful for humans to operate at higher level spaces. We don't know for sure. But, and then also from Artificial Intelligence, a Modern Approach, Russell and Norvig, they define a partial spectrum. They start at the very bottom rung, the least possible intelligent agent, right? Which is basically a lookup table, but can still produce complexity. And then they move on to like an architecture with a knowledge base. They use predicate logic, but anything could be used. And so they define sort of the first steps of the spectrum where the artifacts produced are the same, but the cognition happening under the scenes is actually different each time. So we get to this sort of spectrum that we've been defining here. A long time ago, most of the creative programs were predefined processes, very simple algorithms, maybe some formal logics to deduce something. And we are trying to shift the burden of cognitive responsibility off of ourselves onto the programs. And we are entering an exciting era in our field where machine learning and the semantic web, being able to scrape the web, there are so many ways now we can have the programs themselves gather the knowledge. So knowledge acquisition, we are starting to shift off of ourselves onto the programs. And that helps the perception and possibly the reality of autonomy. So self-learned fitness functions, self-learned aesthetics, we've experimented with this before. And arguably, if we follow that same spectrum, the next natural result would be to shift the cognitive load, not just the knowledge, but the decision-making process onto the computer itself. Now, I don't say self-defined process because that's extremely difficult for a computer to simply spontaneously appear, but self-refined process. There's been a little bit of experimentation with this as well. So once we can shift more of the cognitive load, the mind, off of ourselves, as well as the knowledge, we might be able to push towards this autonomy. Now, one thing we should consider is this Chinese room argument. Are we going to be forever bound by this idea that no matter what we do, our programs, no matter how complex and how mindful and intelligent they become, they are simply mindlessly manipulating symbols? And this is a very difficult question. So as we move from sort of this first order to thinking about thinking, to thinking about thinking and thinking, what's interesting is that the Chinese room argument still does apply. You could argue even this very advanced machine is still just as susceptible to the Chinese room argument. That's not going to go away. But the proposition is that the Chinese room argument is only useful to certain orders. Just as we can't operate very well on the third or fourth or fifth order of abstraction, perhaps it is only useful to argue the Chinese room argument up to a certain point. And so we can use this to drive our progress forward in the field towards more autonomy, but we don't have to keep applying the argument ad infinitum. That might not be actually useful. Now, we don't know what would happen if we did. That could be an interesting research question. But that is the general idea, is that as we move towards greater autonomy, there will be an entity that will be easier to attribute creativity to, rather than us, the programmers. And also, the big question is, will it actually improve the true creativity, or is autonomy not necessary? All right. Are there any questions? Yes?
Yeah, so I noticed that the three sets of people you asked were all somehow skewed towards technical fields.
Absolutely, yeah.
Have you done any work or considered looking at how artists respond to the questionnaire?
No, that would be an excellent question. Yeah, that would be an interesting, particularly because we're sort of invading, in a way, these fields of these people, right? Yeah. And no, we didn't do any work on that. Yeah, that would be an excellent... Yeah, it would be nice to, and that's part of our social responsibility too, is understanding how are we impacting. We're introducing new agents into these fields, right? So how does that actually impact the field? Yes?
The effect where as people retook the test, they got higher scores?
Yeah.
Is that something that happens in all tests?
I actually don't know. That could be, that actually might be a bias then. Yeah.
I don't know either, but I just think that might be really good.
Yeah, that actually would. There's a slight, this is totally anecdotal, but the what people said after the test, we actually asked them a little more casual questions afterward, and they seemed to be breaking down different barriers as they went. But yeah, there might be a bias there, totally influencing that. Yeah.
When people were talking about autonomy, did they ever mention
Embodiedness?
embodiedness?
No, that actually never came up. I was surprised. But yeah, that's actually, there's another philosophical point about that too, and that's an interesting discussion as well. Yeah.
I'll ask another quick question.
Oh, yes, please.
Quite different. You made the claim that we don't want to be creatively responsible for the products of our systems. That was a theme of the survey.
That is definitely an assumption. If that's not true, you can tell me.
What if an artist was an artist and their medium was code? That's a legitimate artistic practice if somebody wanted to hold that.
Yeah.
Then that artist would say, "Product of this is exactly what I wanted, and what I was." All of these productions are in fact evidence of my own creativity.
I see. Using it as incorporating as part of that. Yeah.
There are artists.
There are use cases for that where people do want that.
Artists whose actual mode of creativity is that.
Yeah, absolutely. Actually, so that was a bit of a gross overgeneralization, for sure. Yeah, there are definitely use cases where people want the machine to be part of their creativity, and as well. Yep.
Before my proper question, just to comment on that, I mean, that's a question of what is the definition of computational
Right.
creativity.
We aren't going to go there, but yes, we could be here for hours. But yes, you're right. Yeah.
So I have a similar thing, which is about distinction between consciousness and intelligence.
Yes,
so there's
yes.
a huge problem in the whole of that debate, going right back to Turing about what is intelligence and whether Searle's argument is an argument about consciousness.
Right.
About intelligence. And we can perfectly well do creativity without consciousness, in my opinion.
Yes.
We can't do aesthetics without consciousness.
That's an interesting discussion.
We can simulate them. We can predict what humans
Right.
We can't actually do aesthetics without consciousness. That's where we start.
I think you're going to be interested in this next talk, actually. There might be a few hints in that direction. Yes. Oh, sorry. You had your hand up first.
Two comments. One that I think it was Bob Williamsky around 1980 who proposed that you have just two metacognitive levels. So there is planning and meta-planning. So there is no third and fourth level.
Oh, I was unaware of that.
The second level recursive learning.
Oh.
If you express the second level in a language, in a particular kind of language, it is still recursive,
Yeah.
then you need just two levels. So that's one thing to mention.
Oh.
I think there's an interesting debate between professors and students of computational creativity.
Yeah.
My students build programs, AI agents that are creative in some manner.
Yeah.
I am more willing to ascribe creativity to them, but students are never willing to ascribe creativity to them.
Well, why do you suppose that is? Is it just because they work directly with it and they feel, I don't know.
They always ask the question, I programmed it, so how could it be creative?
Mm.
It's sort of a self-defeating way of thinking about it.
Yeah. And that's actually an interesting debate in and of itself. And that may be something holding us back, perhaps. Yeah, absolutely. Sorry, there was someone, you had it. And then.
I've got a question from the stream.
Oh.
Simon Colton wanted to ask, were there any people who clearly didn't want the software to be creative?
Yes. Oh, yes.
Okay.
Yes. There was a few. Absolutely. One of the definitions of creativity was not a computer. So, and there was a lot. There was a few people that actually tied that into human emotion. Was their rationale was because they don't feel it's capable of human emotion. That was their reasoning why it could never be creative. So there were definitely some people who were quite firmly entrenched in that opinion, for sure, but not too many.
I might have another stream question in a sec.
Excellent. Okay, and then there was one more hand back here, and then over here. Never mind. All right. Yes.
So the academics, how many of them are computer science versus other disciplines?
Actually, they were all computer science, so it was a very, very specific field. I picked computer science because I wanted people who. Come on now. Did I just go right past it? There we go. Okay. So I wanted computer science because in my naive mind, I imagined there would be a progression from people who knew more about technology, knew more about code, knew more about the potential of what code could be. That was clearly not the case. Indeed. Yes?
Is there a higher standard for computers to be creative than for people?
Yes. I would say yes. Now, this is somewhat subjective, but yes. We are willing to ascribe creativity to crows, even though they only operate on the first level. Oh, yes. Do you have a comment about that? Or? Yeah. Okay, you seem to be. But yeah, there's absolutely a higher level of resistance, and that's not necessarily a bad thing. I think it helps to keep us progressing in the right direction if we have a lot more mental resistance to overcome before it happens. But yes, there's definitely a higher standard for computers, I believe. You had a question?
So I was wondering whether it's been considered looking at it from an evolutionary perspective.
Oh.
Programs can make other programs.
Right. We're starting to get to that point.
And I mean, how much of this sequence do we keep taking credit for?
I think you might actually enjoy the third talk then. We're going to get into a little bit about the chain of responsibility and how far it goes, right? So that's actually a very interesting question. Yeah. There's someone else.
Just a comment on that idea of the higher standard. I think in people who don't study creativity, there is a tendency to conflate the trait of creativity
Yes.
with the act of creativity. And when we talk about creativity in, say, a child produces a painting, you're like, oh, it's really good. She or he is being creative, right?
Right.
And they're sort of talking about development of the trait. And no one talks about the trait in a developmental context, or that child is creative.
Yeah.
About a software.
That's interesting.
It doesn't live, it doesn't experience, it doesn't grow.
Right.
On that same scale.
Yes.
So I'm not sure, but that seems to be one possibility for this standard.
Yeah, and it's somewhat of a double standard too. But that's actually quite interesting. Going back to the parent and child analogy, that's very similar. We do have different biases when we evaluate human creativity. And especially, I don't know, it seems to me that the less we train, the more we train these machines as sort of an entity that already exists, the more easy it will be to ascribe creativity to it. Now, again, that's the ascription, not the actual creativity, perhaps. But, yeah. Another stream?
Another stream question, yeah. Do you think it's possible for a player to interact with an AI in a game and not be aware that it's
An AI?
an AI? And not just, so do you think that we'll ever get to that stage, I guess is what the question is.
Oh, I think it's I think it's already possible in small amounts. What's interesting is I think it's easier to pass the Turing test in a video game than in real life. Quite a bit easier. Video games are actually a really interesting medium because they can... People are willing to suspend their disbelief quite a bit more and willing to ascribe details to the program rather than the programmer, even when bugs happen, you know? So it's an interesting social context there. So definitely easier. All right.
Okay, if there are no more questions, then thank you very much. A truly excellent opening talk for the conference.
Here's your talk.
Thank you so much.
Right there.
We should talk later.
Oh, absolutely.
The next talk will be by 9.
Sorry.
Generation code.
Oh, thank you. Yeah, very good. I almost stole the show there.
Hello. Just clip myself up. Right. How are we doing? All good? Okay. Hello. I apologize in advance. I didn't have enough breakfast and I had too much coffee, so this is going to be much more jittery than it was in my hotel room this morning. My name is Michael Cook. For the next 48 hours, I'm employed by Goldsmiths in the University of London, part of their computational creativity group here. I'm giving a talk on Wednesday. I'll have a different employer then, but the same name tag. And yeah, so this paper has such a long and convoluted title that even I couldn't be bothered to fit the whole thing on here. The first part is generating code for expressing simple preferences. And then I thought that was not good enough, so then I added a subtitle, which was moving on from hard coding and randomness. But this was the title my heart wanted to give the paper. I've got a good feeling about this. And I'm going to tell you about some work that I did about getting software to make decisions. And there's a few disclaimers I want to put first, and I realize that copying out on the second slide of a talk is not good practice. But honestly, this is a difficult paper to present. I can't remember what slot I submitted it into, but the reviewers, by the way, whoever you were, if you're in the room, I really appreciated the reviews. Some of them were like, why have you got all this discussion here? Like, just get rid of the discussion and tell me more about the practical stuff. You didn't put enough. And then the other reviewer was like, why are you telling me how you implemented this? I don't care. Like, there wasn't enough discussion. So this talk, I want this talk to be interesting, and I didn't want to dive too much into the paper. So if you want to know how I wasted several weeks of my life, feel free to read the paper. But I've tried to keep this light and kind of more focused on the discussion, and I hope it'll be more interesting that way. So with that said, we want, this is not, like when I say this is controversial, not all the statements are. We want our software to make decisions. That's not a controversial statement. That comes later. And our software make decisions all the time. So for instance, if we want to paint a picture of Broadway, we might want to make huge decisions about how we represent it. This is Mondrian's Broadway Boogie Woogie, and this is a painting I found on Google Images of Broadway. And clearly many decisions were made in rendering these the same subject in different ways. Important decisions that have massive creative context. And sometimes these decisions have really interesting motivations behind them. And they form kind of the crux of our papers, and they're really important decisions. And I was thinking of an example for this, and one that came to mind was Tony Veal's metaphor magnet, which has very interesting justifications for why it chooses a word or why it makes a connection between two words. You should definitely check out Metaphor Magnet's Twitter rendering, but it's also got an amazing website and a rich tool, and there's lots of interesting reasoning going on there, lots of interesting decisions being made. But sometimes our software makes decisions where we don't actually care what decision it's making. We just want it to make some kind of decision, right? So, for instance, lots of the time, software might produce, for example, several poems or several artifacts that are all above a certain quality level, and then it just wants to return one of them. So which one does it choose? And there might be no real reason to choose between any of them. So there are papers where they just randomly pick one, for instance. At that point, we want the software to make a decision, but we don't have a good reasoning for it, or we might not have developed it far enough that it can reason well. And I think I wanted to identify 4 particular ways in which we solve these kind of tie-break situations that I'm going to go through now. And I'm going to tell you why I'm not so keen on them. And I'm guilty of all 4 of them, by the way. So this is not picking out anyone except myself. So the first and most common way of making our software make decisions is, obviously, we flip a coin. We use math.random. Perhaps less common in this conference, but certainly in game development, when I'm making procedural generators for games, you need to make a decision. Flip a coin. Is the coin, if it's a float variable, is it less than 0.36? And then that's fine, right? Because you're making a decision one way or the other. You don't really mind. If you don't mind, then why should the computer mind? So that's fine. This isn't so common, but in the paper I point out that many ICCC papers, even last year, made references to random decision making. Like they just tossed a coin. Then there's what I call inspired randomness. I doubt this picture is very visible, but it's a robot reading a newspaper. So one version of Angelina read the Guardian newspaper as inspiration for some of its games. And some of the information it got from the Guardian was useful, and it was actually used meaningfully in the games. And other information was kind of, we dressed it up. Like it looks like, the nice thing about Angelina reading the Guardian is because I could wash my hands and say the decisions it made didn't come from me because I can't control what's in the Guardian. But really, I'm just using the Guardian as a noisy data stream. It's another kind of randomness. It just looks nicer, right? It's easier to frame. So that's another way of breaking tie-break situations when you really don't care about something. Then, of course, this is the common one, and I imagine many people in this room will have done this. Inherited heuristics, right? So you sit down and you say, well, you're making a piece of artwork. I want this artwork to have a vibrancy of 0.4, because I've looked at all the different vibrancy variables, and I've decided that 0.4 is kind of, that's what a photo should look like, or a painting. And we've all done this, and many of us do research in domains that we ourselves practice in. So I'm a game designer in my spare time, and so we all have ideas of what these artifacts should look like, and we kind of slip these in. Sometimes we don't even realize we're slipping them in. Sometimes we quite rightly do put them in because we want them to be there. And finally, the crowd. Oh, sorry, that's the wrong image. There we go. We ask the crowd for answers sometimes, and one version of Angelina asked Twitter what it thought of people in order to gain an opinion about people. Angelina doesn't have an opinion about Obama, so Angelina's going to ask Twitter what it thinks about Obama. And again, this is me washing my hands, right? Because, well, the opinion didn't come from me, and it came from lots of people, and that's where people get their opinions from, So therefore, it's okay. Tie-break situation. Do you like Obama or not? Whatever. The number of headlines about Angelina's opinion about Theresa May, who's a controversial politician in the UK. But, it's meaningless. It was derived from the crowd. Why are these unsatisfying? And here's the subtitle for this slide. I don't have, this is just, I'm just telling you why I think these are unsatisfying. You may disagree with me. I haven't done a study. But here's why I think they're unsatisfying. There's a number of reasons, but here are my top ones. You can't interrogate any of these opinions to understand them better. If you toss a coin or use math.random to make a decision, no one can go back and understand why that decision was made. You can't give it examples of similar decisions to make and see how it makes them, because there's no context, there's no continuity. They don't form a long-term pattern of behavior. If you come in one morning liking Obama, and then the next day you come in and you don't like him, and there's no justification for it, there's nothing I can read into it, I feel like I'm unable to understand you. And this is exactly what Angelina was doing many times. I should point out, sorry, Angelina is a piece of software. I've said this so many times in talks that I'm tired of it. I'm so sorry. But it generated games. It's okay. They don't form a long-term pattern of behavior, which is what people like. That's how our decisions gain meaning. And people don't like to see behind the curtain. And by behind the curtain, I mean both the software's curtain and their own. They don't like you to tell them that your opinions are actually meaningless junk, and they could be your opinions could be replaced with a random number generator. They don't like that. So that's not good, and which is fair enough. And they don't super much like to know that Angelina is just taking its opinion from somewhere else. It's not satisfying. None of these, there are many other reasons, but these are the things I feel quite strongly about. So we end up coming to a kind of an impasse where we don't want these opinions, these decisions, these preferences to be random, because that's obviously unsatisfying. But where do we get opinions if not from randomness? We need to get them from a human somewhere. So either it's me, in which case I'm putting myself in the system, or it's all of you, in which case I'm just copping out and just letting everyone else decide as if that makes it better. Either way, we're opening ourselves up to the criticism that someone else has given the software the opinion that it has. Wouldn't it be great if we could generate opinions somehow? So they're not random. Like we could actually just generate this kind of nebulous, I don't know what an opinion would look like, this floating mass of gas that was an opinion about something, but it didn't come from a human, right? So it would be that it came out of nowhere, it wasn't random, but they're still like believable and satisfying, and it forms a pattern of behavior, and we can read into it and understand what it's trying to say. Wouldn't that be great? It would be great. The paper claims to have taken a first step on the road towards doing this. That's how I'm going to phrase that. So it doesn't go quite as richly as generating opinions about things, and my last slide talks about that a little bit. But what I look at is preference. Preference between two things of a similar type. So for instance, coffee. I use comparators as the basis here. So if you ever, your favorite language probably has them. You give it two objects of a type, and then it makes some decision, and it returns -1, 0, or 1, depending on whether it likes the first, depending on which ordering they should be in. It's really ordering, but I'm phrasing them as preference. So if the first coffee's milk is less than the second coffee's milk, then I prefer that. Otherwise, I prefer the second coffee. So I like my coffee not to be very much milky. And if I don't care either way, it's a 0, right? So could I generate code snippets like this that represent preferences over politicians or coffee or pizzas or philosophical beliefs? And wouldn't that be great? And yes, it would be great. And you'll decide whether I've actually done it or not. So the reason why I think this is good is that you can interrogate code. If I tell you that Angelina prefers Obama to Putin, and it was decided by a random number generator, you can't ask about Angelina's opinions about David Cameron. But if it's a piece of code, you can pass it other arguments. You can say, well, do you like this coffee more? Or do you like these two coffees that I've just made? And over time, you can understand this opinion on a more deep level. Rather than just knowing about one decision that it's made, you can ask it to make multiple decisions and understand the more nuances element. So maybe if you put sweetener in a coffee, it instantly rejects it, even if it has much less milk in it. And you can only work that out if you can interrogate that opinion somehow. So then we come to this problem of if you want to generate something, how do you tell it what to generate? Which is, you may notice, is slightly circular. So what I'm going to tell you now is what a good opinion looks like. And if there are kind of warning signs going off in your head at this point because I've used the word good and opinion next to each other in a sentence, it's okay. It's okay. I'm not going to tell you what a good opinion is. Here's the crux of the paper, right? I'm going to claim that good opinions are opinions that are defensible, right? So to give you an example, some people don't like pineapple on a pizza, and some people do. And whether or not we agree with each other, we can argue, we can at least accept that both ideas are defensible, right? There's no logical inconsistency there. There's no kind of flip-floppity, you're tossing a coin whether you want pineapple on your pizza today. Like we can kind of understand that some people like pineapple because it's sweet, and some people don't think that should be on a pizza. And there's a sense that this opinion can be defended even if we don't agree with it. So I'm not claiming that one opinion is better than another in terms of what it actually says about the thing that it's comparing. We want to look at opinions on a structural level and look at what they say about the class of objects that they are expressing a preference over, right? Now, in the paper, I present a few metrics, which I then go on to use in a kind of evolutionary system that evolves bits of code. And I don't think it's interesting enough to put in a talk. So I'm going to skim over the metrics briefly, so you can get a feeling of the kind of metrics that I used and why I think they're important. Then I'm going to show you some examples, and then we will probably cut to discussion, I think, because I might be over at that point. But please go to the paper if you want to learn more about them. I didn't want to massively, horribly overwhelm people. So the first metric is specificity. So remember that if a comparator returns 0, it means that the two things you gave it, it doesn't matter. It doesn't have any preference either way. So let's imagine we had 100 politicians, and we asked our software to tell us which politicians they liked more than others. If for 99% of the pairs it returns 0, this is very, very unspecific. It doesn't really care either way. It barely has an opinion. So very high specificity means that it can really richly order every single politician. Like, it can tell you exactly which one it likes more than the others. I want to point out, and I'll point it out again in a few slides, that high specificity or low specificity is not good. It's just a metric, right? You might want very low. I actually used very high in the examples that are in the paper. But it's just a metric that lets us say something about this comparator, this preference function. The second metric is consistency. So does this preference hold transitively, basically? If you like politician A over B, you know what transitivity is. Now, again, the interesting thing about consistency is that not all opinions are consistent. And the example that came up a lot when I was working on this was voting. When people vote for politicians, their preferences are rarely transitive, because politicians are very complex. Like, there's lots of policies you might agree on, and they represent parties and they represent ideals. And you might vote for someone you really don't like, but it's very important to you, this one aspect of them. So again, consistency might be really good for some things. I'd argue that in general we like our opinions to be consistent over things like coffee and pizza. But there are many interesting cases where you might not want consistency. It might add a bit of nuance to the opinions that we generate or the preference functions. Now, the third one is a little bit weird, because if I asked you, do you like pineapple on your pizza or no pineapple on your pizza, and you gave me an answer, and then I said, okay, do you like no pineapple on your pizza or pineapple on your pizza, you'd look at me a little bit funny, because you just asked me that question. But because we're generating code that has parameter orderings, I've had to introduce this metric called reflexivity, because, yes, this is the kind of work I do if you're seeing me for the first time. One of the reviewers was like, and I really appreciate it, one of the reviewers was basically I just imagine them shaking their head as they wrote the review and be like, look, this is okay, but why didn't you just abstract this out? And the answer is because I'm lazy. So basically, this metric prevents the generated opinions from having a dependency on the ordering of the parameters. And in general, this one needs to be high. So I've weighted it very highly. I don't think you'd want to weight it very low if you were using these metrics. We can talk about whether this is an indicator of a healthy system or not later. So as I said, you can weight these metrics, especially the first two, however you wish. There's a fourth metric in the paper which is interesting, but I don't want to talk about it because it complicates things. It's called agreement. If you want, please ask a question, and I'll use some of the question time to discuss it. But so they're not good or bad. They're just ways of thinking about opinions. Like, do you want this opinion to be extremely specific? It kind of shows that the software really cares about this thing if it can express a preference over anything you give it. Or maybe you want it to kind of be a bit more vague. You want it to see a bit more carefree. I don't really care what color paint I use for the sky. I wasn't in that kind of mood today. And, thank me later, I didn't tell you about how I painstakingly got Unity and C# to generate code on the fly and compile it and then reinsert it into the thing. And I just... If you really want to talk about it later, I'd be happy to, but it's not riveting stuff. So I want to show you some results. And before I show you some results, I really want to be clear about something. How am I doing for time, by the way?
You've used 15 minutes.
OK, fantastic. I really want to be clear about something. That I'm generating code, technically, but what's really interesting is the functional performance of the code, right? So if you want to look at the code, the results look a bit like this, because the software does not know how software engineering works. It doesn't know how to write code. I've asked it to, and again, one of the reviewers was like, why did you do this? Because I'm going to show you some preferences, and there's going to be unreachable code. There's going to be conditions that don't make any sense. You're going to love it. It's great. But the point is, functionally, this code runs. And if you squash all the compiler warnings, it's great. It's fine. So here's a really basic one. This compares two numbers. We do more interesting examples, I promise. So if I is less than or equal to j, return -1. then there's a code that doesn't execute. Then otherwise, return 1, then there's some more code that doesn't execute, and then 2 more codes that doesn't execute. But if you ignore that stuff, then this sorts numbers from smallest to largest, so it prefers smaller numbers over larger numbers. This is a bold claim. But, and then you get slightly weirder ones like, if I is less than I, okay, so I don't know that. If j plus I is less than j, so, and then I really have to think about what this even means. So this is if I is negative, then prefer it. Otherwise, return j. This actually wasn't a particularly high fitness one. I just wanted to show it to you as the kind of strange code that it produces. Kaz is dying in the background there. But so then I just wanted, for context, this paper got rejected last year, and I thought, why? And I thought maybe those examples weren't the best. So I went for one that was a bit more exemplary this year. So what if we compared colors? So color, let's say we've got an RGB object with an R value, a G value, and a B value, right? So ignore this code. I'll show you this in a minute. This code doesn't actually relate to this image because I made this slide at 2 a.m. But the top row of colors are randomly generated and randomly ordered. And the second row of colors are ordered according to a generated preference about colors. These are least preferred and these are most preferred. And the preference, you might be able to see a slight preference here. It's a preference for colors with more red in. And I quite like that. I much prefer it to the code. And it's not bad. It's not earth-shattering. But what's your favorite color? Mine's blue. Why? I don't know. It's arbitrary, right? But I've got a favorite color. If you ask me, if you show me some mugs or posters, I'm probably going to pick one with more blue in. This one picks ones with more red in. And again, we'll come back to this in the last slide. I'm not suggesting this is the new wave of decision-making and computational creativity. What I'm arguing is that it's a replacement for math.random. This is, again, some very funky code that says if this is not related to this one, but if the red value in J squared is greater than the I value, the red value in I, then perform an ordering line. So you get funky ones, but once they're visualized, you can kind of forget what this code is because you start to think, well, okay, and now imagine if you could give this more colors, if you could interrogate it and propose more colors to it. Bless you. And in the paper, there's a couple more examples where I had more complex objects, so objects with Boolean fields and some strings and stuff, and they represented monsters in a game. So I had this idea that you'd have this game designing thing, and it would say, okay, in this screen, I'm going to have monsters that have lots of health that are kind of hard to kill. And then in the next screen, what am I going to have now? Maybe some poisonous monsters, and that'll theme. Because Angelina would have to start from arbitrary decisions. And I wanted to be able to frame them. And this is, I believe, the first step towards doing that. So there's some more examples in the paper with some more illustrations. But this is my favorite one, because I think it's simple, but it shows you what it can do. So I wanted to go over some things that people might be thinking right now. I'm sure there are more questions, but just a few topics before I collapse and or pass it over to questions. So first of all, is this kind of a bit disingenuous? Because I've used the word opinion about 25 times, and some of you have looks on your face that really suggest that you did not like me using that word. And I appreciate that. We're in the business of perception, of course, and in the paper I point out that there's precedent in ICCC papers where we say, in theory, if the software wanted to lie to people, that would be okay. That's an acceptable method of framing as long as it's convincing to people. And in a way, I don't even really think this is particularly deceptive. If anything, it's potentially the opposite. Some people have told me that they'll never believe software is creative, going back to Martin's talk. They'll never believe that software is creative because ultimately they can always ask to see the code. But at least in this case, there's actually code to see. Whereas if I'm just asking Twitter for an answer, no one can go and ask the software more questions or look at it or understand why it made a decision. But here you can look at it. You can show it more stuff. I think it's actually less deceptive. But maybe it requires people to kind of reassess their expectations of software because these opinions don't really come from anywhere, which leads us on to my favorite reviewer comment that was negative, which was, if these are arbitrary, then they're random, right? So you just said you wanted to get rid of randomness, and you've replaced it with something that is random. Now, my argument here is that being arbitrary is not the same as being random. Being random means that there's no pattern, there's no consistency, they can't be followed. These are actually incredibly consistent, some of these opinions. They're arbitrary in the sense that my favorite color is arbitrary, but they're definitely not random. They come from a random place. They come from who cares where. But randomness is the thing that people find ugly and they don't really like. These are actually not very random at all. They don't have much meaning or basis. It doesn't have a particularly passionate reason to prefer red over other colors, but it's definitely not random. But I do appreciate the sentiment. It's not coming from anywhere, which leads me on to a point in the last slide. And finally, well, these aren't opinions. Why do you keep using the opinion word? I actually relaxed it slightly in the paper. I refer to them as preference functions more, which is a euphemism meaning, please publish this paper, and I promise to stop saying opinion. But I'm sorry, it's brutal honesty. Because I just like the opinion. Opinion's kind of a shorthand, and I know, opinion is a very strong word, and it's kind of semantics, but semantics are important to some people, and I do understand that. But I don't believe these are opinions. I don't believe the software likes red in the same way that I like blue. This is really important, and I want to hammer this home because I don't want you to think that I'm making really grand statements here. Lots of the papers that you're going to see over the next few days are interested in raising the upper bar of computational creativity and showing new things that software can do, new heights, new reaches. I had the complete opposite. I wanted to raise the lower bar. I was sick of having math.random in my code, and I just thought if I could just replace this with anything better than this, then I could allow the software to talk about the code. If it fails a preference check, it can tell you where in the code it did it. It can tell you which condition statement caused it to say, I don't like this. And this provides new opportunities for framing even trivial decisions. So I want you to know that I'm not trying to make grand claims about subjectivity in computational creativity at the highest level. I'm making them in the lowest level. I just wanted to remove the coin flips from my own work. As a man once said, who's not here in the room today, but if you remove all the reasons why your software is viewed as uncreative, then the only thing that can be left to say is that it is creative, perhaps. And certainly, those 4 things that I showed you earlier, math.random, reading from Twitter, those are the top reasons why people said to, Angelina is not creative, it's garbage. It's just taking its opinions from elsewhere. This is my last slide, you'll be glad to know. So here's the skinny. I can generate some code to replace math.random in my code. And it replaces things like inherited heuristics from myself, maybe as well. It's domain independent. If you can give it an object defined in C#, it can produce an opinion about it. However, that's in theory. At the moment, it's ugly, it's hacky, it's brutish, it's everything that my work is. But it does work, but it struggles. It struggles for more complex objects. If you give it an MP3 file, if you give it an image, it's not going to produce anything interesting yet because it needs more work, it needs more explanation. But I think there's something here. I really do. And now I'd like to know your opinions about it as long as they're specific and consistent. Thank you very much for listening. Geraint.
So I have a problem with your use of the word random.
Okay.
Which I think is imprecise. There we are. It's consistent, but it's imprecise. So you can have biased randomness, which leads to consistency, because certain outcomes are much more likely than others. That's what Bayesian networks are based on when they have consistent outcomes. It seems to me what you're doing here is implementing a kind of hobbled Bayesian network, which only has extreme probabilities in it. I think, why aren't we all doing that? I suppose. Apart from anything else, in cognitive science, there's an increasingly prevalent feeling that that's exactly what humans do, nearly all the time.
Interesting. I will say, by the way, that they seem to be very trivial and kind of extremes, but I'm hoping that in time more nuanced ones could be developed. But again, very, very bad system. Needs to be better. Thank you. That was cool. Joe.
I just have a question that's sort of more lower level, below the
cool.
bar. So that it's about the programming language itself, and the idea. So I've been looking at a programming language that really distinguishes between values and states. I've got the terminology correct, but anyway, the concept is, I might prefer, say, Barack to Hillary, but that's just today. Tomorrow it could be different, right? And it's very contextual. So I think it seems like you're perhaps going a bit on thin ice if you look at these comparators and you don't evolve them and evolve the world at the same time.
Yeah, it's interesting. Or maybe there needs to be some metadata carried in the system so that it's not just the things that you're comparing that you pass in, but maybe there's some kind of context object that gets passed in as well. Yeah, definitely interesting. Mostly I didn't worry about that because the opinions are so trivial. It's like RGB colors. But then even that can vary depending on what mood you're in. Yeah, it's interesting. By the way, if there are any stream questions, I'll answer them via Twitter or email later. But yeah, I don't know. I think Aaron had his hand up briefly.
So you say that people don't like randomness, but in games, I prefer to win every game, but I still play games that have shuffling, and I don't want to win every game of solitaire, and the reason why is that it's not interesting otherwise.
Yeah. So the distinction I'd make is they don't like randomness in decisions which should be, or in humans would be, motivated by some reasoning. So if I played solitaire, if I set up solitaire for you, I'd shuffle the cards as well. But in Civilization, when you meet a civ for the first time and they randomly decide whether they like you or not, actually that's a bad example, they don't, but let's say that they did, that feels really useless. Whereas if they decided that they didn't like you because they have a preference function that says they don't like civilizations that value money, that's way more interesting than just randomly deciding whether you like me or not. So it's about whether you think this decision should be motivated in some way. Some randomness is fine. Some randomness we don't mind. Then there's kind of middle ground where, like making a dungeon, there's no human behind that in theory, but actually we consider the process of design to be a creative decision. So maybe we would want there to be preferences, this dungeon's really, windy, and I guess the designer liked that. And we kind of identify that in human designers. So maybe we would expect that in artificial ones too. I don't know. Gillian?
So it's actually a really interesting question on the stream from Alex Champagnon.
Uh-oh.
I know.
Hey, Alex.
So he asks, you mentioned that software can explain decisions. How is decision spectrum actually done, knowing that there may be challenges in generated code like multiple conflicting return statements?
Right. Good spot. That I may have made that claim too strong. In the paper, it's technically under future work. So I want it allows in theory in the future for us to analyze this code. And in particular, I'm really interested in verbalizing the meaning of code. So here's a piece of code. Now tell me what it does in English. That's a super hard problem. But right now it doesn't do that. So right now all the interpretations are from me. One thing you can do that's quite interesting in theory right now is I could make a little game where you have to try and work out what kind of color or monster or politician this thing likes, and you have to keep giving it things until you can work it out. And maybe you could use that to crowdsource definitions of these. So people describe what they think the opinion is, and then you kind of compile them. I don't know. But yes, I don't currently do it. Sorry, Alex. Trust you to mention that. I really hate picking. I think you...
So as far as the decisions being justifiable,
Mm.
as far as I know, and I'm versed in the literature there, humans, a lot of their decision making kind of happens backwards. They make a decision and then justify it afterwards. And perhaps we could make computers, make random decisions and then come up with justifications for them.
That is an excellent point. So I'm going to repeat it. So the suggestion is that actually maybe random decision making is okay as long as you have a system after the fact that can justify it, because there's some thought that that's actually what humans do. And that's an excellent point. And actually, there's some computational creativity people I've met who've suggested that we do exactly that. It would be okay if a software just randomly did everything as long as it could find interesting justifications afterwards, which I think is cool. For me, I partly wanted this ability to kind of interrogate and be able to actually, So the one thing that people love doing when you show them a software, and I guess Martin came up across this, is they want to try and break it. So this gives them an opportunity to try and do that, and it's kind of more robust. Also, I think it's interesting though, and I think I want that stream to be explored as well, and I'd love to explore it as well, because it's like a really massive linguistics problem.
It seems to me like there are probably both kinds of what you're describing and then sometimes humans resort to.
Yes, definitely. I think also part of it for me is that even though that may be how humans reason, it's not the way we think we reason. And if you, of course I don't. I had very good reasons for doing X, Y, Z, and how dare you say that it was arbitrary? So it's kind of like, I think a lot of computational creativity, it's already been said, it's a bit of a magic trick, it's a bit of an illusion, and it's also kind of pandering to the public and stroking them on the head and saying, it's okay, you're a special flower, and I've made the computer just like you. It really thinks about its decisions before it makes them. It's not a random collection of neurons just trying to survive in a chaotic system. It really means something, and so do you. And I feel like that's what we're doing a bit, but I think that's okay. I think that's okay because AI is deeply ingrained in sociology and culture and how we view technology, and I think that's okay. I think that's part of our job, if anything. But thank you, that was cool. Are we still okay for time for questions?
Yeah, sure. We can have a couple of more.
Yeah? Kaz?
So my question is a little bit like Joe's. The role of experience in that, anecdotally, amongst people I know, preference for a ham and pineapple pizza seems to depend on whether they were exposed to combinations of sweet and savory foods as a child. So people seem to have preferences that evolve from what they know, and some people may be interested in trying new things to varying degrees, but for some of us, some things are just beyond the pale. For example, insects are eaten by the majority of countries in the world, but in the West, we kind of shy away from the idea of eating insects, even though we really like lobster.
Don't spoil the banquet before we've announced it.
So the point here is that these are experientially grounded preferences. How could you incorporate something like that in a model like this?
Well, funny you should mention that. I say the first way I'd like to do it is actually what was suggested here, which is to justify it after the fact, which is to generate an opinion that has a structure to it, and then if they say, well, why did you want to do this, then we kind of make up something, if necessary. The alternative was the thing I was saying about, Stream, I'm going to attach this and pass it over, was the thing that I was saying in the talk about maybe people might have to change their assessment of how they think about software. We might have to think, well, actually, this software has an opinion. It's not the same as mine, but I know where it's coming from, and we might change our estimation of what it means for software to be created. But that's a long process, and it requires massive cultural change as well. Thank you all ever so much. You were very patient.
Mike, thank you very much. We move on to the last talk in this session. Ollie will talk about attributing creative agency. So, please.
Hey everyone, thanks. So we've had no dud talks so far. Let's see how we go. I really enjoyed that talk, Michael. I put my question on Twitter in the tradition that you've established. This is a position paper, a discussion about the nature of creativity. What a ridiculously bold and slightly exhausted subject in this conference, but I'm still at it. Let's go back to the title. So, attributing creative agency, are we doing it right? It's generally, I'm looking at this very broad topic of what the nature of creativity is, and I'm particularly interested in the kinds of properties of machine creativity that are important in the design of computation and creative systems. So I'm going to do this so that I can read this. Another thing I'm interested in is what assumptions we carry over from thinking about human creativity to thinking about computational creativity, and how does that manifest itself in our work in the way that we think about designing systems and in evaluating them. And I'm sorry, I want to do one more thing and just change this to... That's better. So I wanted to frame this like this. This is something I've been thinking about as long as I've been thinking about computational creativity. Imagine that you could actually do this. You could take every idea and you could do a full, extensive literature review of all of the things that made it possible. That's the kind of thing that I think we don't explicitly often say that we're interested in doing that, but it's quite inherent in the way that we talk about attributing creativity to humans, machines, whatever. So more generally, you might say that any artifact, many artifacts embody ideas, or even just acts, human acts or machine acts, came with a full diagram of all of the interactions that led up to that. So this isn't in the paper, but I came up with this today because I thought this needs to be captured clearly. So it's God's royalty statement. In other words, if you're a musician and you get royalties for a piece of music, you're familiar with this process of getting a royalty statement. If you got to heaven and God's there with a giant list, and he or she was dishing out the royalties for all of the creative acts you've done, how would God break this stuff down? That's the kind of thing that I think implicitly we do actually think we can do in the attribution of creativity. So we might draw diagrams like this where we've got a bunch of human established things. This is probably a terrible example. But you've got agriculture, and from that you have different things stemming from that. Beef and cheese, beef tartare, fondue are kind of derivations of those. Sometimes they come together, so a cheeseburger combines these different facts. And the take-home message, if you kind of glaze over and forget everything I've been talking about, the take-home message of this talk is that the inventor of the cheeseburger was standing on the shoulder of giants. I'm interested in art, and this is mostly about artistic practice. And so just to throw in an example to kind of ponder, if you take, there was an interesting kind of standoff between the electronic music band Ohrtecker and the computer music composer Karl-Heinz Essel. And Karl-Heinz Essel makes Max patches, and he argued Ohrtecker had downloaded one of his patches and they'd hacked it and they'd used it in one of their albums. And in a discussion forum, he said, "You've used my Max patch, and so you should credit me for that. That's only fair." And one of the members of Ohrtecker replied, "Why should we? Bands don't credit the makers of their instruments. Do you expect us to credit the Big Bang?" Which is a bit of a dismissive response. But there's an interesting idea there. Again, coming back to God's royalty statement, this is basically a non-human agency. Do we include these kinds of processes in the crediting? Oh, sorry about the colours. So it's true that bands don't credit the makers of their instruments, and in the case of a Max patch, a computer program that contains musical knowledge but is also an instrument, you've got this grey area, you've got this ambiguity. And it's this kind of ambiguity that is the area of interest, particularly for me in this discussion. So we can take any musician and we can think about various things that influence them. We could say Brian Eno was interested in prog rock, but he was also interested in African rhythm, and these things came together in various ways for him. But there are also these other types of influence. This is a physical thing, but it contains human knowledge as a certain type of synthesizer, and maybe other types of thinking that come from outside music that he was interested in. So we are all these complex combinations, and they don't fall easily into categories, which is the point that I'm going to keep repeating. This is probably my favourite, the most description of making music that has most connected for me. Nick Cave, he said, making music is all about counterpoint, putting two disparate images beside each other and seeing which way the sparks fly. Like putting a small child in a room with a Mongolian psychopath and seeing what happens. Then you send in a clown, say, on a tricycle, and again you wait and you watch. And if that doesn't do it, you shoot the clown. I don't think he chose Mongolia for any particular reason. It's just somewhere far away. Don't take offence if you're Mongolia. So here, I'll explain why this is interesting in a second. But the general point I'm making is that here's maybe how we'd like to think of this neat structure of influences feeding into outcomes, creative outcomes. And of course, the reality is that these categories are extremely jumbled up and there's no consistency. And in fact, I would say that they're more of a kind of big amorphous blob or blur. So I'd say that God's royalty statement wouldn't be very clear. There is no clear diagram that we can draw. It would be a continuous function of some sort, and he'd have a lot of trouble paying out those royalties. So to put this another way, this bit's actually in the paper. Just like Michael, I've been off on a tangent ever since I wrote it. We know that creativity is incredibly fluid. We could say granular. We could say that it operates at kind of an infinite number of granularities that we can't always keep hold of. But we don't have a language or an algebra, maybe, if we like to think mathematically, to manage this. And this is a problem. And what we do is we box concepts. So we frame things in terms of discrete categories. And that seems like a perfectly necessary and fair thing to do. That's good reductionism. That's what we're supposed to do as scientists. But the question I really just am trying to pose, and most of this paper is just posing questions, not really providing answers, is what are the pros and cons of maybe taking a more fluid approach or thinking about how we can take a fluid approach towards this problem, so this islands of creativity problem. So just to repeat, when I say are we doing it right in the title of the paper, what I'm really saying is do we have the best terminology and set of concepts for even beginning to talk about attributions of creativity? And I'm thinking, roughly speaking, that at one end you've got boxes which are easy to talk about and they're relatively terse, and you've got at the other end some kind of fluidity which is, arguably more accurate but verbose and potentially endlessly complicated to deal with. So I suppose I have to actually make the case that this is a problem, and I'd say yes in kind of traditional studies of creativity. So I particularly reference Simonton in the paper. where he's very much focused on the multi-human population-based stochastic process of creativity working across the population. And he's got interesting studies of scientific creativity and the ways that randomness plays a kind of important role in specific individuals making creative breakthroughs, and the same can be said in art and so on. In a similar vein, Perkins, who I just particularly like a paper that he's written where he makes this lovely metaphor between creative search and gold mining, where you don't, you dig in one place, you find some gold, or maybe you don't, but that doesn't give you any clues as to where to look next. It doesn't. There's no kind of smooth function or anything. And it's a very similar observation that he makes that basically we need to spread bet when we're being creative. We need to search in multiple places. We need to kind of take a stochastic approach. And sometimes quantity is actually really important to creative achievement, like leading to quality. And I've written about this, and I've tried to suggest that actually we need to think about a type of creativity called generative creativity, which is actually a lot less to do with value. And I'll talk about that a little bit later with an example. But I'm basically talking about a kind of creativity which is emergent. So if the best metaphor for that is to think of creativity in the sense of the Earth's biosystem evolving over time, creating structures without any decisions being made, without a designer. So I'd say yes, it's a problem in the actual study of human creativity. What about in the evaluation of creativity systems? I'd say yes again in terms of particularly captured in the use of language, such as saying a system does something on its own. And at that moment, making an attribution of creativity, which this phrase boxes a really large amount of complexity that we can gloss over quite quickly. So this is my creative effort for this talk. To heighten this phrase, whenever you read it, here's an anagram, "Oh, not news." It's not quite, I didn't quite get the anagram right, so the only one I could find that was actually worked with the correct spelling was "Oh no, twins." Just think of that, and that might bring you back to my paper when you see it on its own. And I'd say it's a problem in system design. I think there's a danger of designing for an imaginary target, which is some kind of enlightenment concept of a creative individual. And we still have many questions to ask and answer. And I think I'm not saying people don't ask and answer these things, but I think that it's a monumental task to unravel this whole issue. And what is the relationship between a creative human and their mentors, tools, benefactors, audience? And the purpose of this talk is to throw in a few ideas about how we might think about that. And this is obviously really important because if we don't know it, we can't model it. So are we true to Simonton and others when we conceptualize the design of systems is one way of just summarizing some of that. So the main focus of the paper is to look at two areas from other disciplines to draw on that are just put up there as things we might think about. Again, I'm really putting these up as just as questions. Is this potentially useful? I'm making some kind of argument to say it is, but you decide. But I'm just throwing these possible ways of thinking about creativity in there. So one of them is I've put it under the heading of becoming, but there's many other ways you could describe it, and I've just kind of captured a few quotes from various thinkers that capture this idea. So basically, it's an attempt to unbox the categories. You could say the nouns, and switch to kind of more of a verb-based thinking about creativity, and that comes up in some other ways in this talk. So from objects to processes. So I was reading about Buckminster Fuller for some reason the other day. And he has this nice quote, I know that I'm not a category, I'm not a thing, a noun. I seem to be a verb, I'm an evolutionary process. So he's thinking about himself as a continuous process of becoming rather than as a thing. Doug Hofstadter has loads of writing about this kind of thing. he has a book called I Am a Strange Loop. And more grounded in in philosophy, Nietzsche was big on this idea of stepping away from an object-based way of thinking of things as being to things as becoming. So he quotes, I'm going to say that wrong, Heraclitus, the whole flows as a river, or being is an empty fiction. So we should think in terms of process rather than fixed form. And the other theme is networks of agency, which is something that it's very well established in social science, and it's something that's, I think, increasingly popping up in the computational creativity literature as an important influence on the way we think about creative process. So generally an agent is, I like really simple definitions, so this one suits me, something capable of having an effect on the world. The most famous contributor in this field is Bruno Latour, and as a popular example, you can compare these ways of thinking about the agency of objects. You could say that we need to ban guns because guns kill people, and in this kind of, he analyzes this debate in America where the response to that is it's not guns that kill people, guns are just passive objects, they don't have agency, it's people that kill people, so we just need to tell people to stop doing that, please. You choose. Latour analyzes this and he says, well, okay, this is really unnecessary to kind of have this divide. We can think of a gun plus person, gun plus people network as a complex that you need to understand in its entirety in order to really analyze how people end up getting killed. So guns affect people. If you don't like someone and you have a gun in your hand, that might change the outcome of that situation. People also affect guns. People clearly have, well, actually I'll wait till the next slide before I say that people clearly have agency. So we can think of we don't have to get caught into this very weird situation of saying that objects actually do things on their own. We can think of actually these clusterings of systems as being the agents rather than just the people themselves. And that's, I think, an important point which has been hugely popular in the social sciences. So following in this vein, with a slightly different way of treating this subject, Malafouris says, sorry, there's some quite big quotes, and I know it's annoying having lots of text, so I'll read it out. If human agency is, then material agency is. There is no way that human and material agency can be disentangled. Or else, while agency and intentionality may not be properties of things, which I think everyone agrees, they are not properties of humans either. So he's saying that actually you can't have this privileged bias. I mean, obviously we live our lives and observe other people, and we assign agency and intentionality to these things, but at a formal level this falls apart. It just doesn't work. You can't pull the elements apart. The example he uses is a potter making a pot, and he's interested in the clay and the wheel as being fundamental to the ultimate outcome of the pot, which you have to read it. It's a good paper. So he's saying agency and intentionality are the properties of material engagement, which is this kind of process rather than thing, and that's where we need to look to find the production, the agency that brings the pot into the world. So it's the grey zone where brain, body, and culture conflate. And in a slightly more pop culture way, Grayson Perry, who happens to be a potter, talking about art, I got this from a podcast that I was listening to on the way over here. The true craftsman allows the material to kick back, which is kind of like what Nick Cave was saying earlier on, that you're putting things out there and you're allowing physical, non-human processes to be a part of what you're doing. And just one more angle on this kind of mass of ideas that's swirling around here is a concept that's run through anthropology in various ways, which known by different names, but One kind of quite catchy idea is the idea of, as well as being individuals, we can also be dividuals, which just simply means that we don't maintain neat boxes around individual humans. We recognize fluidity in the way that we constitute ourselves as objects or as actors. And this actually comes from a cross-cultural analysis. So originally from Marriott, who's looking at the differences between Western and South Asian conceptions of people, and he identifies that they don't necessarily conform to a Western idea of individuality. He also says the common sense form of that we understand ourselves to be individuals, but as a individual, you are divisible. It's not always convenient in terms of social construction to see yourself as a unit, but as something that can be broken down. And I've not quite identified where the term porous has first been used, but I quite like the idea of, just in a similar way, of an individual being porous, so being capable of being the product of a network of interaction with others. Okay, so that's all fun and tantalizing, but where does that actually get us? So a couple of examples I discuss. Thanks. So I've probably done this in the wrong order because I should summarize all of that, which I do at the end. So I'll just jump to this example and then summarize. There was an interesting paper that came out last year looking at violin design over time. And the authors were proposing, it was hard to see whether they'd really got the evidence in to support this, but they were proposing that actually the F shape that you have in the body of a violin, which amplifies the sound, there was very little kind of active human design in the evolution of this shape. But over time, different workshops kind of varying the designs of violins, the result over time was that the sound approached that, the shape approached that common shape that we know, which is particularly well optimized for amplification. And the authors are suggesting that actually this happened just as Darwinian evolution happens. In other words, someone kind of makes their variant of the violin, and over time that one's successful, and someone else makes their variant, and that's not successful. They weren't looking at the formulae and thinking, how do we design the most amplifying sound hole? Take it or leave it, the paper's quite interesting to read. It's hard to see whether they're making a really good case, but I still think it's an interesting example, tantalizing example of how we can have an outcome that is clearly value-focused in a certain respect, but without the actors involved necessarily being consciously engaged in that value process which is going on. And then I discuss, so that's just an example of everyday human non-computational creativity and thinking about how that needs to be exploded in terms of looking at the actors and how they interrelate in networks and so on to form creative outcomes. And the other example I just briefly discuss, it's a fairly arbitrary choice. I work in the area of musical meta-creation and improvising musical systems, and I discuss Arne Eigenfeld's improvisation that happened 2 years ago in London with an improvising musician. It's pretty much an arbitrary choice, but just to identify a single piece and discuss that process. And this is very vague and hand-wavy, but the way that we look at that final outcome actually involves quite a complex story of the programmer, the musician, the developer, the system, the content, all interacting in these ways that might be analogous to that description by Malafouris of the potter creating an outcome. So generally speaking, I'm just saying that there is a lot of unpacking to do around that kind of core question that we tend to ask, which is what's the level of creativity of the system? It's not usually that simple. So we might single out certain interactions between things such as the developer and the system during the actual performance itself, the musician interacting with the system being a co-creative practice where so that's an example where process is kind of commonly recognized to result in the creative outcome. It's the interaction between, in an improvised context, the interaction between the music and the system is what leads to the actual outcome. So that's less ambiguous. But we have other things like the content actually playing a role. So I use a lot of audio samples and recordings in my system, and they feed in to those creative outcomes as well. So this is where it gets really murky, because I have to then conclude and say some really intelligent stuff about what I think we should do. And paper, maybe next year I'll with some positive feedback from people, nearly done, I might get there. But I am just asking questions, I'm just posing questions. But one thing, borrowed from anthropology, I think that this field, highly interdisciplinary though it is, involving humans necessarily in our understanding of computational systems, rich description, which is basically the highly qualitative, non-reductionist approach to analyzing a set of interactions in a creative context, can be a useful tool for what we're trying to do. That comes from social anthropology, but it's emerging in interaction design. So it is something that's recognized and being used in studying relations between humans and machines. So you can look at Darish and Button, who describe how this is useful in interaction design contexts. So I tried to throw in, these are not in the paper, but I tried to throw in some actual suggestions. And I guess I'm proposing a dual reductionist and non-reductionist approach, because I think that most of the kind of mathematical work in computational creativity is fantastic, and yet could be supported by additional rich descriptive approaches. So perhaps the catchphrase should be, can you be more vague, please? And some more tentative principles, just banging through these because the bell's ringing. No, I'll just leave these up and then you can ask questions. But remember the take-home message, the inventor of the cheeseburger was standing on the shoulder of giants. Thanks. No questions? Kaz, of course.
I wanted to ask about that interesting sounding file in the paper. So you mentioned that this seems to have, the design of the present shape seems to have happened over time. Do they get into when people realized that certain shapes were effective? I mean, so the evolution process, let me clarify that a bit better. Let me try and be more vague. The evolutionary process has no mechanism by which to recognize that particular structures are effective. It just keeps doing them because they keep working. Whereas networks, which include humans, definitely do. At some point, someone looks back and goes, whoa, this S shape is killing it. Let's stop doing the others. How do you feel that that person should be attributed to creativity? Is a recognition of something that comes out of a complex system a creative act? And how does it compare to the evolutionary process that generates?
Yeah, so I think that's an important question. That's an important question about cultural process, creativity at the cultural level. And yeah, I'm sure that some people were thinking, they didn't just switch their brains off and put shapes of wood together, they were thinking all of the time. And so it becomes a dangerous argument, dangerous area to be arguing entirely for that evolutionary process. So yeah, I'm sure, I mean, the facets of the human mind that contribute to creativity are many, and being able to recognize that something's good is obviously absolutely critical. The only reason I'm interested in that point is to say that there are ways in which a design can come about without a designer, which is obviously what evolutionary theory stated about the world, and there are many evolutionary theories of cultural process and so on, so it's not that radical. I just thought that was maybe, depending on what the jury says at the end of the day about that evidence, that's maybe a good example to work with. Yeah. Yeah.
I guess it's starting out as a comment, so it may be a question mark later, but the comment is I like the reference to South Asian cultures, and I want to just amplify and say that I encountered some really interesting work by a guy named James Leach, who you may also know his work, but he talks about how in a certain Papua New Guinean culture, the idea that humans are created by their parents and their village and other kind of informing things. Wow, that's cool. We don't usually think of ourselves as being created. And they go on to kind of describe what it's like a raising, instead of just giving birth or whatever to the child, you have to raise it as if it was like an agricultural product or something. So I wonder if that kind of flipping the script, there is a question in there. I wonder if that kind of flipping the script and looking at ourselves as created beings, but not just from God, but also from our culture and the place we're in, that could help to decipher the steps by which we also can create other kinds of beings, non-human entities.
I almost didn't perceive the question, but the comment's great. I think the question, I just say I agree. James Leach, actually, I studied with him, so I did an undergrad anthropology degree. I'm a fallen anthropologist. I can't remember most of the things I read. I certainly can't remember anything he wrote. Yeah, I don't know. I definitely didn't just answer the question, but I'd love to discuss it. Yeah.
I kind of want to answer on your behalf, I guess. You had a quote up there that said, the true craftsman allows the material to kick back. That's kind of what a parent does in general. They interact with you, and it's kind of like this feedback loop where, you didn't learn the lesson that you're supposed to, and the parent kind of interacts with you. So like allowing the material to kick back. I don't know.
Yeah.
And,
I think I'll go back to something that's, because so much anthropology is really hard to read when you're coming from an engineering background or something, but popularist though it is, I think that Douglas Hofstadter actually has some really eloquent ways of discussing those sorts of subjects as a popular read. But then, yeah, there's a lot of philosophy as well. Okay.
Okay, great.
Thanks.
Thank you very much. Thanks to all the speakers. We now have a coffee break, and we'll continue part with the next session, which will be on evaluation
I guess so, I assume so.
Okay, so let's begin our second session, evaluation and marks, and I'm going to hand over to Ashok Goel.
Thank you very much, Anna. My name is Ashok Goel, and this is my colleague Darren Badwell. We'll do this team presentation, so we'll both talk. We were having dinner yesterday, and Darren doesn't drink, and I got drunk. So we agreed that I'll do the easy part, he'll do the hard part. So this is a joint work with 4 of our colleagues, David Joyner, Chris Graham, Warren Lemon, and Oscar Martinez. And I will talk about each person's contribution as we go along. So I'm going to set up the background. We all perhaps have come across the Raven's test of intelligence. You may have taken it yourself. This is a very famous test. It was first introduced by J.J. Raven in about 1932, and it's supposed to test adductive ability, the ability to make sense of complex situations. It's a very good test of what Spearman calls general intelligence, although these problems deal with only visual analogy. The correlation of success on Raven's test is excellent as compared to other intelligence tests. So here is an example of a 2x2 problem. The Raven's test consists of 60 problems, 24 of which are 2x2 matrix problems, and 36 of which are 3x3 matrix problems. Here is a simple example of a 2x2 problem. I should mention this is not directly coming from the Raven's test. The Raven's test is copyrighted. So all of our examples have been inspired by Raven's test. When we actually do our work, we run them on the real Raven's test, but I cannot show them here for copyright reasons. So here are 6 choices. You're given by a 2x2 matrix. You have to pick one of the 6 choices that will complete the matrix. So which one do you think is the right one? Okay. Here is an example of a 3x3 problem. Any suggestions? All right. 3 is the right answer. So people take this test, and we wanted to build AI programs that can take this test. Now, as you can imagine, people have built computational models of AI, of human problem solving with Raven's test. Perhaps the most famous model was built about 1990 by Patricia Carpenter and Marcel Just and their colleagues. And they the basic scenery goes like this. You have a problem. You extract propositions out of them. So here is an example of some propositions. These are just about shapes. You can also have propositions that express spatial relations. For example, on, left off circle triangle. So the circle is left of triangle. And then you have various kind of rules. These rules look at the input image, the propositional representation of the input image, and induce which rule must be active. Then that rule is applied to the third row, and a choice is made. And that's how you solve the problem. This is the most popular conventional model of human problem solving in the Raven's test. Now, actually, there are a large number of strategies involved in here. You could, for example, first construct an answer. So for this 3x3 problem, for example, you could construct an answer based on the 8 entries that are known. And then you can compare that answer with the various choices, see which choice is closest to your answer, and select that as an answer. Alternatively, you could do something completely different. You could pick one of these 8 choices and put it in the matrix and see whether the matrix makes a sense or not. Whether you can explain why this matrix makes a sense. And so you could both go forward or backward. Actually, a very large number of such models have been proposed. All of these models have used different strategies, but they have one thing in common. They all use propositional representations. So one question that becomes is, what is the relationship with creativity? Where exactly does creativity lie here? Does the creativity lie in the visual thinking? Because there have been theories about how visual thinking is a central pillar of creativity. But wait a minute. Although there is thinking going on about images, there is no thinking in images. The thinking is in propositional representations. Is the creativity in analogical reasoning? There have also been proposals in computational creativity that perhaps analogical reasoning is a central process of creativity. Yes, there could be some creativity in analogical reasoning. But there is a third potential source of creativity, and that is metacognitive ability. And that argument goes a little bit like this. So Kirby and Lawson, about 1983, these are psychologists who study psychometry about human intelligence and human creativity, suggested the reason the Raven's test is such a good test of intelligence and creativity is their term, I'm not just introducing it here, is because there are so many strategies that are applicable to it. And Keating and Bobbitt in 1998 suggested that the reason this is a good test of intelligence as well as creativity is because it's hard to decide which strategy to use when. That the creativity lies in being able to use one strategy, perhaps not seeing that it doesn't work and switching to another strategy. So creativity can have large number of sources here. Now, before I go further, a couple of acknowledgments. What I'm going to say next is the work of Mathley, Kunda, and Keith McGregor. I'm going to specifically talk about Mathley's work right now. In fact, the next few slides are coming from her presentations. So I want to talk about mental imagery. So I'm going to leave aside propositional representations. I'm going to talk about a completely different kind of representations that we do with mental imagery. So some of the current theories of cognition say that here is the perceptual apparatus, and some visual pathways lead to our understanding of images of the kind of visual inputs I showed you to construct deep representations of long-term memory. These deep representations are propositional in nature. Now, when we actually use these representations to solve problems, we either take them to a verbal short-term memory or to a visual spatial short-term memory. In the verbal memory, they are still propositional in nature. But when we take them to visual spatial memory, something changes. The representations are not propositional anymore. The representations now in the visual spatial short-term memory, when we're actually using them, have an iconic character to it. They use affine transformations. So here is an example of an affine transformation. So here is an image of a cat, and you can translate it, rotate it, scale it. So now completely different set of operations and different kind of representations. Here are other operations, set operations. You have two images, A and B. You can combine them. And here was A and B. You can not only just take the intersection of them and the union. So this is the intersection. Initially, I showed you the union. You can also take differences. So this is A minus B, the color in violet, and B minus A, the color in blue. So an alternative way of doing problems on the Raven's test could be not to use these propositional representations that have been proposed earlier, but to use this visual, computational mental imagery. Here is visual similarity. And the reason for doing some of this is we all get this idea very quickly. Are you, when you're doing all of this, actually extracting propositions and then comparing propositions? Or is there something more basic going on, which has to do with visual similarity? So using this idea, Mathley, and as well as Keith later on, proposed that perhaps we could do something different. Let's remove this propositional extraction thing. And at least in the visual spatial short-term memory, we're going to operate on problems like this using just these iconic representations, affine transformations, set operations over pixels. And they actually wrote a program, and the program did very well. Out of the 60 problems, it got 50 of them right, which is comparable to the best other AI programs which use propositional representations. The only ones it did not get right are shown in black here. So in the A set, it got everything right except for the 11th one. Compared to human beings, so this now comes to the sort of evaluating creativity side. These are the human norms. So this is the 95th percentile. This is the 50th percentile. This is the 5th percentile. This is the number of problems somebody is getting right on the Raven's test. This is age by years. These are typically developing humans. And this particular algorithm that uses just thinking in pictures, not only thinking about pictures, but thinking in pictures, is able to do as well as a typical American 16-year-old. So this was an attempt to show that there could be alternative strategies. Last fall then, we decided to conduct an experiment, and Darren will tell you more about that.
Can everybody hear me? We don't have to hand off the microphone there. So the Georgia Tech University, they launched a new program.
problems here. What we actually saw was that was the median and the scores were actually much higher. These agents performed much better than they had anticipated. So really a lot of strong, very creative solutions to draw from this. So what I'm going to show here, and you don't have to dig into the numbers, obviously, but this is the different types of problems that we had. The class average, and then we pulled out 4 specific agents that performed exceptionally well and also had a novel approach to solving these problems, and those are the results they have there, and they were significantly above the average of the class. And that's where I come in. I am agent number 4, if you're curious, and the other agents are online. They're hopefully watching on the webcast here too. So now what I wanted to do is take just a minute or two and talk about the approach that these 4 agents that we pulled out take. And so the first agent, as Ashok said, the most common method to solve these problems is to extract a propositional explanation of the problem, then solve it using this propositional representation. And that's what this agent was the best performing at that. And the key point about this is that the agent started off with a library of known shapes. And these shapes had, so it was circle, square, had angles of symmetry, corner counts, things like that. And it was able to recognize shapes based on this known library that it had. And then it did a couple of different passes to actually apply reasoning to solve the problem. And I'll talk about these in the context of a problem right here. I stuck with a 2x1 problem, so it's a little easier to see. And this one is a non-intuitive answer because what most people would, the intuitive answer would be that you're deleting the inside circle. So in frame C, you would delete the inside triangle, and you end up with a big square. You don't see that as a possible answer, so the agent has to creatively come up with another solution to this problem. So the propositional representation here, once again, you don't have to dig into the details, but this is what it extracted from the problem. Each one of these frames has different elements and the propositional representation of what those mean. And then it applies this reasoning to it. So it first does this, what Warren called a top-down pattern recognition, where it takes some simple transformations, affine transformations, to the propositional representation, applies it, sees if there's an answer there. If there's not, we have to move on. In this case, there was no simple answer because the problem itself is not intuitive, right? So then it moves on to this bottom-up analogy, and this is where it compares all different combinations of object mappings and applies rules to that. And as you can see, it was able to come up with the right answer by mapping the small circle to the large circle there. Then it was able to complete the transformation over there to get a large triangle. Agent 2 was very similar to Agent 1 with one big difference, and that was where Agent 1 had this library of known shapes, Agent 2 didn't. It built everything, its understanding based on the problem there. And then after that, it would still extract a propositional representation and a reason based on the propositional representation, but I'll show you what that looked like. So given the same problem that we looked at before, first it isolates out the different shapes that it sees. They're shown in different colors, and then it groups them together based on measurements and characteristics that it sees. So for example, here, it's grouped all circles together the same color, all triangles, all squares, and it doesn't know what that shape is. It's shape 1, shape 2, shape 3, but it knows that they're the same. And after this, it's able to apply the same type of propositional reasoning that Agent 1 was. And as you can see here, down at the bottom, it calculates what its ideal answer is, and then in red is where the selected answer doesn't quite match, but it picks the best one. And you can see this one's 73%, great, we'll pick it, and it happens to be the right answer. So Agent 3 is where we depart into purely visual reasoning. And this one, Oscar wrote this agent, and it's fascinating the metrics that he used. So basically what he wanted to boil down the visual representation into meaningful measurements and metrics that he could use to compare. And he chose this dark pixel and intersection pixel ratio. And based on that, he can go and find an answer. And this is actually the best, if not one of the best performing agents in the whole class. So what do we mean by dark pixel and intersection ratio? So we can see here, we had to use a different problem. The problem we were using before didn't really illustrate this well, so we put a different problem in here. But we can see if we are comparing frames A and B, in red here we have the intersection pixels. And from that he calculates a ratio. For the dark pixel, he basically takes a projection onto the x-axis of both these images, counts the total number of dark pixels, and then if you can see there's a little red, that's the difference, in that he takes that as a ratio. So how does he solve the problem with this? He, using frame C, he calculates the same metrics across all of these answers, and as you can see, this problem here lines up very closely with the metrics that he used right there, and that he calculated between A and B. And based on that, he was able to get the right answer. Once again, he has no idea what shapes are in here. He's just taking metrics based on the pure visual representation. And it was very, very well performing for that. Finally, the agent 4. This was my agent. My goal was to do a hybrid approach where first I tried to, and this actually was based on what my 7-year-old daughter would come in there when I was working on the program. She would stand behind me and she'd look at it, kind of scratch her chin, and then say, I think it's that one. And so I was trying to kind of see her thought process, and what she was doing was looking for these affine transformations on the high-level image, and that's really easy to do. It's real cheap to scale and rotate an image. So I first tried that, and if that failed, then I'd go and like Agent 1, I'd pull out a propositional representation. So how did that work with this? This is back to the problem we were using for the first couple of agents. First, you try to put some affine transformations in there. Didn't work. We didn't find anything. So we had to move on and pull out a propositional representation. For that, what we did here is, given these two frames, there was two possible ways that you could map the objects between frame A and frame B. Only one of them yielded an answer. You select that answer, and it's the correct answer. So the agent has to be able to explain why the answer is right. And that's where the creativity comes in, because it's not an intuitive answer when you look at the problem itself. So with that, I'm going to pass it back to Ashok for a summary.
Thank you. So one thing that Darren did not mention, I'll add to that, is that the students who are taking the online OMS CS program, online master's program, are really high achievers. Their average age is 40. They are mostly professionals in the industry, in all kinds of industry, including information technology. And these are very, very bright students. I will say these are the brightest students I have ever met, and I've been at Georgia Tech for more than 25 years. So these are exceptionally good students. And that is really important to note, because we will soon talk about human computation, and so that point is going to be important. But to summarize, these 4 agents are using different strategies. The first agent is using propositional reasoning, more or less the way you would expect it, performs very well. Second agent uses propositional reasoning, but it generates the representations. Instead of beginning with an ontology of various kind of spatial primitives and shapes, it generates them at runtime. The third one uses visual reasoning, more or less like the kind that I showed you when we were talking about Mathley's work. And the fourth agent combines them. So now we have 4 agents. Actually, since there were 224 students, we have 224 agents. One important question in computational creativity is, where are these creative strategies coming from? You and I can sit in our labs and we can create some creative strategy and put it in a machine. But it's just your and my creativity. Here we have an enormous resource. By now, this class has been taken by about 750, 800 students. By the end of 2015, it would have been taken by more than 1,000 students. We'll have 1,000 AI agents solving the Ravens problem, written by high achievers. There's an enormous resource here. So one way of getting access to creative strategies is to do human computation. But you can't send it to Mechanical Turk. You have to have access to really smart people, really creative people for tests like this.
And so now we have a resource. When we build these programs, we always ask ourselves the question, how can we build a program so that we can teach our students well? But perhaps the question should be flipped. How can we build a program so that we can learn well from the students? So there is an opportunity here. So I'll conclude now. So there are sort of three sets of conclusions to be made here. One set of conclusions is there are many strategies for solving Ravens. The literature on the Ravens test in AI and creativity and cognitive science, I think, is very impoverished. There are only a few strategies there, and they all sort of repeat here. But there are a large number of strategies. And it's not just the contents of knowledge and the control of processing which are important. The modality of representation, whether it's propositional or visual, is also very important. Third, some of these strategies are based on computational mental imagery, and we have perhaps not, as a community, explored this mental imagery as much as we could. Fourth, creativity perhaps lies not just in visual thinking, analogical thinking, but also in the combination of visual thinking and analogical thinking with metacognitive ability, where we are selecting, suspending, switching between various strategies, as Agent 4 did. One way of dealing with how do we acquire all of these strategies is to do through human computation. I've already made that point, but the requirement there that if you're going to deal with a creative task, then you have to have human computation with extremely creative people. And in the online Masters of Computer Science program, we have access to now more than 3,000 high-achieving people. And so the question is, how do we make use of that resource? Thank you. Michael?
I had a question about what this work may have told you about the Ravens test itself. Because I think presumably, like when humans take the Ravens test, there's many more things than just taking the Ravens test that can do, and presumably the Ravens test is sort of like an indicator that's pointing at broader aspects of my mind, in a sense, where when there's these programs that are specializing in the case of the one where it's just like collapsing the black bits on the bottom, that sort of strikes me as kind of like hacking the Ravens test in a way. And so I was just wondering if you have any thoughts about sort of reflections about the test itself, or thoughts about where these programs might go, or maybe there's a thing unrelated to the Ravens test they do, but somehow they use the same like visual competencies, like the outline transformation stuff, to also pass the Ravens test, or if there's anything along those lines.
Yeah. There's sort of several questions in there. Let me see whether I can address some of them. One is that the Ravens test itself is, although it's completely visual analogy problems, it's supposed to be a good representation, a good measure of general intelligence. Now, of course, what exactly is general intelligence? There are robots which are playing soccer, so one could say that part of general intelligence is the ability to play soccer or to be able to move in the world in an embodied manner, and that's certainly the Ravens test is not capturing. So there are a large number of dimensions of intelligence and creativity. Another aspect of the question you were asking is that some of these strategies appear to be sort of programming tricks in a particular way. So they may not be very good reflection of how you and I are solving problems on Ravens from a cognitive perspective, but as an AI strategy, they are still useful strategies. And one question that becomes is, can we as a community now build an AI agent that can learn from all of these creativity strategies? So we now have 1,000 strategies for using Ravens test. And this is perhaps for the first time in the literature on computational creativity, there are 1,000 strategies for doing any one thing. Can we now design a creative agent that will learn by itself? This was coming in the first talk where sort of self-refined strategies can come into play. A third possible interpretation of what you asked was whether the Ravens test is, whether it's showing us, or what these strategies are doing, whether it's showing us something about human cognition itself, the use of visual thinking and mental imagery. And I don't know the answer to that yet. That requires a lot more thought.
Okay. But we don't know how our mind processes these visual images. It could be close to collapsing the pixels at the bottom, right? I think at the process, we don't understand how that works, and this could lead us to my understanding along those lines.
So I sort of feel like, continuing on that same theme, one other direction we could go from this is deriving a better Ravens test, which is to say, we could derive a variant on the same sort of analogic reasoning that human beings do indistinguishably well from the previous version of the test, but that confounds a lot of these AI agents. Have you moved in that direction at all?
That's a very good point. Let me build on that in a particular way. You know, before we wrote programs for doing Raven's test looked like such a hard test. Will my program even be able to solve 5 problems out of 60 problems? Now we're building AI programs to routinely solve 55 or 58 problems. Raven's test is no longer that challenging. So the question now becomes, this is sort of, we're constantly changing the milestones for AI and computational creativity, old problem. So what you're suggesting is, could we build a harder Raven's test so that these strategies would not do as well?
That's close to what I'm asking. Okay. What I'm really asking is, can we make a program, a test that is comparably difficult for human beings and harder for these programs?
Yeah, fair enough. Yeah, good direction to look at. Okay.
It's actually quite close to what I wanted to ask, but from the other side. I wanted to know whether, given this large library of agents that solve Raven's problems, do they tend to get the same problems wrong as humans?
We have looked at error patterns. So it's not just a question of accuracy. It's also a question of what the error patterns look like. So we have not done this work. So I'll have to go back to Mathley Kunda's work now to look at the error patterns. So let me zoom out for just a second, and then I'll come back to what you're saying. So the origin of Mathley's work was beginning with cognition and autism. It is a fascinating finding for people with autism. People with autism do very poorly on most intelligence tests, but they do brilliantly on the Raven's test. And many people with autism also claim introspectively that they think visually, which is why she started on this particular line of reasoning. So now to come back to the point you were raising. One question here is that I have now lost my train of thought. Remind me of the point again.
The agents get the same questions wrong.
Yes. So she compared the error patterns of typically developing humans and people with autism as well as her algorithm, the affine model. And what she found was that for the various kind of errors, so the errors that people make in classified in various categories, so there were 6 major categories. For 4 of them, her computational model provided a pretty good explanation. For 2 of them, it did not. So there is some work of that, but we have not replicated that work for all the agents and the students in the classes.
Okay, I think we'll have to move on, I'm afraid. And if David would like to come up, thank you very much.
Am I good? Am I okay? All right. Okay, I'm David Norton from Brigham Young University. So I'm going to be talking today about a survey we designed to evaluate our system, Darcy, that stands for Digital Artist Communicating Intention. The idea here is, as with many of you, we have an agent that we want to be able to evaluate, primarily so that we know when we've made an improvement or a version change on our agent, if it is more or less creative. This is a common problem in the field. We want to be able to iterate, right? And we want to be able to compare. And we're doing this in a domain, visual art, that is subjective and a little amorphous, and so it's very hard to do that. And there are many evaluation kind of methodologies out there in the field that many of you have developed that all have their strengths and their weaknesses, and we're introducing a new one and we will present its strengths and weaknesses. But first, I have to start talking about our system, Darcy. This system is a visual art system designed for very specific tasks right now, at least this particular version. And that task is to take a photograph and, given any adjective, render that photograph to match that adjective. And the catch is to do it in a creative way that we define specifically to mean it is sufficiently different from the source image, the source photograph, to be considered original or novel, and that it is sufficiently similar to be functional for the task at hand, right? Which is we want to keep the source there. So those are kind of two tasks. We want to be able to do this, and that's a creative task for this particular problem that we will be evaluating later. So really fast, I'm going to go over how the system does this. Okay, I just want to see what kind of time I have. Okay, so Darcy has three components primarily. I will start by talking about this component here. First, the system learns to identify what features in an image will match a particular adjective. And we use kind of social learning. People go online, can train it by labeling images, and we train neural networks with positive and negative examples for that adjective. So the output of the neural network then becomes the fitness function for a genetic algorithm used in image rendering. So we call it a commission when we give Darcy a photograph and an adjective. And for the commission, we run the genetic algorithm, and after X number of generations, we pull from the commission the top candidates. So this is not the end, because we want we want Darcy to return a single image. We want it to curate its images and not have the human involved in that process. So it's building a candidate pool in this step. The candidate pool takes, again, like I said, the best images, and it removes duplicates. It guesses what a duplicate is based on the feature vectors that we use to train the neural networks and comparing them to one another. If they're within a threshold, if they're too similar, then we throw them out. So we're building this candidate pool. Now, we perform this genetic algorithm. We use about 100 generations, but we perform this genetic algorithm many times. We call each time an epoch, and each time we constrain the problem more and more. So this falls on work by Mikado done the earlier 2000s. So future epochs of our rendering step involves a novelty neural network that is trained using positive data points for the adjective and negative data points that are the candidate pool we are building. So the next generation, we're getting images that satisfy these criteria but are novel relative to what the system has already produced. And we do this over and over again. For our experiments, we ran 8 epochs. And this gives you some examples of how the results are changing over time. So the idea is now we have a big pool of different images to pull from. So finally, we curate. And we use a very simple inherited heuristic, if I'm using that term correctly, Michael Cook. But so this is, again, to achieve our goal. We rank the candidates by how similar they are to the source. Using a different similarity metric, we use bags of visual words, histogram of bags of visual words, and we compare those. And then we take the top 10% of those images, and then we re-rank those, again, by their adjective score from the neural networks. And the top scoring image becomes the artifact that Darcy has produced for that commission. So that's a commission. And now we want to know, okay, so in the future, we have lots of plans for Darcy. You'll hear about some of them. Are we getting more creative or not? So in this space of creativity evaluation, there's a lot of challenges that we face. Here I've kind of outlined 5 categories of challenge that I think we have to address when designing a evaluation methodology. So the first, we have to pick or design the methodology. And like I said, many exist. we are presenting our own methodology here, and it is based on a human survey, a human kind of a mechanical Turk almost. The advantages to that are that it's relatively easy, relatively simple to get a lot of data. So if we're interested in the opinions of a broad audience in order to get our evaluation, then it's one of the most effective ways to do that. It has a lot of weaknesses, a lot of flaws associated with it, and we try to mitigate those in the designing of our survey. So we hope that our survey design that we present can be extrapolated and changed and used by others in other domains. Okay. So I'm going to design kind of the overall flow of the survey and talk about how we address each of these problems. And I'll describe them as we come to them. So first, we were very specific in how we described the problem to those participants taking the survey. The problem was very specific. This was our source image, and we looked at 3 different adjectives, cold, eerie, and violent. And then we had, in order to create kind of a baseline to compare what human evaluations meant, we had human artists, in addition to Darcy, create artifacts, and then we compared the two. We had 4 human artists, each producing an image for these, and 4 artifacts from Darcy. So I'll just quickly show you so you know what images there were in the survey. Each participant was randomly given one of these images from each of these categories. So they were given 6 images to evaluate to avoid survey fatigue. So here's the eerie images produced by Darcy, and the eerie images produced by humans. Violent by Darcy. Violent by human. Okay, so you get the idea. Now, we need, in order to be able to compare versions of Darcy, their results, we need a measurable assessment. And we need to empirically ground ambiguous terminology. Right? Creativity is ambiguous terminology. If we ask someone, how creative do you think this image is? It's hard to, first of all, interpret what that even means, and secondly, people are going to have different opinions about what that means. So what we did is we created a Likert test with 5 items. These are the 5 items we used that pertain very specifically to this problem that we are trying to address. So here they are. I like this image. This image is eerie, cold, or violent. This image is surprising, a surprising modification of the source photograph. This image would be difficult to create from the source photograph, and this image makes good use of the source photograph. So we've broken down creativity into attributes or requirements that are commonly agreed upon in the field. You may disagree, but there are some common attributes here, and we've specifically tailored them for this problem to reduce the ambiguity and bring people to the same level as much as possible. This is a 7-point Likert scale here. So then here's the introduction to the main part of the survey that people were given. We describe the problem that we're trying to solve and give them examples so that everyone's on the same page. So the 4th challenge in doing a creativity assessment is there's a lot of different focuses we have in the field. For example, strong, computational creativity versus weak, or the idea of process. This has been mentioned before, process versus artifact. What do we care about? Or do we care about both? And that is kind of where our research lies. We're interested in the artifacts Darcy produces, but we want the process to be perceived as creative as well. So the catch with trying to evaluate the process, at least as we saw it, is that in order for the participant to understand the process of the agent creating the artifact, we can no longer do a blind study. We need to reveal how Darcy is producing its work, a particular piece of work, and we've just revealed the artist. So to handle this, we divided the survey into 3 experiments. Survey takers were randomly given one of these experiments. We had about 300 responses, so we had 100 in each of these, roughly. Blind was standard. The participant did not know which agent, a human or Darcy, was producing the image. They didn't even know the name of Darcy. They just knew that there was a computer program doing some of these. In the basic case, we revealed which was produced by Darcy and which by human, but didn't give any more information than that. In the detailed case, users were presented with a brief summary of how Darcy works, kind of a really high-level, simple description. And they were given a test at the end to make sure that they actually read it and comprehended it at some very vague level. Actually, less than half the people got the test right. But so we have less responses for the detailed experiment, but we felt that was important. But now we still want to analyze these results, these non-blind results. So in order to do that, we have to address some biases. There's many types of biases that can enter surveys, but in this particular case, when you don't have a blind survey, there's the obvious bias of, well, as we've talked about, people have different opinions about whether computers can ever create art, whether being a computer inherently prohibits you from creativity, or we may encounter people that are close to us taking the survey that just want it to succeed, right? We have biases both ways. And a lot of the approaches out there in this field may be susceptible to this because a lot of the approaches involve experts within the field evaluating systems. So we needed to come up with a way to, if not eliminate this bias, at least measure it and be able to talk about it with the results. So at the beginning of the survey, we lied to all of our survey takers. We gave them 15 pairs of images, every survey taker, blind, basic, or detailed. And those pairs were randomly assigned a computer or human artist. And they were asked which they thought was best. They were given 10 seconds to respond, to put them under pressure. The images themselves are actually kind of random filters are applied to random images, and I went through and picked some that I thought looked cool, and I picked ones that were sort of similar on some axes so that there wasn't too much that the participants had to differentiate between the two. But it was random, which was human and which was computer labeled. We created a bias score then at the end by subtracting the number of human responses they picked minus the number of computer responses they picked. So if they weren't biased, it would be close to 0. If they were biased in favor of humans, it would be positive. In favor of computers, it would be negative. Okay, and then we performed the experiment, and we collected results. And I'm going to show you now the results of the Likert test. So this is for the light question. I like this image. Blue is human, red is Darcy. Sorry, I didn't include a key there. And we have standard error, and none of these are statistically significant. Okay. Here's the adjective question. Again, not statistically significant. And now we have the first statistically significant difference, surprising. People thought Darcy's images were more surprising. And they thought perceived them as being more difficult to create, whether they knew the process behind the creation or not. And then use was not statistically significant either, though humans seem to have scored higher there. Okay, so Likert scales are commonly used. They're very common in psychology. They're very common in marketing. Still to this day, they have a lot of value. They give us orderings, but they have problems. A big one, the big problem is that, what's the difference between a 3 and a 4 or a 3 and a 5, right? What does that mean? That differs from individual to individual. Not only that, it differs within an individual based on all kinds of factors, time, context, things like that. So it's hard to tell what that value means. Ranking or preferences eliminate a lot of those problems. Not completely, but they help resolve that a lot. And it turns out that you can convert Likert scores into preferences. And we do that just to give us kind of a sanity check on these Likert results. So here we have for the blind experiment a summary of the preferences. So what we do is we take each survey taker, we pairwise compare all of the human and all the Darcy images that they looked at, and we determine whether they preferred one or the other, or it was a tie. And then this right here is the percentage of human preferred, Darcy preferred, or tied responses. And we see results that corroborate very nicely with the Likert results. So we see very little difference in any category except surprise and difficult. So was there a difference between the three different experiments? So we discovered that statistically there was not a significant difference between whether the people knew about the process or not. And this is going to change for every problem, right? Every domain, every agent, this is going to change. What about the bias? Okay, what was the bias? So on average, it turned out there was a human bias in favor of humans, but a very small one, a score of 0.9. Right? The maximum was 15. There were very biased individuals both ways that took the survey, but on average, it was a small bias. Did that bias have an impact? To test that, we ran a correlation between the bias score and the scores given to human responses or human artifacts and Darcy artifacts. And this is a very boring table that doesn't really have a lot of useful information because it wasn't statistically significant, except in this case right here, where humans were favored. So what we glean from that is that in our case here, bias was not a strong impact on the overall results. And we can more comfortably state, okay, we see that the process, if people understand the process, Darcy's process for creating images, that did not diminish their feelings about the images, and the bias did not strongly affect those results. But this would need to be conducted for each survey so that that can be accounted for. And this is one of the main things we're proposing be done when this kind of bias can be injected into a survey, that we measure bias somehow and, if needed, use that in formulating our conclusions. So that's all. Questions? Go for it.
So I'm sitting here getting excited. So you say about how this can be useful
more widely, the approach that you're taking. So I have a system, I would like to evaluate it using your survey. What do I do?
So what do you do? I think so I think that the main step is to design the Likert items that you're going to use, or if you want to turn them into preferences, design these to kind of parallel these a little bit, but be very specific to your domain. So we actually performed a similar study using very similar Likert items previously and discovered that they do correlate strongly with an individual's opinion of what creativity is, and they are consistent with each other. So I think if you follow a similar template, you'll get similar consistency. The importance is to be clear what the artifact is, right? We didn't just say, oh, these are images produced by a human and images produced by a computer, which do you like better? We said, we take a photograph, we take an adjective, and we have to make it look like the adjective, but not lose the photograph. That's what we told people the task was. And I think if you're specific there, that's the important key. And then to not ask about creativity in general, but to ask about components of creativity. You can probably change what those components are.
Because I think this is the really good bit, because if you just ask people how creative is this computer system, they don't know how to answer that. But when you have these specifics,
Yeah.
So does this list represent the actual questions in the survey? Because I was wondering, are there like alternative questions representing each item so you can calculate consistency and Combus Alpha validate the questionnaire, all that stuff?
So how are they presented to the user?
Yeah, like, so are there like different alternative questions capturing preference for this image, representativeness of this adjective, and so on?
Yeah, so they're presented exactly like this, but they're given a Likert scale. So how much do you agree with this statement, right? Between 1 and 7, use a 7 point. And so this image is a surprising modification of the source image photograph. I strongly disagree to I strongly agree. That's how they're represented.
Right. So I think one considered improvement would be to develop alternative for each item, for each question, to secure them, calculate consistency using Combus Alpha, and really validate this questionnaire to make it available to everyone.
Yeah, so in our previous study, we used Combus Alpha to design the question, and then this one was kind of an iteration on that experiment.
Okay.
So, yeah, that has been done, and should probably be continually done to fine-tune the questions. Yes.
I somehow missed who the subjects were.
The subject?
Yeah.
Okay, the survey participants. So they were basically so it was a survey we generated, and then it's basically a close network, right, to us. So these are colleagues, and then colleagues' friends, friends of friends, things like that. We advertise the survey, right, and then people can take it anonymously. Probably mostly, but not necessarily. So it's not a totally random audience, and it's not really wide. 300 is better than like 2 or 3 people evaluating, but it's not thousands, right? The nice thing about our audience was that because of the size and because of the social locality to us, there was probably limited fraud. But as you expand, you're going to get more and more fraud, survey fraud. But that can be detected. There are ways to detect that to try to minimize those results tainting things.
One more question, which is fairly detailed. So you had a slide about the bias, which only...
Which slide? The last one?
Just a little bit back.
Oh.
It's like towards the end.
Oh, okay. The table, the big nasty
table where
okay.
there's a little bit of bias, and it was only for the difficulty. Right? Does that mean that humans essentially were able to pick up the difficult images are made by the computer?
So right here, this means we got a positive correlation between the humans, so between the bias score, which positive is human, is a bias towards human. So this means that, presumably this means that if a taker had a bias towards humans and they knew the process that Darcy engaged in to produce images, that they gave a higher score to human results.
So they were able to figure out kind of which one is which.
They knew which was produced by Darcy and which was produced by a human. And so that seems maybe a little backwards. They now know how Darcy produces work. Why would that positively affect their score against humans? And my assumption is that maybe they begin to understand the problem in general and how it might be difficult for anybody to do it. That's my only guess on that.
So at the beginning of your talk, you mentioned that you were interested in how changes to Darcy you can see the effect that has on Darcy's creativity. And so I'm wondering how you see this type of survey being implemented to where you don't need to go out to thousands of human survey takers and try and understand the differences that one iteration has over another. Is there something a little bit more immediate that you consider?
You could build a model of what you think people would want. But I can't think immediately of a very effective way of doing that, because it depends, I guess, what your objective is. Our objective is to delight as many people as possible, and so we kind of want an overall. We want to get the overall opinion of people, and the only way we're going to do that is by getting a lot of results from people. Using a human survey like this, it's very easy to distribute, and now that we've kind of designed the survey, it can be easy to iterate, relatively easy to iterate on that, and maybe use Mechanical Turks, do some survey fraud detection, and get results more quickly than trying to find experts to talk about the creativity of the system. But it's not a perfect problem. It's still slower than a automatic score evaluation, but I can't think of a better way.
Got time for one more question?
Yeah.
Could you just give an example of what one of the detailed descriptions look like for a human and for Darcy?
I can't. Well,
please feel free to say.
I had one in my appendices. Basically, it talked about, let's see, I described a few of the algorithms we use and very briefly what that means. But that process that I explained to you guys in the first half of this presentation was summarized. And then they were asked it was a very simple quiz. They were just asked what the name of the algorithms used were, which were bolded. Basically, did you read it? And didn't just skip through it.
And did you ask the humans to provide that justification as well?
A justification for their,
well, so was there a detailed description of both the human created and the Darcy created?
Oh, no. Okay. But they knew what the task was. I did not know what was going on in the heads of the humans. So
might be interesting variant.
That would actually be interesting. Yeah, get from each artist, get a description of what they did and present that to the audience. Yeah, that's really good.
Are you good to go? Thank you very much, David.
Just hit the escape or the directional center.
Little bit sugar this morning. I have hard time talking. I really wonder the people after the lunch how they will do. All right, so I'm going to talk about quantifying art creativity in art network, and this is work I did with my student Babak Saleh. So the question is, can we develop a computer algorithm that assesses the creativity of paintings, given its context within art history? We're doing that because we are all doing computational creativity here, and an important characteristic for a creative agent is to be able to assess its creativity as well as judge other agent creativity. So what's creativity? Of course, we're going to answer this because there's a long debate about what is creativity, how to define it. I'm just describing what we use in our algorithm. So as you know, we can describe a person, a product, or a mental process as being created. For our purpose, it's very hard to go with the mental process because it's very hard to go and see what is the mental process behind a great painting. It's very hard. So we go for creativity of products. When it comes to products, two main conditions for a product to be called creative. It must be novel compared to prior work, and must have some value or influential moving forward into the future. So these two conditions resonate back to Kant's definition of artistic genius. Among the condition he put is the work has to be original as its primary characteristic, but also it has to be exemplary. People start to imitate it somehow. That's the condition to be creative. Moving to the 20th century, I choose this definition from Margaret Bowden, which highlighted the utility of the work, the novelty, but also the surprise. But when it comes to novelty, she made a distinction between what's called psychological creativity where we assess novelty with respect to the creator, versus historical creativity, where we assess creativity within the context of whole human history. So our definition of creativity is in line with what's called historical creativity. So while working in the domain of art, we are proposing a general framework that not necessarily only work with painting, can work with sculpture, literature, any other form of products. However, the domain of art is very interesting because we can, from art history, we know something about which paintings are creative and which paintings are less creative. Art historians give us these hints. So we can use this somehow to validate our results, although it's not easy, or optimize the parameter of the algorithm. Once we do that, we hope that the algorithm can be used with other kind of products as well. But one fundamental issue is how to validate any results of any algorithm, quantify creativity on art will generate. So here I would like to highlight, before I begin, 3 limitations that any algorithm that score creativity on art will face. So you have an algorithm for assessing creativity. Any algorithm have an input and have an output. The input is a painting, the output is a creativity score, right? But obviously, we cannot judge the creativity of a painting out of context. So we have the context, which is supposed to be all paintings ever made. So that's how we judge how creative that painting was. And here comes the first limitation, because the algorithm will never have access to all paintings ever made. It will only have access to a limited set of paintings. So that's what we call a closed world limitation. The second thing is the algorithm will have, the input to the algorithm is actually some encoding of the information in the painting. And this is some visual encoding achieved by some computer vision algorithm that try to encode some elements and concepts of art, maybe color, texture, subject matter, perspective, any of these concepts. So here we are limited also by this kind of encoding, because if the algorithm that we use to encode the painting doesn't do a good job in doing that, then whatever we produce here will be basically not right. The third limitation, that any algorithm will have some parameters, and depending on the parameters, the results will change. So the result depends on the parameters, which also is a limitation. But we cannot, actually, that should not stop us from doing this, because we understand that as time goes, more and more painting will be available online, so we're reaching the limit where we have more and more paintings and we can judge correctly. So this will disappear. And as time goes, also more and more advanced computer vision techniques will be invented that can quantify element and concept of art correctly. So this will also bound to disappear. And finally, the parameters, we should think of the parameters here as basically different ways to assign creativity scores based on different interpretation and different criteria. So here we define exactly what do we mean by novel and influential by these parameters. So this also is a rich ability of the algorithm, not a limitation. So that's why the algorithm will do an objective job in assessing creativity given the input and given the parameter that we set. All right, so let's formulate the problem. We have a set of paintings as an input here. We call them P1 to Pn, and the output is a creativity score. Each painting comes with a timestamp when it was created. We construct a directed graph, all paintings. Painting Pi will have an arc going to painting Pj if Pi comes before Pj. And on the edges of the graph will assign weights, which comes from the similarity between the two paintings. Obviously, here comes the problem, which is how you measure similarity and which concept of art you're going to use. Obviously, you can use color, texture, perspective, any concept that you like, and each concept will give you different similarity measure. And that suggests that we're going to have multiple graphs, one graph for each concept of art. And as a result, we're going to have multiple scores. So the scoring we're going to get is going to be multidimensional, one scoring for each concept of art that we're going to use. All right, so the graph will be a cyclic graph by definition here. So now let's think about what these weights tell us about the creativity. So, so if you have a painting Pi and a prior painting to it Pk and some weight between them. So if the weight is high, it means that Pi is similar to Pk, which means that if you assign creativity, you should, the creativity for Pi should be less because it's similar to Pk, and the creativity for Pk should be high. At the same time, if the weight is small, that means that Pi is novel with respect to Pk, so we should increase its creativity and decrease the creativity of Pk. And now if you look from the other point of view, which is how PI was influential moving forward, and consider another painting PJ and look at the weight. So if the weight the weight between PI and BJ is high, that indicates that PI was influential to BJ. So we need to increase the creativity of PI and decrease the creativity of BJ. And in the same time, if on the other hand, if the weight is small, that means that BI has no influence on BJ or less influence on BJ. That's why the creativity of BI should be less and the creativity of BJ should be more. This is the basic logic here. So if you look carefully, these 4 rules actually boils down to only 2. A high weight implies the prior node is more influential and subsequent node is less creative. A low weight implies the prior node is less influential and the subsequent node is more creative. So what's high and what's low? So we need to balance the graph. So we use a balancing function here, which is basically will convert the weights into positive and negative weights, and where 0 would mean it's somehow neutral. There is no much influence. So we use a specific form here, a simple form of balancing function, which is a linear function around some value m, which we can choose as the median of similarity or some percentile of similarity. And as a result, the graph now will have positive and negative weight. And the rule is the more negative the weight, the more creative the subsequent node and the less influential the prior node. And the more positive the weight, the less creative the subsequent node and the more influential the prior node. Now, once we do that, there's a problem, because since now we have negative weights in the graph, that will be problematic in propagating creativity in the network. So instead, a negative weight from I to j means a positive weight, or we should reverse the edge to be from the other way around. And that's safe because by construction, if you have an edge from I to j, we don't have an edge from j to I, so that's safe. So as a result, what we're going to do is that we convert the network to what's called a creativity implication network, where if the weight is positive, we'll just keep it. If the weight is negative, we'll just reverse the edge and negate it. If it's 0, nothing is done. So now we reach what's called a creativity implication network. So what's good about that is that it's going to be a very simple rule here. The rule will be between any 2 nodes, if the weight is high, the creativity of the prior node should be increasing, and the creativity of the successor node should be decreasing. Notice something here, that since we reversed the edges, some of the edges, the links on this graph is no longer temporal. So it means that you can have an edge now where PI actually comes after BJ. So it's no longer temporal. It's basically implication network. So how the creativity flow in this network? Basically, creativity now flows opposite to the direction of the edges. This is how the things flow here. That leads us to a very simple way to propagate creativity in this network. So this is the formula that we're going to use here, which basically to understand this, it's say that node PI will collect creativity from all its outgoing edges using this summation here, while node BJ will the contribution of node BJ will spread among all its incoming node, and that's why we have a normalization summation at the bottom. But obviously, similarity between painting can come from other reason. Maybe it's a coincidence, or maybe just because they are coming from the same school. For that reason, that's why we have a constant term here, where 1 minus alpha is the probability that similarity between paintings is coincidental. So this is the formula that we can use to update the creativity in the network. So now we can write this in a matrix form like that, where W is a column stochastic matrix. And what you can do is that you can iterate through this equation until we reach equilibrium, or there is a closed form solution also you can obviously obtain here. If you are familiar with social network and literature, this is basically a random walk in a Markov chain. If you set alpha to 1, this will vanish, and what you end up with is an eigenvalue problem, which is called eigenvalue or eigenvector centrality. On the other hand, you can think of this as a weighted average of what's called the Hubble centrality problem. And another way to look at it is it's actually a weighted variant of the PageRank algorithm used by Google. But here you have weights and it's inverted basically. So this reduction is only possible because this network that we created, the creativity implication network. One problem is that this network, this algorithm now sums up the novelty and influence together, so we cannot really discriminate between them. So how can we deal with that? The problem is the edges in the network now, some of them has been reversed, so they are not temporal anymore. But what you can do is that we can actually color the edges to different sets. There are prior edges, if node BI comes after BJ, or subsequent edges. And therefore, actually, we can modify the formulation such that we have a term here that collects the originality and another term that collects the influence, contribution to the creativity. And now we have a parameter beta here that control whether we're looking for scores that emphasize originality or emphasize influence. All right, so let me talk about experiments and results. We experimented on two data sets. The first one is from what's called Archive online gallery. It contains around 1,700 paintings and sculptures, some sculptures, 66 artists, 15 styles from 15th century to 20th century. The other data set is much larger. It's wiki art data set. It's contains about 81,000 paintings, 1,000 artists, about 27 styles, again ranging from 15th century to 21st century. We pruned this set to only 62,000 paintings because we removed non-Western paintings, Japanese paintings, things like that. We removed things like mosaic and installation, and things that's very hard to judge. Just keep it only to paintings. How to do the visual encodings? That's important, of course. There are so many different ways to do that. We used one of these two features that are popular in computer vision. One of them is called class me features, which basically encode any image at the semantic level, where it tell you what is the presence of certain objects in an image, about 2,500 semantic elements that was trained using images that are available on the web, has nothing to do with art at all. So we thought that this would be a very good way to somehow encode the subject matter of the painting, although again it has nothing to do with art, but it's somehow semantic encoding. But also it captures the composition of the painting because of the lower level features has something to do with composition. Other encoding is what's called gest features, which encode mainly scene decomposition along several perceptual directions like naturalness, openness, and things like that. And these are widely used in computer vision in discriminating between different scenes, whether it's indoor, outdoor, kitchen, office, things like that. So again, we think that this is, we're trying to look for feature that we know how they behave. So when we see the result at the end, we can judge whether it's a good result or bad results. Okay, so this is one result obtained on the 1,700 archive images. What you see here in the x-axis is the time starting from 1400 to 2000, and this is the creativity scores scaled. And every painting here is just a point. So the ones on the top is scoring high, the ones on the bottom is scoring low. So how can we interpret these results? Does this make sense or not? First, there's a problem here, that we're starting with sets that are all masterpieces. So one might criticize that anything that pop up in the top are already created anyway. That's correct, but also anything that will pop up in the bottom are also creative. So we're giving low scores to something that also are created, because it's a zero-sum game. But the bottom line is look at this result and see, given the encoding that we use, does it make sense or not? So if you look at things that are scoring in the bottom, it's clear that they are typical subject matter. So nothing creative, according to the algorithm, about painting a portrait of a woman in 19th century. That's something that has been done before many times. That's why it's scoring very low. If you look at things that are scoring very high, you can find some Vermeers around here, Goya's crucified Christ here, and some interesting things here. So let's zoom in to this particular period to see what's going on. One thing I would like to mention that it's not really meaningful to compare a painting in 1500 and a painting in 20th century and say that this is higher than this. This is nonsense. What this is useful for is to look at a specific period and see relatively how things score relative to each other. So now we are looking into a zoom-in version between 1850 and 1950, and that's where we can see what is the behavior. So, for example, we can see that up to this point, Munch Scream scored very high among all these paintings. Obviously, there is a span here where nothing scored higher. And then followed that in that period, Klimt and this is also scored very high as well. In the early 20th century, Picasso's this painting by Picasso scored the highest among his blue period painting. And if you look at this period from 1903 to around 1911, the highest scored painting is this one here, which is basically this painting by Picasso, which is known as the early Cubist painting that later developed to be the Cubist movement. Most of the things that are here are Cubism painting, and other Cubism painting coming to be higher than this later when things become complicated here and people start doing synthetic cubism, while the highest Cubist painting scoring this maquette of a guitar by Picasso. And again, some art historians will point to this as a transition in Cubism. What's interesting is in 1915, these bunch of paintings are popping even higher than the Cubism. And if you look at all of these are Malevich paintings that appeared in 1915 and was beginning of his own school of his own style at that time. And the algorithm actually really identified that this is a transition forward in abstraction than Cubism by itself. And if you look at this period here from 1915 to 1950, most of the painting that's scoring high here is either Mondrian or O'Cathy's paintings. So what is this painting here that's scoring very high on top of even all these Cubism painting? What is this? So when you look carefully about this, it turns out to be a painting by Mondrian that was dated 1910. But when we look carefully, we found that actually this was wrong. The annotation was wrong. This painting was done in 1956. So actually that was a good news for us because it tells us that the algorithm somehow works, because if you move this painting to 1910, it's supposed to score high. So that was good news. We'll come to that in a second. More examples. Here is a religious subset of the wiki art, about 5,000 paintings. And in these two plots, we weigh the influence versus novelty. So here, this is the scores emphasizing novelty. And the interesting thing here, if you emphasize novelty, you see this envelope of the curve increasing novelty at the time of Renaissance, high Renaissance, going to Mannerism and Baroque, and then it drops. While if you emphasize influence, things are different here. And these are more of the popular painting that people copies or use as an example. Going back here, if you emphasize novelty, things that pop up in the 20th centuries like Marc Chagall, Boietro paintings are considered very novel in that case compared to traditional religious paintings. While if you emphasize influence, these go down, and obviously you cannot judge influence moving in the future. Finally, the final plot I want to show here is this, where it's a subset of 12,000 portrait paintings. And here we're showing creativity along two dimensions. The first dimension here is using the classmate features, which include more of the subject matter, although in this case it's all faces anyway. And the other dimension is the gest feature, which look at the scene composition and capture more the texture. And since we are having two dimensions, the third dimension is the time, we're dropping that. So basically this is the crowd of all portraits ever made in the data sets. And what's popping out here is more of the 20th century's creative portrait the algorithm finds. And an interesting thing, if you look at how things change here, you can see more and more abstract portraits and more and more complex texture going on, and these very textured portraits. So basically this is a multiple dimension scoring. All right, how to validate the results? The issue that we have seen with Mondrian paintings showed us that this idea of art time machine. The idea is if what happened if you have scores like that and take a painting, let's say from the Renaissance, and move it forward to 20th century. What you expect to see from the algorithm, if you run the algorithm again, that the creativity score should go down for that painting because it's not creative anymore if it was created in the 20th century. In the same time, if you take a painting from 20th century and move it backward to the Renaissance time, it should score higher. If you take a Picasso and put it here. So this is the idea of time machine. So what we did is we pick up some sample paintings, change the time, and recalculate the scores. And we have 3 cases here. This is a baseline case where we take painting from Renaissance and Baroque and let them just randomly change around 1600, so local movement. And as you see, there's not much change in gain or loss in their scores. While if you take more modern painting and move them back to 1600, you find that most of the schools has gains in creativity. But actually these gains are different. For example, Cubism and Expressionism has huge gain when you move them back into 1600. While, for example, Neoclassicism have a very small gain of only 5%, because Neoclassicism is somehow a reinvention of older Renaissance and Baroque schools. So that's quite basically expected behavior. At the same time, if you look at Renaissance and Baroque and move them forward to 1900, actually their creativity scores lower, so they are less creative in that sense. So that tells us that the algorithms how to do something objective. Finally, I would like to mention this. I showed the result to Marianne Mazon, who is an art historian, chair of art history at College of Charleston, and she pointed me to this book, Shape of Time, by George Kubler, that appeared in 1962. In his book, he came up with this concept of prime object and replication, looking at art history. That in art history there is some prime object, and there are some lots of copies of that object with some variation until the next prime object appears. So this is the concept. But the interesting thing is that he makes this analogy between prime object and prime numbers. He's saying that prime object is the same as prime numbers. Prime numbers are not divisible by any other numbers. So we have this analogy, and that got me thinking that if I give the algorithm the integers instead of paintings and design the network such that I use a similarity based on a model division, what happens is by construction the algorithm will give high score to prime numbers. So what I get out of this is that really Kubler was genius, and this analogy is really a very good analogy. Anyway, so I'll stop here. Just a couple of conclusions. The algorithm take a bunch of paintings and get scores that are meaningful. And I'll just stop here and take questions because that's business. All right, thank you very much.
That was a fascinating talk. I would absolutely love to see on those diagrams the trajectories of individual artists in that space.
Yes. There are so many different visualization things that we have that we want to do, and that's really a good one of them. That what certain artists scores go up and down with time. That's very interesting.
I would assume they go up sharply and then flat out. Is that?
Yeah, I guess. Yeah, that's my guess. But we have to see that. Yes.
Similar question. Necessarily because you wanted to give 2-dimensional graphs on your display here, you were throwing away some information about the relationship between the quantity and the unmeasured. And I think that relationship is probably very interesting. It would be lovely to see some 3-dimensional plots so that we can see the shape of the surface that's generated as you change the balance between those two parameters.
That's true. Yeah. Yes.
On one of the last charts, you had 2 living signs that were right next to each other in the upper right. Yeah.
This one?
Why does one artist get that have a similar? And those 2 images are kind of similar-ish, right? So why are they both?
Yeah. The algorithm somehow statistics because I have many paintings. So if you have 2 paintings that are similar somehow, but still 2 is not really a big number. Right, but these two are similar, but both of them are very different from the crowd, so they are both sticking out. The same thing happened here. So Goya's and Velasquez are really both sticking out. They are similar in some sense, actually, they are similar. But both of them are very different from the crowd here. That's why both of them are considered high. But 2 is a small number. If you have so many of them, then the scores will get lower. Yes?
It's really interesting. I'm wondering whether you could also apply this to, let's say, musical symphonies, or is there something about art?
As I mentioned before, the input of the algorithm is mainly the similarity measure between your products and the dates. That's it. So if you have a good way to measure similarity between your product, and I know in music actually we have more advanced techniques to measure similarity than even we do in computer vision, then you can feed to the algorithm. So I really think, yeah, that's applicable to anything as long as you have the similarity function.
There's a problem with that though. If you take a genre like jazz, where if you're heavily influenced by people who came before, that's a really good thing. Whereas you're saying here that influence is not such a good thing. The paintings that showed a lot of influence from previous works, there was a negative correlation there, wasn't there? That they were considered less creative by your metric.
Yes.
So that wouldn't work with jazz, for example.
That's true. That's true also. Yeah.
One more question for us?
Okay.
Yeah, it's relating that to music. I think one of the questions that I would have is you're suggesting that creativity is transformational creativity, that it's really creating something other than new, right? And so I think related to that then, the notion of craft, that if something is not new, but it's just simply done better. You look at, say, Haydn and Mozart. Haydn did all the originality, but Mozart just did it better. So in your case, Haydn would score much higher than Mozart.
That's true. Obviously, that's very naive. So similarity is not enough. So something like the previous talk, we should really measure so similarity. We should measure multiple aspects about the relation between paintings, like what the previous talk did, and that would be much more informative than just similarity. And as I mentioned, also similarity is not one-dimensional. You can just measure on different dimensions. But you are totally right in this observation.
Right, I think we'll finish off there. Thank you very much.
Thank you.
Let me just say one thing. I don't know if everybody, probably you know this, but just in case you don't, we only have an hour for lunch. You may have noticed that.
I just wanted to ask you if, like,
That's just a 2-minute warning.
So, are you at University of Sydney before?
For about 2 more weeks. 1 more. You and a study. Yeah, I don't think how much skill you get. It's going to be exactly at 2 o'clock. Okay. Just say your second. Okay, so just wait a few more seconds for people to grab their seats. But this next session is called Creative Mechanisms, and we're starting with Ashok Goel again. And his paper is titled "Is Biologically Inspired Invention Different?"
Thank you, Oliver. So, in the morning I gave a talk on visual thinking and analogical thinking on the intelligence test. This talk is completely different. So I'm a little concerned that you might think this guy doesn't know what he's talking about because 2 different talks on 2 different topics. So let me tell you a little bit about what I do and how these things are related, at least in my mind. So I started working on artificial intelligence, then I started working also on cognitive science, and these days I do a lot of work on human-centered computing. This will come through in the talk I give. This is a position talk, not a technical system talk, so there are no algorithms, no system in here. We all look at fundamental processes of computational creativity. There are perhaps a large number of fundamental processes. I do not know what all of them are. There are 6 processes that my lab has been looking at for a while. The design thinking is dealing with problems which are ill-defined and ill-structured. Analogical thinking, meta-thinking, abductive thinking. Abductive thinking is drawing explanations for a set of data. Visual thinking and systems thinking. So the morning talk dealt with analogical thinking, visual thinking, and meta-thinking. So all research in my group deals with 2 or 3 of these circles at a time, because I don't yet know how to deal with all 6 circles together. The current talk is going to be the top 3 circles. So I'll be talking about design thinking, analogical thinking, and systems thinking. And I'm also going to give a talk on Thursday, which is going to be a different triangle. So at least in my mind, this is all related, it's all coherent, not just a scattershot approach. Okay, let's talk about what is biologically inspired design and why are we going to talk about it. So biologically inspired design is the idea that you can take inspiration from nature in order to do design of technological systems. So as an example, morpho butterflies give very brilliant color, but their color is not based on chemicals the way human color, for example, in textile is based. Instead, morpho butterflies have certain structural properties, so certain kind of wavelengths are reflected, others are not. That's how they give color. And that has led to people to think about a different new generation of computer screens, which are based not on particular kind of materials, but on the structural properties of the screen. This is an example of a self-cleaning paint, which is based on the idea coming from lotus leaves. So lotus leaves are plants that grow usually in tropical countries, and they are usually very, very clean. So biologists and physicists working together figured out that there are nanoscale bumps on the outer surface of lotus leaves, so that when raindrops fall, they don't glide, they roll, and they take all the dirt away. Once that particular mechanism was understood, then people started saying, well, why can't we build paints that can operate on the same principle so that you can apply these paints on the windows of your house? When it rains, the window cleans itself, which was a sort of an awesome idea. I can give you lots of examples like that. I'll go through these examples very quickly because I want to get to the main point. But here is another example. In the 1990s, the Japanese railway engineers wanted to construct a train, Shinkansen 500, that could go through at much larger speeds. The difficulty was that when it went through tunnels, it created shock waves. The shock waves created noise, and so neighbors were not happy with it. So how do you make a train go at very high speeds? These are bullet trains. These are called bullet trains now. They're shown in the bottom right on that particular corner. And the inspiration for the design of that nose, the bullet, came from the design of the bullet of the beak of the kingfisher. So the kingfisher goes from air and goes into water, changing medium, just like a train has to change medium and going from into the tunnel and out of the tunnel, and makes very little noise. How can it do it? And once they understood the mechanics of it, they use it in the bullet trains. I'll give you one more example, then we'll move on. So this is a humpback whale. And on the pectoral flippers of the humpback whale, you notice these sort of small little tubercles. So why does humpback whales have tubercles on it? The reason apparently is, biologists tell us, that as these humpback whales are chasing prey, they can cut at far sharper angles without stalling because of these tubercles. Then people who make windmill turbines started making turbines based on the same principle, and these turbines are said to be 70% more efficient. Okay. So these are all examples of biologically inspired design. So I think by almost any definition of creativity, this is creative. It's novel, it's useful, it's feasible, it's unexpected, in some cases it's very surprising. In fact, it's so creative that I wish I was this creative. I don't have the creativity of going from humpback whale to a wind turbine. This is clearly based on cross-domain analogy, biology to design. It's conceptual design. Design is a very complicated process. We're talking here largely about conceptual design. We're not talking about downstream processes of design like optimization and so on. Now, a couple of other things about biologically inspired design. First, this takes a very long time. So this group of physicists and biologists working together who discovered these properties of lotus leaf, these were a group of German physicists and biologists working together. It took them 30 years before they reached the point excuse me. Before they reached a point where they could think about self-cleansing paints. Moreover, almost all instances of biologically inspired design are by serendipity. There is no systematic process at the current time. Excuse me. Now, here's one question we could ask. What's the big deal? Biologically inspired design has been going on for centuries. So according to Wikipedia, Shushruta was the father of surgery. This was on the banks of the river Ganges around 600 BC. And we know that Shushruta made some medical instruments which were based on the design of tigers' teeth and tigers' claws. We know about Leonardo da Vinci. He certainly is well known for doing biologically inspired design. So what's new here? What's different? What's the big deal? Here is a big deal. Over the last 15 years or so, biologically inspired design has moved from a paradigm into a movement. And here is why it is becoming a movement. It's certainly creative. There are major rapid advances going on in biology. So that just over the last 50 years, biology has made enormous advances. Because of the internet, we actually have access to some of that knowledge. But most importantly, people are very worried about environmental sustainability. And the argument goes like this. We are facing very large problems, we as a human species, and we really don't have good solutions for it. I don't know a solution to environmental sustainability problem. There perhaps is no one solution. There perhaps is going to be a very large number of solutions. Here is an example of a kind of problem. Across the world, water is in short supply. Yet, 3/4 of the world is composed of oceans, water. The problem is water has salt in it. How can we desalinate it? And there are desalination technologies. These technologies are extremely costly. So this is actually coming from Qatar, countries like Qatar, which have an average per capita income of $100,000 per year, can perhaps afford it. Most countries cannot. Yet nature has a large number of organisms that do desalination very, very well. Why don't we look at the mechanisms that these biological organisms use? Now, simply because even if, first of all, we don't understand, biology does not understand the mechanisms that seabirds use for desalination really well. Even if we understood that, there is no guarantee that we can scale them up for human desalination, but at least can become a source of ideas. I'll take one more example. In the United States alone, last year, about 1 million buildings were constructed, most of them residential. I don't know the number. This data is coming from Department of Urban and Housing Affairs. I don't know the number across the world. Let's say it was 10 million new buildings. The architect and engineers of every single one of those 10 million buildings is faced with the same problem. How do you take water as many stories as the building is high? Every single architect and engineer across the world uses the same old techniques for taking water high, which are based on mechanical principles. And I can tell you, my mechanical engineering colleagues tell me, it wastes both energy and water. Yet trees they raise water very easily. They use a process called transpiration, which is based on some material called xylem, and it works very well. Redwood trees are all around. They take water 200 feet high without much difficulty. Why don't we look at how transpiration works? Now, of course, that creates a new set of design problems. We don't know of materials that can work on the capillary reaction and use transpiration. But that's the point. We change the design space. Now we will look for materials, wallpapers, perhaps a new generation of wallpapers that will act to this principle of transpiration and take water as much high as you want. Change the design problem. So that's the idea. And I can tell you that people are trying to build wallpapers will act exactly that way. So I hope you can see why people are interested in biologically inspired design. Right now, according to Lepora et al., the number of papers in biologically inspired design is doubling every year. According to Bonser and Vincent, the number of patents on biologically inspired design is doubling every year. So the growth is exponential, but here is the problem. There are few experts. There are few communities of practice. Things are happening by serendipity, not through systematic design. There is little theory or methodology. Things, like I said, are happening by serendipity. Often it happens that there is a husband and wife team, an engineer and a biologist. They work together over years and years, and something comes out of it. There is no scientific discipline. If only we could make a scientific discipline out of it. If only we could systematize the process. That's what we do in computational creativity. We systematize processes of creativity. Then we could build a generation of techniques and tools that could support some of this. Okay, so that's the goal. But how do we do it? Biology is a very, very rich domain. There are, current estimates are 5 to 15 million biological organisms, plants of various kinds. You can think of them at various levels of abstraction. So if you think in terms of your and my body having 1,000 organs, actually human body has more than 1,000 organs. But say of the order of 1,000, and you multiply that by 15 million or 10 million, you're getting billions of biological systems. Huge amount of knowledge. Design is very hard. We all know that. The search space is vast. The requirements evolve. Requirements are not known in advance, or not all the requirements are known in advance. There are a large number of constraints. Constraints conflict with each other. Design is hard. That's why people have been doing design for centuries and centuries, and it's still an unsolved problem. So biology has a lot of knowledge. Design is so hard. How do we systematize it? Well, here is one possibility. One possibility is that people have been doing design for a long time. There already exist design theories. Perhaps we don't have to invent a new design theory. Perhaps we can take a design theory that already exists in some other domain and apply it to biological inspired design. And that raises the question, can we do that? Is there something fundamentally different about biologically inspired design so that you cannot take an existing design theory and apply it here? There are two possibilities. One possibility is that biologically inspired design is just another variation of, let's call it, regular design. In that case, it's just a matter of getting biological knowledge and feeding it into the design process. We already have the design theory, we already have the design technology, we already have the design tools. Alternatively, there is something fundamentally different going on about biologically inspired design. So that simply having more knowledge is not going to help you, because the process itself is different. Okay? So I hope I have set up the question for you. Why is this question important at all? Is biologically inspired design different? Now, the current understanding of biologically inspired design, much of the work on biologically inspired design today assumes implicitly that biologically inspired design is not different from regular design. And therefore, people are building various kind of dictionaries and thesaurus. And the idea goes like this. Give me an engineering function, and I'll find you a biological equivalent to that. I'll pull the biological knowledge, and we'll use the regular design process, and done. Well, that will work only if the process of biological inspired design is not different from regular design process. Because if it is different, then simply getting access to biological knowledge is not going to suffice. Okay. So that's the question. Now that's the empirical question. All right. So in my lab, since about 2006, for about 9 years now, we have been looking at this problem of biologically inspired design, and our motivation was precisely environmental sustainability. If we could make an iota of a difference there, that would be a big win. Of course, that's a big if, whether we can make a difference or not. So we look at the practices of people who do biologically inspired design, then we develop cognitive models, then we develop information processes and services and tools, then we try to introduce them to biologically inspired designers, and this is a sort of cycle that iterates of itself. So what I want to share with you is some findings. First, let me tell you about the methodology. Since 2006 to 2012, we have looked at about 83 design projects that have been going on at the Georgia Tech campus. Because there is no existing community of practice of biologically inspired designers, I'm unable to go to that community and look at real professional designers doing it because there are none. Things are happening with serendipity. So I'm forced to look at combinations of senior students and graduate students doing it. That's the only access that I have to processes at the current time. So several students from my lab took the class, participated in the projects, took field notes. We have made audio recordings. And since these audio recordings are coming over 83 design projects over several years, we have access to huge amounts of data. We are having difficulty analyzing that data. So data is not a problem. We have the data. So let me share with you some empirical findings. I call the first finding zero-earth finding because this is something we knew going in. The first thing is that most designers don't know much about biology. I am a designer too, and my knowledge of biology is very limited. Most biologists equally are naive about design. So it's important to understand that there are no experts in this. Engineers are not experts, biologists are not experts. You can make teams of them, that's how this works usually happens. But the teams also have a big problem. Engineers and biologists typically talk very different languages. The models are different, the measures are different, the metaphors are different. Okay, so biologically inspired design is happening. It seems to be very important, and yet we don't have a systematic method for doing it. So here are some findings. First, in biologically inspired design, analogies are used not just for finding a design solution, but also for evaluating a design solution, for explaining a design solution, for evaluating a biological, for explaining a biological solution. So why do you think that the glands of penguins will be useful? Let me give you an explanation. Out pops a biological analogy. Next finding. Although the literature on biologically inspired design almost always says, whenever some product or some system is designed, that this was a biological analogy. In reality, that is not happening. Why scientists report that things are based on one analogy, I don't know. But that's not the way they're actually happening. In reality, in most of the cases, you have multiple analogies or compound analogies. So in this particular case, somebody is designing a microbot that can swim stealthily underwater. So the first design that somebody came up was with the notion of a copepod. And I'm not a biologist, but I'm told that a copepod has a large number of appendages. So it just swims. It creates minimum wake in water. So which was cool, except the copepod swims very slowly. The problem became now, well, okay, we can use the copepod design for small velocities. What do we use for high velocities? Answer, let us use what a squid does. And squid has a single orifice, and it propels a jet of water through it. And the wake it creates is somehow, the squid is able to do it, balances exactly the natural wake in the ocean water. So that is how to detect the squid, stealthily. And so now you have two analogies, and the question is how to combine them. Here was a third finding. I'm going through this very rapidly because I want to get empirical findings and go back to my original question. So here was a third finding. Okay, there is biology and there is design, but what exactly is transferred from biology to design? What is the unit of transfer? What is the knowledge? One kind of knowledge that people are transferring is knowledge of causal mechanisms. So this is a particular Namibian beetle. The Namibian beetle has a fascinating property. Namibia is a country in South Africa, and it's a mostly desert country. And the Namibian beetle has a fascinating property that it can harvest water from fog, which will be a great thing if we humans had it. And there is a particular mechanism that it uses for that is shown here. And I don't want you to look at this mechanism in detail. I'm not going to describe this mechanism. The point here is that there is some causal mechanism that is achieving some function. It is a teleological mechanism, and that's part of what is getting transferred to engineering and design. Another thing, what is getting transferred are problem decompositions. Nature has already decomposed. One of the hardest things in design is you're given a function or a problem, and how do you decompose it into subfunctions? Nature has already done the decomposition for some of the things. Again, I'm not going to go through the details of this. The point is that for a large number of situations, we can take the problem decompositions, the functional decompositions that nature has done for complex functions, so that we don't have to worry about how to do those decompositions. Here is one that surprised us enormously. This is something that we found in 2008, and at that time it was unreported in the literature. So if you look at design, and I know every one of us is a designer, many of us computer scientists here, so we design by nature all kinds of things. If you look at design, any textbook on design, including in software engineering or artificial intelligence, the design always is described like this. You start with a problem. This is a problem-driven design. You do requirements analysis, it's called in software engineering, and different branches of design, it's called different things, specification analysis, problem formulation. But you start with a problem, and then you map to some biological solution, you abstract some pattern, and that's how you solve the problem. But in biological inspired design, something different is going on. That is only part of what is happening in biological inspired design. In biological inspired design, you begin with a solution. And I have not come across with this idea earlier. You begin with a solution, and then you try to find out, is there a problem anywhere for which I can apply the solution? So let me take an example. This is an example of problem-driven design. The Japanese railway engineers had a specific problem, like I mentioned, how to make a faster train that could go through tunnels without making too much noise. This was clearly problem-driven design. But this design, the humpback whale to the windmill turbine, was solution-based. A group of biologists led by Frank Fish, and I love that the last name is Fish, we're doing biological inspired design. But a group of marine biologists led by Frank Fish first came up, just for a long time they were trying to understand the hydrodynamics of humpback whales. Once they understood it, they started asking the question, to what can we apply it? So this kind of solution-based design is, insofar as I know, has not really been studied much in design theory, although once you start thinking about it, you can see instances of it everywhere. Okay, so the sixth finding is problems evolve over time. Problems rarely remain constant. In fact, often, like I mentioned, biology helps you identify new problems. I'll not go through this. I'll go to the last finding here. The last finding is the current theories of analogical reasoning, almost without any exception, assume that the analogs are available inside your long-term memory. But that is not what is happening in biological inspired design. Because engineers are novices at biology, and therefore they don't have these analogs in memory. Instead, they go to the web immediately. Analogy is situated. Current theories of analogy also assume that the representations are well-known. But the representations are not well-known. Representations are well-known only if you're an expert in the domain, but they are not experts in biological inspired design. Okay, so summary, biological inspired design, our empirical findings suggest there is something fundamentally different going on. You can't just take biological knowledge and apply it because the process itself is different. So some people have tried to apply a theory of design called TRIZ to biologically inspired design. Julian Vincent, the theory of TRIZ is coming from George I. Altshuler, who was a Russian mechanical engineer. I'll show you his theory in a second. Julian Vincent, a British biologist who is sometimes considered the father of biological inspired design, believes in TRIZ, and he is now trying to build BioTRIZ. And I would humbly suggest that this is not going to work. So the general theory of BioTRIZ is very much similar to analogical reasoning, except that it's problem-driven. There is nothing solution-based in TRIZ. Essentially, TRIZ says that a large number of design problems have exactly 39 variables. I've shown only a few here. 39 variables, 39 rows, 39 columns. There are 40 inventive principles. And every single design, creative design, is done like this. It's based on a contradiction. I want a plane to lift off, and I want to lift off with the highest mass. But the lift-off is contradictory to highest mass. And so you find out where the contradiction is. One of these principles is lifting off. The other is higher mass. You go into that bracket, and there is inventive principle sitting there. You apply that inventive principle, creative design. Difficulty, that is not the way biologically inspired design seems to work. We have found no empirical evidence for the application of design contradictions in any of the 83 case studies we have seen. So it may be that it's there and we haven't found it, but that's to be stated. Another thing we can do, we can use theories of analogy. theories of analogy, like, for example, structure mapping engine. Now, structure mapping engine is not the only theory of analogy. There are many more. So, for example, Keith Holyoake and Paul Thegard have one. Mark Keane in Ireland has one. Douglas Hofstadter has one. So there are a number of theories. I'm just going to pick one on this because I don't have much time. So this theory essentially says that you begin with a problem. Again, the process is problem-driven. You retrieve a solution, retrieve an analog, you map, you transfer, and so on. Here is an example of doing mapping from the solar system to the atomic structure. Note, the analogs are assumed to be available in long-term memory. The representations are assumed to be known. The process is problem-driven, which is not what is happening in biologically inspired design, although it's completely analogy-based. So although structure mapping theory and theories like this are very powerful, it's not clear that they, in fact, are applicable to biologically inspired design. So here is the option 3, which is a great option for you and me. We really have to build new theories. We just can't take existing theories of analogy, existing theories of design, and hope that they will apply to biologically inspired design. So you and I have a lot of work to do. So our community benefits from the fact that existing theories don't work. So conclusion, one biologically inspired design, I think, is a novel methodology. There is something going on there, even if I do not yet fully understand it. And it's not just another instantiation of regular design, whatever regular design it is. Second, we already talked that there are twin processes of problem-driven and solution-based design. And therefore, I'm going to use the term not design anymore. I want to use the term invention, because design is almost always problem-driven. And finally, the current theories don't seem to work. The current theories of creative design don't apply because the same kind of process is not occurring, nor do the current theories of analogy seem to apply. The current theories of analogy seem to me to be very limited. And I'll finally acknowledge a large number of people have contributed to this. Thank you.
I think my knowledge of the design literature is kind of patchy, but I have seen a lot of discussion of the idea of a solution-driven approach. And I think that one of the better-known examples is the Post-it note, where the guy tries to find strong glue, he ends up with weak glue, and then he doesn't know what to do with the weak glue.
Yes.
And it takes him 3 years before he finds someone else who actually says, you need to do this, and it's usually successful. So would that be a counterexample?
Yes, it is in fact an example of solution-based. But those examples are relatively rare, and there is no good design theory of that. Okay, if you know of a design theory for that, I'll have to know about it.
Like I say, my knowledge is patchy, but maybe Nigel Cross.
So Nigel Cross has done work, Kruger and Nigel Cross have done work, but their notion of solution-based is completely different. So this is their notion of solution-based. Imagine that you're solving a complex problem, and you come up with a candidate solution for that problem. Now the subsequent processing is based not only on the original problem, but also on the candidate solution. That's a completely different notion of solution-based analogy. So you're right, their phrase has been used, completely different context, completely different method.
Basic question. So you had someone in the middle of the talk, the biology students want to understand and design. What exactly, what's the main thing in design?
Good point. So the design students coming from mechanical engineering, large number of disciplines. So some of them are computer scientists, but mostly mechanical engineering, biomedical engineering, industrial design. Right, yeah. So mostly seniors, some graduate students.
So do you have some ideas on how to do this kind of solution?
No, I do not. I wish I could say that I know how to do it. That's exactly the kind of design theory that we have to build. If there are, in fact, in biology, a large number of solutions, then first, how do we represent those solutions? And then, how do we use solutions to identify human technological problems for which those solutions would be applicable? And that's a new kind of design theory to do it.
Okay.
Give me 2 minutes.
You weren't expecting such a...
Here we are. View.
Grammatical invention.
View. How do I do this slideshow?
I'll read all of the authors.
Right, that's perfect. Thank you. Thank you very much. Okay, so, yeah. Okay, so this is working. Back, forward. No, it's playing my whole talk. Stop. How do I do this? Someone help me. What button am I supposed to press? Play.
Don't worry, if it doesn't work, just do whatever.
Clicking. Well, it was into playing my whole talk. So, if you can figure it out, then you can do it. But okay, by hand. Okay, so I'm Joseph Corneli. Hi, I usually go by Joe. It's the role of blending and mathematical invention. Yes. So, to give you some context, the work was done as part of the European project Co-Invent. We've just heard lots of interesting talks about theoretical stuff. Our theory is that we can do a lot of things with concept blending, and that's a contentious point. But today I will show you how it actually works in the context of mathematics, at least partway there. So that was the first context. Now, just want to show you that. Okay. Take a minute. Okay, so how to blend a sketch. Okay, so we start with some goal. Identify 2 or more relevant input spaces, put them together. Someone had a nice picture. You had, of the cheeseburger, the cheese, and the burger. So you've got 2 things coming from different domains. You want to get something out. You want something for dinner. And you need to do these things. So in our world, one of the key steps is to find some commonality, like it's both food. But in the mathematics case, it will be much more obvious that these commonalities are actual structural similarities. So then you combine them, respecting their common structures, and you get something out at the end. And of course, what you get at the end might not do what you wanted, so you need to keep fiddling about with it. There's lots of theoretical influences that say, yes, blending is the way mathematics happens, or it's the key idea for all thinking in general. Some people will overstate it, some people will sort of understate it. But in the context of mathematics, this might actually work and be somewhat realistic. So, okay. And by the way, there is actually a fair amount of mathematics in this talk. So for those of you who don't like mathematics, I'm sorry, I'll try to explain what's happening as it's happening and stay within time as well. So, yeah, we're going to just jump into 2 theories. So supposing you've got the natural numbers and a theory of a function. It's called a total unary function. That just means you've got a function you can apply to every element of a set. And it has an inverse, so you can go forwards and backwards. So you know about natural numbers. There's no thing such that it is the predecessor of 0. Okay, natural numbers start with 0. That's the world of natural numbers, starting with 0. Okay. Again, just raise your hand if you don't understand something, and I'll say it again. Okay. So it will get much worse from here. This is like our easy warm-up example. So the conceptual space with the function, that one's easy, right? You apply the function, you apply the inverse, and you get back where you started, or vice versa. So what we're doing, we're now going to talk about how to do that, finding the things that the theories have in common thing I said to you before. So down there in red, that's all you also, another tip is if it's something in red, that's you have to pay attention to that, and you can ignore most of the other stuff. So so if you've got this successor and you've got this function that applies to the elements of your space, which are just called x, now I'm going to look for something that is in common. So now I've got a function that applies to something in some space. So you can just ignore all of the interesting particular details and you just look at the most generic kind of structure there. And this stuff is where I take functions and I take category theory, or we do collaboratively, and we draw arrows and we show what goes where. But it's what I just said. You find the most generic stuff in common between your 2 theories, and you say, that's what's in the middle. I'll show it really is in the middle in a minute. And then we use this category theory thing called a co-limit to preserve structure from this generic space, which is what the things have in common, and the 2 input spaces, which could be somewhat arbitrary. Important to note in this context, we're looking at mathematics. So one of the other things besides just your typical category theory idea is that axioms become theorems when you push them to the colimit. But okay, so that part's red. The main idea is you've got this space on the left, that other space on the right. They've got something in common. I showed you what they have in common, which is they've got some space which has some function which does something. It's not rocket science. And you push them to this blend, which combines features of both spaces and preserves structure. Of course, after doing all of that, you might not get something you were very interested in. You might get something different, wrong. In the case of mathematics, you might get something that's just not consistent. So we're pushing mathematical theories around. You might get something that has a contradiction, and I'll show you that in a minute. Now this is what it actually looks like when you implement. Is this causing that black thing to appear? I don't know. Is that black thing really necessary? No. Oh my God, it's much worse. Okay, view. Into full screen. Well, we're back without the black thing. Okay, so so this is what it looks like if you write it down as a computer program, except it's the computer program printed out quite nicely in LaTeX. So you see you've got this thing that's a theoretical description of the natural numbers. We've got something which we call a sort. It's a type of thing. It's got some operations. It's got some axioms. Imagine your typical view of the natural numbers. This is what it says. Okay, 0 plus y is y. That kind of stuff. The same basic thing we do with the other example I told you. You've got an inverse, and you run the function. You get the same thing back. Hopefully, no one's raised their hand yet to say I don't understand anything. So we're doing pretty well. Now. We use this thing called a heuristic-driven theory projection, which I've put footnotes to some papers. There is software that actually does it. I didn't include the results because it's actually what I already showed you. You find this thing in common, which is some space with some function. Okay, and you push it out to the colimit. To compute the colimit, you get all of this stuff. So in the end, it's basically taking all of your theory from the left, theory from the right. You've got all the stuff from the common space, which is why it's called N. You chuck it all into the colimit because you've preserved as much structure as possible. All of these things are deducible from the axioms that we had before. That's what I noted. It's inconsistent. So I told you something could go wrong. Let me think for a minute. We don't have a successor, a thing that is the predecessor of 0, but if we apply the predecessor function and the successor function together, we get the thing back. So in the case of 0, let's see, predecessor of 0 is 0. I don't know. So the point is we get a contradiction. So we've got to remove one of the axioms from one of the spaces and run it all over again. Okay, so you've got an axiom. This is what you do. This is called generalizing or weakening. So we go once again. We get it right. Okay, no contradictions. So that was just a warm-up, right? So now we're going to get into some more interesting things. So we've seen the basic case of basic model of how this blending stuff works in the mathematics domain. The claim that it's a universal theory of how all cognitive science works. I think we haven't even gone there. We're just looking at blending mathematics theories, okay? And how does that work? So here's one that I find extremely intuitive. So that stuff with the natural numbers is very illustrative for how does the theory work, but actually, how do you get this concept of infinity, right? Where does that come from? This is the sing-along part. So follow the bouncing ball. You go from the start to the end. Okay, bounce, bounce, bounce. If you've got a finite process, it's got to start. You go several bounces. It's just the kind of counting process. Then you get to the end. But if you have an infinity situation with infinity, you start, you follow the bouncing ball, and this song goes on forever, and it doesn't stop. So what would happen if we were to blend these two pictures? I assume you've got some ideas, but maybe you don't know what I'm talking about. Okay, so blah, blah, blah. Yeah, paying attention to the bits in red, you chuck it all together in one theory. It's both finite and infinite, so that's a problem. There's an end state and there is no end state because we just chucked it all together, right? We took as much as possible from the two, space on the left and space on the right. So we can't do that. That won't work. We've got these contradictions. This is the inconsistent theory I told you could happen. Quite frequently it does. So we weaken things, and we just selectively kind of delete certain axioms and keep other ones. So we incorporate the infinitely many states and the end state idea from these two different theories. And this picture, I think, is worth, maybe an infinite amount of words there, because what you see is you've gathered the idea of an end, as well as this counting process, and the fact that it's infinite, all chucked together into one theory, and we're not getting contradictions. So you could just think of this as like an infinity symbol. That's what we produced through computational blending. So that's pretty good. This is the power of blending. Okay, so this is like a more mathematically intensive example. This was the part where I said, I'll slow down, I'll say things 2 or 3 times if you want. I won't even say them at all if you really object, but basically, if you ever took abstract algebra, you might have heard of ring theory, and you might have heard of prime ideals. If you didn't, I'll show you a nice example that will make you feel it's incredibly intuitive, but that will come a couple slides later, so be patient. But you have heard of prime numbers because it was in one of the previous talks, and you probably saw that in school. So the idea is you've got your prime numbers, and you've got these things from ring theory which behave a bit like prime numbers, okay? And the thought is, could we produce this ring theoretic thing by blending our kind of common sense, intuitive, grade school notion of prime numbers with the theory of rings, which is like how would I describe it? It's an abstract algebra concept. And indeed, we can do that. So the first input space is the prime ideals of some ring together with a multiplication operation for ideals. So we assume that we know what ideals are. In fact, I think that should just say the ideals of some ring rather than the prime ideals of some ring. Let's just see what it says. So this is the big unveiling of what it is. It doesn't say, so delete that word prime at the top, okay, because we're going to recover the primality in the blend. We're only going to look at everything but that word. So what is an ideal? An ideal is a subgroup of your ring that absorbs other elements that you multiply in. And these ideals can be multiplied by each other, okay? So you can multiply 2 ideals together by taking all the sums and all the products of all the things in the ideal, and you produce something else. And because the ring itself is one of these things that absorbs everything in itself, they're closed, that's an example. So they always absorb each other, and now I'll show you the example, okay? So there's a sort of sense of division in ideals. So just think about your integers. We reviewed integers last week, or 2 slides ago. So all the things that are multiples of 10 and all the things that are multiples of 2, okay? So you've got your even numbers and you've got your multiples of 10. Multiples of 10 are also multiples of 2. So the 10 ideal is a subset of the 2 ideal, right? I'll say it again. Everything that's a multiple of 10 is a multiple of 2, okay? In fact, if you multiply the ideal of 2, multiples of 2, by the ideal of multiples of 5, you get the ideal of multiples of 10. And the notion of division is a little bit weird here because usually when you have something that divides something else, it's smaller. Here, it's bigger, okay? But there's still a notion of these things factoring out. So this now you know what an ideal is, right? So now, forget about what I said about primes before. Now we're introducing the notion of primality into the equation. We've got a basic theory of integers and the usual definition of prime. So we, again, as usual, just chuck as much as possible into the generic space to give a sense of what it means to be suitably generic in this world. We've got some set of things, which we call a sort, with a binary operation, a neutral element, and a binary relation. Okay, so sounds like something we have in both of these worlds. And in our first attempt, much as in the other example I showed you with the code, you get lots of stuff. You get, a set, you get a plus, you get a times, you get a 0, you get a 1, you get the set of ideals, you get this relationship of something being prime, you get the set of all primes, you get a multiplication between ideals, you get an identity of ideals, and you get a containment relation. So we've just chucked everything of all of our theories into this co-limit, plus all the axioms that assure that the set is a commutative ring. And importantly, after you kind of smush the rules of primality together with the rules of ring theory, you get something that specifies primality for ideals, and prime is the collection of all prime ideals. So I said there's a little bit of algebra in there. The point is, yes, there is, and making sense of something is a computation. So here's what we do that's a bit more interesting maybe. This is where the kind of creative move takes place. On the, as I said, what we did was not wrong. We didn't produce an inconsistent theory. What we produced was something with a bit of slop in it. So had we blended things that were a little bit more precise, it would just all kind of slot together and dovetail together, and we wouldn't need to do algebra at the end, okay? So we restrict on the one side, instead of talking about rings, we talk about these containment division rings, which are rings with a certain property. All ideals are subset if and only if the bigger one divides the smaller one. As I said, there's a bit of confusion. The bigger things divide smaller ones. So that's the condition. Okay, so if it's contained, then it's a divisor. And this blend, it turns out, is a minimal set of axioms so that the interpretation is uniquely determined. We just slot the axioms all together, and they fit, and we get this theory. Okay, so I think I'm doing pretty well on time, because I've only got one slide for discussion, so I want you guys to contribute to the discussion, I hope. Computational creativity. Where is it, and did we see any of it in this talk? What we've talked about is using computers, and I like to think of it as a bit like a lathe. Okay, so if you've got a lathe and you want to like cut a piece of wood, you can use a chisel and you carve things, but you kind of do that by hand. So what we've shown is you can use this computational engine a bit like a lathe. If you know what you're doing, you can reverse engineer a concept using this blending mechanism. But I think and I think everyone here would probably agree, that's not really computational creativity. That's, I don't know, computational lathing or something. So to be more convincing, I vaguely mentioned this idea of internal evaluation, that the blended theory might be inconsistent, or there might be some other criteria that you would apply to assess that, and you might go back and start over again or something like that. So again, those are things that the sort of operator of this tool is typically bringing to it. It could notice if it was finding something inconsistent, and it could back up and it could try things again. But it doesn't have a whole lot of sense, really, about what it's coming up with. So I thought, why don't we, instead of calling it internal evaluation, let's call it embedded evaluation, where the system asks and answers some more interesting questions along the way to the result. So what did we see, for example, in the prime ideals case? We saw there are two different ways of going about it. You get a more generic one, where you're blending theories of rings with theories of prime numbers. It's good, because we've now produced it in a very general way. Or you could produce the blend in a more elegant way, where you say, oh, well, yes, we had to do this certain computation. Let's just inject that into the one side of the blend itself, and now we create this really elegant blend. Maybe the computer could notice, oh, I could do this in two different ways. We figured it out. It shouldn't be that hard. Or even take it as a hint that these containment division rings are actually kind of mathematically interesting theory, and then start trying to prove theorems about that, which is what our more algebraically inclined colleague started to do himself. Okay, so now this is the slide that I actually think is really interesting. So this one I'm going to dwell on in a minute. I'll read out the quote. It says, what is characteristic of the movement of the theories that will be considered here, actually the ones that were considered here also, because this is the end, is the existence of an end conceived in advance as a term of the ascent. Okay, so this is a philosophy of mathematics idea. Like I said in the discussion of what does it mean to blend things, you usually have some idea of what you're going for. You're saying, okay, I want to recover this concept as a blend of these two other concepts. You have some other criteria, like ways of evaluating the things. You say, oh, yes, it's going to be a mathematical theory. It's going to have to be consistent. I'm going to have to push axioms to theorems, all this kind of stuff I said. So you conceive of these things in advance. And actually in mathematics, there are a number of other structures that work that way. So that's interesting. And there's this sort of notion of perfect or perfectibility, that, yeah, I got a blend, but it wasn't quite the right thing. Like in the case of the infinity example, we chucked everything together and we got a bunch of stuff. It didn't really work. We thought, this is too much stuff in the theory. If I remove some of it, that construction is a bit better. So that's fine if you consider yourself to sort of be a lathe operator, and this thing is the lathe. You can keep moving until you have the perfect carve on your thing you're lathing. But the challenge for computational creativity, basically, in my view, would be for the computer to decide the goal in advance, or to ask the question, to say, what would be really interesting here would be if we could recover such and such as a blend, or to say, here's the goal which the human set, which is way up here. I'm going to have to break that down into lots of little sub-goals so I can reconstruct this other theory as a blend. If you get back to the inspirations that I said at the talk, these people are claiming this is how mathematics works, that everything's kind of constituted as a blend. But if we're going to redo all of that using computational creativity, or eventually use this to produce new mathematics, then the computer needs a role. So that's that from my side. You can ask comments or questions.
So I was wondering, how do you determine the relevance of different input spaces for your problem?
So in the case, I think, of all the examples we showed, so the first one is just illustrative. Let's take two things that have something in common so that we can find a common space and illustrate the theory. The second one was like, we had a notion we wanted to constitute as a blend. So again, it was a bit of an illustrative thing, but you have an endpoint in mind. So how are we going to get the notion of infinity as a blend of these two things? So that's I think you have to work in a way backwards from it's the same thing as it's saying here. You pick something as an endpoint. So how could we reconstitute X as a blend? And you can trace the whole things back, right? So you look for the generic space. Well, I think the question we always ask in cone blend is, what's the generic space? What do the two things have in common? So you're working backwards, right? You say, I want to constitute this thing as a blend. What's the generic space? Then you move back up here.
Well, I think there could be a couple of input spaces leading to the same generic space.
Sure, we should.
So do you think do you think
Yeah.
it's important at all to focus on selection here, or does it just not matter which input spaces to use, as long as they form the same generic space?
It does. I think that's what the last example kind of illustrates, is that you can pick something that. Now, I won't claim for sure that those things have exactly the same generic space, but I can imagine ones that would. You just add in some extra axioms, and they don't have anything in common on the other side, so they don't go in the generic space. But you just try to be minimal. It's kind of an Occam's razor thing, that you don't want all these axioms floating around, because you will push them into the blend, and you don't want that typically. So you try to be minimal. That was what the final example showed, is much more elegant because it fits together quite nicely.
To be computational, I would expect that you would have a defined set of operators for blending, and I wasn't clear whether you did have such a set.
So yeah, that was what all those four-letter acronyms that I was whirling by, CASTLE, HETS, and HDTP, are the different engines for those things. So the CASTLE is the specification language.
Yeah.
HDTP is the thing that finds the generic space between these two specified theories. And HETS is the one that pushes it out to a co-limit. So each of those things is a specific implemented algorithmic way of doing the things that I was talking about.
Is that set of operators going to be complete in any sense, or it seemed like there was?
No, it's disclaimed to be complete in any sense. It's only so that the things that you can blend, it's complete maybe in the sense of first order logic. So, but if you were to try to blend things using higher order logic, that's not gonna sit well. So the examples that are in the paper that I didn't include here were some ideas from Galois theory. So if you're working with Galois theory, you can basically add in a root. You add in root by root, and you build these other algebraic structures which correspond to the additional roots to your polynomial. I thought, oh well, that's just like blending, because you add things in, so you blend it. But the problem is the relationships require higher order relationships to make sense of these new structures. You'll see in the paper, but that won't work so easily. There may be ways to kind of cram it in edgewise, but it's not an easy one.
So you seem to have made a clever move to deal with the combinatorial explosion problem that occurs with conceptual blending. Okay, so for a very long time, since '76, Linux to about AM, we have known that, because of set theory, we have known that if you take one concept, another concept, and combine them, then most of the time what conceptual blending produces is not very meaningful. Occasionally it will find something really interesting. And AM never knew how to do that evaluation to decide what is meaningful and what is not meaningful. You are making a clever move that instead of just blending these concepts, your computer program will come up with a third concept already, and they sort of reverse engineer the two, right? That's how you deal with the computer explosion. But then the question becomes, how does a computer program come up with a third concept?
Yeah, well, so I think that there's sort of the current iteration, which is, as I was describing, what is the, so you find that your work really, it's a bit contrived in the sense that the computer doesn't. So the current family of things seems to be that you pick it, and then you can show by hand that, yes, I could reconstitute this thing as a blend. There's other examples that we compute, and if you see the system running, it's quite impressive because it's trying adding this thing and that thing, and it will go through a huge chain of evolution to find the right blend that will fit. So, for example, in the examples in music, it's particularly clear that it's trying this and this and this and this and this until it gets something that's consistent with the requirements. So I'm not fully sure that we have cut off all of the different possible combinatorics. I think that by and large, what the issue is here is it's a search problem. So there is a combinatorial explosion. What I've shown you here isn't, say, the solution to that. It's really saying, as you're saying, that is a problem that needs to be solved, and we're also working on that. Although I didn't talk at great extent about that in this talk. But that we're working on these things, and I think that the more the process of blending can sort of be broken down into very small steps. Well, okay, you'd think that'd be worse because it's more combinatorial explosions, but at the same time, that gives you, sort of more leeway to try to negotiate those points and build a theory about how to do the search. So that's attention is going there as well. Oh, hello.
How deeply tied to the domain is this? Are you really interested specifically in blending of, say, abstract algebra theory, or is that being domain for a more general system?
Well, so as I said to the question is about the logics and so forth. So that this first order logic, things specified in Castle or OWL. So no, I think that the same system is working now on mathematics and music examples. However, I think it's more tied to the logics than it's tied to the domain. So I don't think abstract algebra is the be-all and end-all of mathematical theories. But the problem that you run into, even in abstract algebra, is it's tied to first-order logic. That's the current limitation. So that's not a limitation of blending theory. That's the current limitation of these implementations that we're working with.
Okay, let's thank our speaker.
Oh, wow, so comfortable. I thought I'd keep it. Let's see. Yeah, and I think it's a little bit wired too here.
Excellent. Testing. Oh, it's you. It's me. Right. If you want to, you can use the optional clicker. That would be great. I like clicking. Yeah, me too.
So the next talk is Tony Beal and
Al Najjar, that's right.
And they are unweaving the lexical range.
That's right. And attach this to some sort of part of your body. Do just shove it in your pocket, whatever. Does it work?
As far as you know.
As far as I know, okay. And maybe doing a Marcel Marceau up here.
Okay, that's a novel response. Okay. Detect displays, maybe.
You're making progress.
Hmm?
Are you mirroring? Yeah, you should mirror your display probably.
I should or I should not?
You probably
Whichever
should.
one you're currently doing, do the other one.
Do the other thing.
The collective wisdom in this room is, it's just humbling. Okay, thank you. I'm delighted to be able to follow on from several talks this morning which introduced some of the themes in this one. It's a bit like pushing Scientology to people who've been spent the day watching Tom Cruise movies. All of the high notes have been covered. Though I have to say the color scheme here is absolutely awful. Hang on a second. Yeah. If you're half blind and you're looking through a Coke bottle, you might think that that was acceptable. Jesus. Okay, this is an inauspicious start.
You did promise us a rainbow.
Yeah, I wanted more than 7 colors though. Oh, I'm just going to go full speed ahead here because we're running out of time. Okay, so what I want to talk about is symbol grounding, which is a problem that Searle attacks in The Chinese Room, and which plagues all of us. Often when I speak on my work on metaphor generation to audiences of linguists, they say, you're just playing with words. There's no meaning in there. This is all Jacques Derrida kind of stuff. And I have to remind them that Derrida was talking about human beings and not computers, and that Derrida was saying that humans do exactly the same kind of thing, playing with words. But we do have the sense that when humans use words, that they're grounded in shared culture and shared experience of the world. And how do we get a machine to do that? To use words in a way that reflects a shared culture and a shared understanding of the world. And one of the ways we do that is we talk about the Turing test. Now, we can introduce the Turing test and say it's all about behaviorism. It's if our machine quacks like a duck and walks like a duck, then it's a duck. And that caricature of the Turing test is very popular with the media, who want to turn everything into an X-factor Turing test, often at the expense of the AI. And you may have heard putative reports of Turing tests that weren't really Turing tests last year. Turing has actually quite a sophisticated view on this. He imagines talking to a system, which may be a human or a machine, and having a conversation that reveals an interior mental life. So you might have a conversation about your favorite Dickens character. And the system says, well, my favorite character is Mr. Pickwick. And the interrogator says, why is that? And the system responds, because he reminds me of Christmas. And why does he remind you of Christmas? And so on. So the system has opinions, and those opinions are grounded in shared culture. And so this harks back to what Mike was talking about earlier today, not just having arbitrary or random opinions, but having opinions that are grounded in what you know about the world and being able to interrogate those opinions and find out other consistent things that the system believes. The Turing test is actually much more sophisticated than the atrocities that are perpetrated in its name in recent years. And this led to Searle attacking the Turing test, but he was really attacking Roger Schank. And anyone who's seen or met Roger Schank can see why you would want to attack him. And Searle puts forward the Chinese room argument, which is actually a very devious piece of Gedanken. And as much as we dislike it, it's almost impossible to disprove. In 1980, he put forward this argument that said a system that purports to understand Chinese or any language or any symbolic human activity isn't really understanding because it's not conscious. Over the years, by 1990, he elaborated his argument to talk about a distinction between syntax and semantics. He says computers are inherently syntactic, they manipulate symbols. They're not semantic in the sense that they can imbue those symbols with real meaning. They cannot ground the symbols in the real world. Only brains can do that. He doesn't know how brains can do that, but there's something about brains that is not possessed by a computer. Computers have syntax, which is great, but we infer the presence of semantics where there is none, and the Chinese room does a good job of showing that the man following his rules can give credible answers to Chinese questions but doesn't understand Chinese. Now, one reason for that is that the symbols aren't grounded in his experience of the world. So when he's answering questions about apples and oranges, he doesn't actually think about those things because they're not connected into his memory, into his experience. So he's just manipulating symbols. He doesn't have the experience, and he doesn't have the grounding of those experiences. So one way to overcome this is to try to give computers experiences and ground symbols in those experiences of the world. And one way to do that is sensory motor experience, right? So one clever response to the Chinese room, which is still open, I suppose, is that if we embody our computers in robots with real-world effectors that can sense and change the world, they can ground their symbols in the actions that they can take in the world. And those symbols will gain meaning because of those actions and the ability to change and sense the world. Now, despite my penchant for drawing robots, I'm not a roboticist. But I think in software we can do something akin to this. We can talk about sensory grounding of symbols. And to do this, I'm going to look at a problem that was inspired, nay, explicitly stated by Mike when he visited Dublin a couple of years ago. He said, what if we could get a computer to creatively name colors? So there's a bot called Every Color Bot. My wife was just emailing me. So this is real-time drama. If you see the message come up, where are you? Why aren't you responding? I may need you to cover for me later. Okay, so Mike asked the question today, how do we ground an RGB symbol? He didn't put it like that, but that's what I was thinking when he said it. So when I say I like this RGB code, let's say A4D4FF, but I don't like CE2029, what reasons do I have for making that statement, other than an arbitrary statement, an arbitrary decision, or a random decision? Well, one way to do it is to ground these symbols and to say, this is the color of the Microsoft blue screen of death, and that's why I don't like that color. This is the color of blood. I'm squeamish, so I don't like that RGB code. But this is the color of green grass in spring, and that's why I like this color. Whereas another system might say, red, that's the color of Magnum's Ferrari. I like that. Blue, that's the color of a newborn's eyes. I like that. Green, that's the color of Shrek's earwax. I don't like that, right? So we can all ground these things in our own experience, and then our experience of those things that are grounded, that provide a grounding, allow us to derive decisions about these symbols. So having experience allows us to defer and to calculate feelings about things. So these are arbitrary codes in one sense. They're hexadecimal codes. In another sense, they're grounded in the color wheel, the RGB color wheel, and we can go a step further. We can ground color terms in those RGB symbols. Now, here's the bot that started the conversation with Mike. Every color, it's one of the simplest bots out there. It generates a random 6-digit hex code every few minutes. And it tweets it, and it tweets a swatch of the corresponding RGB color. People seem to like this bot. they follow it in large numbers, and they retweet these things. Now, do they retweet it saying, I'm a big fan of 04AFD4. I play bingo on weekends. No, what they mean is, I like this color. And like everything else on Twitter, you retweet because it says something about you, right? Look at what I'm retweeting. Doesn't this show great taste and discernment and hipness, right? So people follow this. It gives them random stimuli, and by selecting from the random stimuli, they're saying something about themselves, which other people can then appreciate. So Mike's idea was, wouldn't it be great to one-up every color bot, to receive its colors, and then to name them, and to go back at every color bot. Hey, bot, the best you can do is call this BBC6A1. I call this Rusty Battleship, which would have been more appropriate if the colors were working here. Or cow urine, which I don't know what that looks like. I'm making a guess based on my grounding of cows and urine, right? So the task here is to come up with a creative name that names colors, which is grounded in the RGB color spectrum, and which makes sensible use of words and color groundings in the real world. How do we do this? Well, we can imagine that we have color stereotypes. There are things in the world that we associate with colors. Those colors we can give RGB spectrum ranges, and therefore we can ground those stereotypes in RGB. So for instance, we know that chocolate is browny. We could use the word brown, but we can give it a specific RGB shade or area of the RGB spectrum. Likewise for sky blue, which looks like Irish sky blue here, but should be deeper and bluer and nicer. Okay, so we know, therefore, those color labels are now grounded if we can give them RGB codes. It's a cheap kind of grounding. Bear with me. We're not going to solve the philosophical problem of the century in this talk, but it's a start. Now, if we were to name this shade here, which is halfway between sky blue and chocolate brown, if we were to call it chocolate sky and understand the linguistic rules that make up the compound, making it from chocolate and sky, and to calculate the corresponding RGB code that goes with it, we could in effect say that we were grounding the noun-noun interpretation process in color semantics. We could take the grounding of the individual inputs and create a grounding for the composite whole, which would be a nice thing to do. Where do we get the color stereotypes from? Well, we do it laboriously. In fact, I have a large database of stereotypes which I use in my metaphor work, and I took out the ones that, in my mind, are associated strongly with colors. And then my wife very generously spent a long time calculating RGB codes for these things. And she's still married to me, right? So you don't have to use your students for everything, right? So coffee brown, 362D26, sugar white, FFF, AFA, grass green, 228B22. Sounds like a George Lucas movie. 8B4513, different dark chocolate, milk. There's a heart in there. That's just me, right? Okay, so heart red, sky blue, and so on. We've got about 600 of these things. Words that denote strongly associated with colors, and we've grounded them in the RGB color spectrum. Now what we need to do is to figure out how to combine them. So for any arbitrary color, let's say we're presented with this color by every color bot, we could find the colors that are associated with color stereotypes and say, oh yes, there's two colors, chocolate brown and sky blue, that if we were to mix them in a certain realistic ratio, would give us something close to this. So why don't we call this chocolate sky? Why don't we call it sky chocolate? Chocolate sky sounds good, right? It sounds natural. Sky chocolate sounds really weird. And if you start combining words just because it's convenient to do so, you'll get a lot of nonsense. You'll use words in ways that people do not use them. And you'll fail the first tenet of the Turing test, which is to suggest that you understand language in the way that a human does and have an interior mental life that makes sense of what you're saying. So what we do is we use a Duchampian idea, which I call the linguistic ready-made. we scour the Google Ngrams, which is a database of web text fragments that you can download locally, for interesting word juxtapositions. And we particularly look at the ones where the two words being juxtaposed are color stereotypes. So paper white, tawny tiger, rose red, garden green, right? And we say, okay, these two words are associated with colors. Perhaps the whole phrase is associated with colors. Gold star for the top of the class, right? Snow storm, forest fire, mushroom cloud, not so much, but it's a very good color term. You say, no one's going to say, I'm going to paint the baby room mushroom cloud. I want that baby growing up with a realistic sense of the world. Okay? But if a computer generated a color mushroom cloud for a kind of a dull gray, I'd be very proud of it. Right, so what we do is instead of arbitrarily combining words to get the colors we want, we look for linguistic ready-mades that contain color terms that if we were to interpret them as color descriptions would give us the color that we want. And what is the gain in doing that? Because these are tested combinations of words by human beings. So they make sense to humans. So it convinces the viewer, the audience, that the computer is using words in the way that a human would use them. Okay. So summer night, cherry tree, pine forest, and so on. Pear tree, all very nice. The frequencies are from the Google Ngrams. And of course, the higher the frequency, the more common this term is, so the less creative it is as a compound. So pear tree, microwave oven. Okay, very common phrase, it's a banal name. If we start looking at the bottom of the frequency spectrum, and the lowest frequencies in the Google Ngrams are 40, then we get things like midnight sunset. That's a challenging combination, right? Jungle sunset. I like this one, putty cat, right? I thought I saw a putty cat. Okay, so the system doesn't know anything about Sylvester and his linguistic impediment. All it knows is that putty is grey and that cats, it has a concept of cats as black. So a blackish grey. A salt desert. Okay, something that you would find in some kind of Tolkien novel. A salt desert or Game of Thrones. Velvet night. I think velvet night's pretty nice. Wintry storm. Amber is not very good. Cut that one out. I like baby ghost, right? Again, if you were Tim Burton and you were painting the baby room, baby ghost would be great, right? Concrete park. Porcelain toilet is a bit too realistic. Lavender sky is just lovely. Okay, so I should say, and this is a really important point that I really regret not saying at the beginning, this is joint work. This work was done in Helsinki. I was teaching there. I was very kindly hosted by Hanu last autumn, and I gave this task to students of a computational creativity class. And my co-author, Khalid Al-Najjar, was one of the best students in the class and came up with a really good solution, and is the co-author of the paper and is the guy who did the really interesting empirical experiments that I'll talk about shortly. And Khalid had the great idea of using an analogical color scheme. Now, an analogical color scheme is a color scheme where you take a series of colors that are relatively adjacent to each other on a color wheel, such as the RGB color wheel. So you don't start saying, I'll take a color from here and a color from there, right? You say, I'll take a color from here, here, and here. And you get colors that naturally fade into each other, like the colors of nature, like leaves changing. So what we do is we assume that the color we're presented, that we have to name, is the middle of the analogical color scheme. And we pick two colors on either side of it. And then we find a linguistic Ngram, a ready-made, that provides this color and this color, and then that's how we name the color in the middle. Now, Khalid put together a bot. All the students were asked to build bots. And they were asked to give their bots a personality. They really seemed to enjoy the idea of not just building a bot along some CC principle, but to put their own personality into it. Khalid's bot, which he called Hugh bot, aims to psychoanalyze users. So tries to psychoanalyze every color bot, which is a long and deep analysis, I imagine. Humans name E55F7C pink red, but we proudly name it Crimson Flesh, right, which is straight out of the Hammer horror movies of the 60s. Another student, a very good student in the Helsinki class, named his bot Drunk Circuit. And his bot was meant to be a bored IT worker, just tweeting about the vagaries of life, like many of you are doing right now, right? And so they all have this disaffected air of an IT worker who thinks he's too good for his job. Thank you, every color bot, after giving me this color. Now I want rosé champagne. And then he tags it wine styles. Okay, so you can see that this bot is actually categorizing the resulting noun compound as well as deriving the name. So he figures out, or the bot figures out, that rosé champagne would be a good name for this, and that rosé champagne names a kind of wine, and that's why he tags it. One of the tricks with Twitter bots is you want your tweets to be seen by people who aren't following you, so you tag them in ways so that people who aren't following you will see it when they do a search for a tag of their preference and say, this guy's a wine expert, and follow you for one tweet. And then they will. The next tweet you'll start talking about Shrek snot and they'll stop following you. It's a sad and precarious life being a bot designer. Awesome color bot, as delicious as honey shrimp. It doesn't look very appealing, but I would eat it anyway. Now, here's a common, by the way, there actually is a color here, but it's been eaten by this, okay? So here's a problem of tonality that you see in a lot of Twitter bots. Honey shrimp sounds delicious, and honey shrimp is a great, the color is a weaker version of this color, right? It's a great name, honey shrimp. So it's found a name that appeals to people, and that people would think, yeah, honey shrimp would look that color. I can see that. It's a good name. Then he says, doesn't look very appealing. As delicious as honey shrimp. Well, either this is ironic, but honey shrimp, who's not going to like honey shrimp, right? So there's two sections of this tweet that are at war with each other because the system isn't doing coherent combination. So back to Mike's talk earlier today, when you pick things, it's picking the elements at random here and it's putting them together when it should have a theory of honey shrimp. Well, sentiment analysis says shrimp is neutral and honey is really nice. So that would be nice to taste. So that should say looks very appealing and act accordingly. So you can see the boundaries of its generative grammar here. But still, for a student project, it's pretty good work. Now, we looked at how humans name colors, and there are people who like to name RGB colors for fun, not for profit. There's a website called colorlovers.com, and you go on and you type in an RGB code, and you'll find that people have named it. And then there are other people who express love for that name by, it's like liking something on Facebook. So someone named, these colors are different colors, by the way, but again, it's been eaten, Sparrow's Lament, Sparrow's Angel Wings, Sparrow in the Wind, right? Like Elton John themed down there. The colors are actually quite different. Maybe you can see them here. Anyway, those names are human names and people like them. I think they're pretty poor names, which sets us up for a thrilling evaluation. So anyway, Khalid's bot, Hugh bot, limits itself to color combinations based on the analogical color scheme that provide combinations that can be categorized as natural, foods, liquids, and so forth. It's using semantics to limit what it's generating. And we gave people on Crowdflower pairs of names for the same RGB code, generated by humans on Color Lovers and by HughBot. We didn't tell them that they were generated by humans or machines. We simply said, these are names that have been suggested for these colors. What do you think? We gave them 3 questions. Which name is more descriptive of the color shown? Which name do you prefer for this color? Which name seems to be the most creative for this color? And we chose over 1,500 colors. In the end, we recruited 940 distinct judges. We got 5 judgments each. And for the the names that we chose from color lovers, the human-generated names, they had an average, a mean of 2.18 loves each, right? They all had at least one love. So there was at least one human out there who said, I love this name. Right. And then we gave them the best name generated by Hugh Bot. And the numbers are really startling. Now, they're startling in a good way and in an unsatisfying way. In a good way, because we trance the humans here, right? Rise of the machines. I don't like Sparrow's Lament. It's completely opaque as a name, right? It's not grounded. Why is this color sparrow? Why is it lament? When you call it Crimson Doom, now you're conveying lament, right? So 70% of the judgments went the computer's way on the descriptive name, but also for preferred name and creative name. Now, I suspect what's happening here is that the humans who get paid pennies, right? They get paid peanuts to do this, have made one decision, and then they say, right, it's the most descriptive, so it's also my preferred name. We've told them, we've primed them to find it most descriptive, so it's most preferred. And it says most creative, well, of course it's the one that I prefer, right? Because I've got creative taste. So we get the same numbers for 3 questions, but they all go the same way, 70-30 split, which I think is quite remarkable. And one of the reasons is grounding. Ironic, is it not, that the human names are not very well grounded. When you present the color and the name, humans have a tough time saying, why is this called Sparrow's Lament? But the machine name is transparent. They say, yeah, I can see that. It's the color of honey. It's the color of shrimp. I like honey shrimp, okay? Oh, honey shrimp. So it's not hard to ground your symbols. And if you do it right, you can do it better than humans. So, on that note, any questions?
Thanks for a terrific talk and a terrific piece of work. It's great.
Two things on your last conclusions there. The first thing is about the way the bot actually generates its colour. So, I mean, that's built in, right? So, I wasn't quite sure what your point was about doing that explanation of the descriptive thing around the colour wheel, just at the very end while we were talking about that. So could you just clarify that for me? The other point is, isn't there another downside here, which is that the kind of people who are spending their time on colour lovers and not necessarily the people you necessarily want to compare your system with?
I'll answer the second question first. There's no point getting sniffy about our subjects because we'd have to preclude all of the web from taking part. Actually, I mean, they're quite poetic names. So I think they suffer. The hypothesis is that they suffer because they're not grounded.
Which is kind of the other question, actually.
Yeah. And then, or in fact, they are grounded in an opaque way. So they're not immediately. It's not immediately obvious why you would call this sparrow or lament. Whereas the human names being opaque, the machine names are quite transparent. Each of the components in the name is associated with a color. The juxtaposition is interesting. So I think that's why we get most creative name.
But then shouldn't we be saying that they're less creative than the human ones? That's the point that I failed to make in my question. Sorry.
Why should they be less creative?
Well, because they're grounded in something that is really obvious. They're right next to the same domain as the thing we're trying to discuss. Whereas the others have much deeper levels of analogy in them.
Well, they're not. They have a color similarity, but they're not in the same domain. So, for instance, honey and shrimp are both foods, but they're quite far apart in an ontology. And the idea is very appealing. Right? So, paper tiger, no one invented the phrase paper tiger to describe a color. It's being repurposed as a color name. So it's not like we're taking existing color names and associating them with colors. We're taking existing phrases with semantic import, grounding them in color, which is something that maybe people haven't done when they use these phrases, and then making people think, oh yes, that would be the color of a paper tiger. But when you see the name paper tiger on a color, you think, but that also has the resonance of someone whose bark is bigger than their bite, someone who talks big but has no all hat and no cattle, if you like.
I have two kind of related questions. One of them is, do you know what the mean number of likes for a name on the color website is? So the sample you pulled had a mean of 2.18 likes, but do you know what the mean is for all colors?
No.
If it's like 2,000, then you picked all the lousiest ones. If it's like 1, then you picked the best ones and really trounced them.
No, it's not 1 and it's not 2,000. If you do, I guess we should have calculated this on a large sample, but if you do a cursory look at colour lovers, you'll see that lots of colours have 0, some have 1 or 2. You might find a handful with 7 if you were to do one.
Okay. And then a related question is, you're claiming that the reason that there's a big difference in the Hugh Hubot's names and the human names because Hugh Hubot has them grounded very nicely and the humans don't. But do you have any way to measure that grounding? Like you could, I haven't seen any of those names, so I don't know, the few you showed me, I would agree with what you're saying, but 1,500 colors, is there any way to measure the groundedness of them?
No.
So that you could say, for example, that the 70-30 really must be very correlated with the groundedness because this group isn't grounded and this group is.
Well, I guess. Have a look at this one, porcelain toilet. What color is porcelain?
It's white.
Well, porcelain doesn't have to be white, but it's a default assumption, right?
Right.
What color is a toilet?
It's white because
It doesn't have to be.
porcelain.
Many
Right.
people have fancy avocado colored toilets.
Sure.
So porcelain toilet, it's not like people are taking the color of porcelain, the color of their toilet, calculating the color of porcelain toilet. What you're doing is you're presenting them with a hypothesis that the color of something, the hue of a paint that was called porcelain toilet would be this hue, and then people are agreeing with it. So it's different from giving them a deterministic analysis. So it's not like you're saying this is absolutely grounded and you see it right. It's more like I'm exploiting the fact that once I tell you the name, you're going to construct confabulated grounding, which harks back to what Mike was talking about earlier today, in that we often have post hoc reasoning. If you give people enough reason to look for meaning, they will find meaning. If you just present them with randomness, they'll soon figure you out and won't look for meaning anymore, which is the theme of a talk later this afternoon.
Last question, I think. It's tricky. That's okay. I'm a lot later. That's okay.
I'll break a pool cue.
Okay, so using RGB color space, which is identical color space, since you are using the colors of materials, it might suggest to you subtractive color space instead of identical color space, something like C and Y. Would it make a difference if you use identical versus subtractive when it comes to naming? Maybe.
Well, actually, we did. The color stereotypes were done in RGB because there are more tools for RGB on the web, and you're more likely to be able to do a web search and find the RGB code for a given thing. But we did convert it into a different color scheme, the CIE lab color scheme, which is closer to how it's claimed to be closer to how humans perceive color. So RGB is not a good model of how humans perceive color, and artists who wander into the digital domain quickly end up eschewing RGB for different systems. And we picked the CIE lab approach. But there are other approaches that we could use, you're right, and we might have gotten even better results or worse results with subtractive schemes, CMYB. Right. Just one quick one, because he had his hand up from the very beginning and I was rude enough not to.
I can ask you later.
Okay.
Make it quick. With the human names, did they come from experts who had rated lots of, or named lots of colors, or were they just randomly selected?
This is the web. I mean, everyone's an expert.
I wonder if somebody who's named 200 colors versus somebody who's named 1 color, because your bot is an expert, right? It has collected lots of you, your students, and all that.
We like to think of it as an expert. That's how we're putting it out there. Basically, if you spend your time on colorlovers.com, you're a self-proclaimed expert. But I guess what you're asking is if we got designers, if we got someone like Kaz to do this, if we paid him 5 cents per color, would we get better results? I don't think so. We'd have to go up to 7 or 8 cents. No, but your point is well taken.
It's be interesting to see.
Yes. I don't think we will see, but you're right that if we did have designers on top, then it would be very interesting to see their. But
I suspect designers would really go for spirals laments.
You don't like worse than the toilet.
Well, yes, that's my favorite. So, thank you.
It's a coffee break now, but let me
Ladies and gentlemen, before we start the session, we have two announcements. The conference has the Best Paper Award Committee, consisting of Amilcar Cardoso, who is here, and Rob Saunders, who couldn't make it here today. And we'd like to hand out two of these awards before this session, because they will be presented here. So I'm very proud and happy to announce that the award committee has decided to award the Best Student Paper Award to Sarah Harmon for her paper. And then we will hand out another award as well, which goes to the Best Paper Runner-up. And I'm proud to announce the winner. She is Sarah Harmon. The Best Paper Award will be announced at the reception tonight, and so will the Best Student Paper Runner-up. So stay tuned.
No pressure now. Well, welcome to the last session of this day, I think. I'm very happy to introduce our winner, Sarah, with her presentation, Figure 8, a novel system for generating and evaluating figurative language.
No pressure. Hi, my name is Sarah Harmon, and today I'd like to share with you my work in generating figurative language. Now, figurative language is something that everyone in this room has encountered. Some of you have even researched it extensively and built Twitter bots as a result. And it's something that we teach each other from a young age. It's something that we tune into and we hone in on. And it's so a part of our culture that we often forget about it. We say things like, I see what you mean, without even considering that seeing is a metaphor for knowing. So we surround ourselves with figurative language, and we do so for important reasons. And it's because figurative language lets us express ourselves. It lets us express our emotions. We can, with it, we can relate unfamiliar things to things that we've seen previously, our previous experiences. And it even helps people to, us to get people to listen to us better and to understand what we're saying better. So I should be using figurative language a lot in this talk. I don't. But ultimately, figurative language is something that it's just ingrained in how we talk with each other. So my thinking is that if a machine could generate figurative language, it should be able to reason about our own language usage as humans and narratives much more easily. So this leads me to my research question. Namely, I'm interested in whether a computer can generate creative figurative language and whether it can do so on par with humans. And as we've kind of touched upon in some of the talks previously, this is a very challenging process to get right. So for the purposes of my research, I narrowed my focus by examining only the simile. And that's a phrase where you use like or as in the comparison. Now, there are properties that we can identify that make certain similes better than others. And we can rely on these properties to establish our goals for a figurative language generation system. So I'm going to list a few. We've already, again, some of the talks have already mentioned some of these. But I do want to clarify that these are by no means the only goals that we should be considering. I think they're important, and some prior researchers think they're important, but I do want everyone's minds to be open. So first, I think that a good creative simile should be novel. Salvador Dali once said that the first man to compare the cheeks of a young woman to a rose was obviously a poet, and the first to repeat it was possibly an idiot. So we don't want to hear cliches in our writing. They don't engage very well at all. The simile should also be understandable. There should be a clear, accurate link between what you're describing and also what you're using to describe it. Now, surprising. The surprising property makes for a more enjoyable simile. As humans, we often think that similes are more clever if we're surprised. And this tends to happen if we see a comparison between two things that are they're not in the same major categories. They maybe have a few properties in common, but they aren't conceptually similar at all. So if I said to you that the cherry was like a strawberry, that's not very surprising, that's not very interesting, because cherries and strawberries are in the same major category of fruits. Ideally, a strong simile fits the context in which it lives. So this is what I mean by apt. You don't want the simile to just come out of nowhere or have no purpose to the paragraph that you're currently writing. So you want it to be context appropriate. And this is a fancy word for saying that similes should sound good. So if I said that her empty eyes were like a deserted desert, that wouldn't really be satisfying, because the high similarity of deserted and desert is distracting. So you won't find that simile in literature, I don't think. I at least haven't read it. But you will find the somber desert or the fragrant desert, because these sound much nicer, and they also do other things, like they appeal to our senses. But generally, they sound quite nice, and we like them for that. And finally, a creative system should generally be able to come up with knowledge from outside of its pre-existing knowledge base. So otherwise, the output is going to sound maybe novel to a human initially, but it's going to get boring once you realize that all it's doing is spitting back the same constructions over and over. So I want to be surprised as a creator. We all want to be surprised as system creators. Now, there have been some wonderful examples of prior work that construct similes and metaphors based on these properties. Aspera, for instance, was a case-based reasoning system that intelligently adapted examples from corpora. Prior work, we just heard from Dr. Tony Beal, but prior work has shown that using properties and categories of things that you're comparing is useful, not only to make the simile more understandable, but also to make it more surprising. And Dr. Beal has also, we'll hear from him again very soon, but he's also shown that systems driven by the web can be very powerful in terms of harnessing the internet's knowledge base and for creating coherent similes. And so we can easily find conventional similes this way. So all of these works inspired me to expand upon them and to create my own system that generates figurative language, and I called that system Figure 8. Central to Figure 8 is that we model the human processes of creativity and revision. Now, not everyone agrees on how we should model creativity, which is why we have this conference, and not everyone agrees on revision either. And this is not just computational creative people, but everyone in psychology, across a wide array of fields. But what most researchers do agree is that to author language and stories, to start this writing process, humans are going to rely on their prior knowledge and their experiences. So in computer science, an appropriate analogy might be using a case-based reasoning system or a CBR system, which is what a lot of prior work has done. So most of you have probably worked with CBR systems before, but just briefly, how a CBR system works is that when you're presented with a problem, a CBR system will access a case library of similar past problems, and then they're going to attempt to solve any new problem that they encounter by just referring to that library. So Figure 8, in line with this, is a CBR system, and it has some fancy imaginative processes attached. It has what's called a brainstorming phase, where it generates similes using meaningful decisions based on what it knows, things like categories and properties. And then it has a revision phase. And during revision, it ranks these generations based on the desirable simile properties that I mentioned earlier. So in this ranking, we can do things like we can rank novelty by simply looking at a list of cliché comparisons. To make sure that the simile makes sense, Figure 8 will perform a simple Google query to see how many people have said something grammatically equivalent. We want to say chocolate sky, not sky chocolate. You can also pass in a simple world model to Figure 8. This is just a simple set of parameters for now. And that ensures that it generates something that's specific to a certain context. And finally, it looks at all kinds of things. It looks at properties of words, categories shared, various kinds of similarity, and all of these to make the simile better. So this will make a lot more sense if I give you an example. So I'll step through the basics of how the procedure works. So this is a block diagram of the general system. So let's say, I'm going to give you an example that's not very modern, because a lot of the texts that I was drawing from Figure 8 were from Project Gutenberg. They were fairy tales, literature from classics texts. They were from a long time ago. So for the sake of that, let's say we're writing a story about a man who's coming to visit his sweetheart's home for the first time. So the first thing, he's walking down the road, he's thinking about her, and the first thing he sees is this garden in front of the house. Now, as good authors who want to make meaningful writing choices, we can stop and think of it here. We can say, okay, he's going to meet his sweetheart. How should we describe this garden? Maybe we want to reflect this mood that he has, that he's in love. Or maybe we want to foreshadow his meeting with her. Hopefully it's a positive one. Or maybe we just want to describe the garden in terms of how he would describe his friend. So Figure 8 doesn't do any of this planning yet. But what it does do is we can tell it that we want to describe a garden, and we want to do so in a beautiful way. We want to use a simile to say that a garden is something that reminds the main character of his friend. So what Figure 8 does is, in line with Tony Veal and some other researchers, the system has this knowledge base of words and their properties. So it can search for a word with properties that are in common to the one we're searching for, garden. This knowledge base was actually scraped from the web. It's scraped from several online databases, and it has the ability to expand. So in this case, in this example, Figure 8 found moon as a word that might share properties with garden, which is pretty good. A moon is like a garden, not too much. They do have a natural beauty to them, but they're not the same thing, as I hope we all know. Gardens are man-made plots of land. Moons are celestial objects. So already we're doing pretty well in terms of generating the simile. Now, what Figure 8 does is it actually looks at what other human authors have done before. So it says, okay, how have other human authors described moons? And then by relying on some of the related words in those descriptions, we might be able to enhance the clarity of the simile itself. So here we find that authors have written phrases such as the slender moon, or the moon was rising, and so on. What Figure 8 then does is it uses these descriptions to create a complete sentence. So what it's doing here is it has a case library of grammatically appropriate sentences, and it performs a process called imaginative recall on these memories to create new appropriate sentences. So in this case, one final sentence that Figure 8 has generated is, like a pale moon, the garden lit up in front of him. So having the garden perform an action like a moon and be described like the moon strengthens and clarifies the simile. However, this is just one construction, right? So the real beauty of Figure 8, of this system, is that it generates lots and lots of these potential similes, and then it ranks them by their desirable properties. And it says, okay, this one, I like this one best. This is the one that I should use within this paragraph. Now, it's imperative that this ranking process is good. So I wanted to make sure that if I had humans rank the same similes, that their rankings would generally line up with Figure 8's. So to do this, what I did was I recruited participants from Amazon's Mechanical Turk, and I had everyone look at generated similes, rank them in terms of how understandable they are. So when I say understandable, I'm going to call that clarity. And I also had them rank them in terms of how much they personally liked them, in terms of quality. And I randomized how I would ask the questions, so hopefully there's no bias there. And I should note that the participants looked at sets of these similes. So that is, they looked at 5 different similes that were attempting to describe the same thing. So tenor here is just a fancy word for what you're trying to describe. So one set may be 5 different similes that describe a beautiful garden. The garden was like a moon. The garden was woven as elaborately as a lady's dress, and so on. And importantly, these sets were not cherry-picked. So what I did was I ran the system and I said, give me the first comparisons that you come up with, rank those. I don't care how terrible they are. I'm just going to use them and give them to the humans and see how they rank them as well. So here is an example of one such simile set that you might see if you were a participant in my study. Figure 8 was trying to describe a queen, and you can see that it considered a few different properties that queens might have, such as their strength, their grace, or their beauty. And you can also see that some of these are definitely better than others. So if you want, you can take a minute right now and decide which one you like the best, and I'll show you the computer's rankings in a minute. So the generations are, there was a queen glowing like a somber forest. It was their queen flying like a white bird. She saw that queen strewing like a yellow flower. The queen blocked them like a rugged mountain. And the queen stands like a strong castle. You'll notice that some of these sentence constructions are quite similar, and this is actually on purpose. So in a pilot study, I had people rank more complex sentences that Figure 8 generated with more applied context-appropriate knowledge, and this actually wore some of them out. The cognitive load was a bit too high, so we had people saying, oh, this is so frustrating, these sentences are so long, and I can't believe we have to rank all of them. So for the actual study, I told Figure 8 to keep it short and simple, just for the sake of these, for all the other future participants, and just to make sure that their frustration wasn't reflected in their rankings. All right, so here's how Figure 8 ranks each of these constructions. The queen stands like a strong castle is the clear favorite here. Figure 8 decided that this was the most readable construction, as well as the one that it liked best overall. So it did this based on its memories and research into how good authors write. So by looking at this, we can already see some interesting decisions made by the system in this example. For instance, it does like the simile about the queen, comparing the queen to a bird, but it concedes that it isn't as readable as a queen blocking a group of people. So flying like a white bird sounds quite nice. It's a little cliche. It's a surprising comparison for a queen. However, a queen is really more likely to block someone than she is to fly. For this particular simile set, humans were in high agreement with Figure 8's quality and clarity rankings. First and second choices were an exact match, and this actually happened quite often across the sets. And Spearman analyses further confirmed these strong positive correlations. And interestingly, there was not only a strong positive correlation between human and Figure 8 ranks, but also humans often liked the similes that they thought that were the most readable. So generally, this was a fantastic example for me to see because first and second choices are dead on, and we see these strong positive correlations. We're even finding some interesting things that I hadn't even thought about before. So now let's look at the example that makes me cry. So this was the simile set with overall the least significant correlations. Figure 8 is trying to describe snow here, and I want to point out one of these in particular. We have all of these flowery, whimsical descriptions. The snow is like a leafy sun. The snow is like a voracious bird. And then we have the snow falls like a dead cat. This is my favorite simile that Figure 8 has ever generated. You can just imagine snow falling off the roof or a mountain like a dead cat. And it's memorable. And that's something that I hadn't even told Figure 8 to do. That's a property maybe not of creativity, but it's of good writing, right? It's a property of good imagery. Let me now extend an apology to all the cat lovers in the audience. I should mention that I love cats, I promise. But I also love that simile. So it's upsetting that neither the humans nor my own system acknowledge the inherent beauty of the snow falls like a dead cat. And instead, everyone seemed to think that comparing snow to rain was a pretty good simile, despite the fact that comparison is not very surprising or interesting, at least to me. Figure 8 did like the voracious bird one the best. I guess that's cool. And the cat simile was at number 2, which might be my own personal biases shining through the system. I'll talk a little later about why this might have happened. So back to describing snow. So if we look at the actual correlations, we see that figure 8 and the humans matched up pretty well in terms of what they thought was readable. What they liked, however, had no significant correlation, so that was sad. But that was a rare occurrence. 46% of the time, figure 8 exactly matched its first choice for clarity and quality with that of the humans, and it exactly matched its first or its second choice with humans over 80% of the time. So thus far, figure 8 has been good at matching top choices, and it's had strong rank correlations overall. So I'm pretty satisfied with how well figure 8 evaluates its work. I would like to talk about some interesting findings that I found along the way. First, people love ranking sentences when they're short. I got many, many comments from people who participated about how much they loved doing this and how relaxing it was. And I should note that there didn't appear to be a significant difference in rankings between people who gave me those comments and between those who didn't. So that's good that that didn't affect anything. But this generally was just exciting for me to see because I'm always happy when people are enjoying their time participating in these kinds of things. There did seem to be a set of people who would like the similes if they were more readable. And that doesn't mean that their rankings were exactly the same between quality and clarity, but what it does mean is that they generally ranked similes as more likable if they were clearer. So this is an interesting finding. You can think about things like a lot of times popular books, for example, are more readable. So there's probably more to explore here. And people also appear to like the similes with higher positive sentiment, which may explain the dead cat problem. One of the reviewers actually pointed this out, so thank you for that justification. I really want to know why people didn't like that simile, because I love it. I do need more research to confirm this idea, however. So I'll probably have to conduct a separate study without any of these confounding variables. Generally, though, there do seem to be certain qualities of similes that people hone in on and which drive their choices. Things like how they sound, or how whimsical they are, or maybe they relate positively to some event in their past, which is harder to find out and adapt to. But this is something to explore for future work, right? So can we identify these groups of people with certain preferences, and can we adapt computer-generated text to these preferences? Another direction for future work is to ask experts, like English professors, perhaps, to rank the similes too. So I'm interested in what their preferences are, and how similar are they to the general public, who are obviously down here in comparison. Finally, I would love to improve upon figure 8 in general and evaluate its work against actual human authors. So would figure 8 be more human-like if it used preference functions, or if it wrote its own code? Right now it has the ability to learn based on what it reads and how others rank its generations, but there's so much that could be improved in terms of how it models psychological processes. And there are also methods that may enable its lexical and syntactic decisions to be much more meaningful. So there's a great deal of work that's yet to be done there. And I'm hoping that as I continue to improve this process of generating quality output and make it more human-like, that figure 8 will still be able to discern which of its outputs are the best. So the link up here is to a short demo. I wrote up some examples so you can more clearly see a few parts of the figure 8 system. It's not exactly figure 8, but you can at least see a few of the resources that I'm pulling from for this system. And thank you for your kind attention today. Yes, ma'am.
Fascinating talk. I'm wondering if you consider...
Sorry, can you speak loud, because it's not possible to hear on the
I
background.
can be loud, sure. A great talk. So I wanted to ask if you considered having authors use this as kind of an aid.
As an interactive tool?
Yeah.
Definitely, yes. Okay, let's collaborate. What's your name?
Maya.
Nice to meet you.
Yes, sir.
Hey, yeah, congratulations on the award. So, the tenor selection,
Yes.
is there like a specific sort of like tone or something that you want the system to generate? For example, in the example you're giving, you say that the garden should be beautiful or something.
Mhm.
But in the examples that you gave, it seems like the 5 descriptions of the queen are very different.
Oh, they're
So,
very different, yes.
is the system actually trying to convey some specific attribute about the tenor, or is it just choosing 5 sort of like possible attributes of the tenor? Because I mean, if you're going to use this in a real setting, presumably there's something about the queen that you want to convey, right?
Yes. So the answer to your question is yes.
Okay.
It does both. So for the study, I actually had to take out the context-appropriate components, just so I could make the sentences more simple for people. I found that if I was including more of that context information, it somehow made it more frustrating for them to rank sentences. I maybe took out a bit too much of it. I mostly just wanted to make the sentences as simple as possible. But it does have that ability to, so it can be either, you can give it a set of parameters and it can be as big as or as small as you like. So it can be like, okay, I want you to describe a garden and it should be pretty and it should be green and it should also be red, and it can have all of these different properties. But you can also just say, I want you to describe a garden, and I don't really care. I have a deadline. So, but hopefully that will help with something like an interactive tool. You had your hand up first.
So related to that, I thought it was really interesting what you said about people preferring positive sentiments, and that maybe that was why the falling like a dead cat fell flat. But it also strikes me as like a very noir simile to make, and I wondered whether not so much like specific attributes, but a general tone. Like, could you tweak it to make negative similes, or generally negative, just negative in kind of valence?
Yes.
Is that a thing?
That is definitely a thing. And actually, when I first started doing, some of my previous work has been in sentiment analysis.
Right.
So that was one of the things that I tried to get it to do first. Sentiment analysis it's very tricky to get significant results for even just judging human text. So that was one of the reasons why I strayed away from it initially, but I think I am going to bring that back in. It does, when I say things like describe the garden in a positive way, it does take sentiment into account in that description. But obviously not during the study.
Okay, cool.
Because dead cats are not positive in any way. Hello, yes.
Hi. So kind of continuing on from that question, or your comment about it, it seems like your system is in a somewhat unique position to kind of flip the script. So you could have done the study in reverse and had the system evaluate 5 similes which were created by humans. For example, things like that. Does it have, it seems, because you're just talking about sentiment analysis, it seems like it has some kind of sense of taste or whatever, some preferences of its own about other similarities. So is it a fan of anyone in particular, or does it have any kind of like style that it likes out there in the world?
I need to analyze that much more clearly, but it does. So it obviously started with probably some of my own biases, as I just said, okay, like this is how you should weight things. But as it's learning, it does seem to be evolving its own preferences. And I've noticed that if I feed it different input texts, it will start preferring different kinds of similes. So that's something that would be interesting to explore, especially, maybe I could feed it similes from the internet as opposed to similes from classical texts and see what kinds of things it starts to generate. But that's definitely interesting. Yes, Cass?
When you test, you try testing with some context built in, with some tone built in, you found it frustrated me.
Yes.
Could you keep the sentences short but add context? Because I think this is what Hulu was saying, right? If you just tell it to make similes about a queen who is defiant, you don't actually tell people that. Just give them 5 similes all in the same tone. Could you do that? And will you do that?
I could do that. I probably will. Yes.
Sure. Good talk. Thank you.
The question about combinatorics, so it might be the same question that Joe was asking in a different way. So from garden to the moon, but I could have gone from garden to a lot of different things.
Yes.
And the moon, I have some objectives, but it could be a large number of objectives associated with the moon. So to go from garden to moon to the objectives, there's a potential for a combinatorial explosion. So you must be using something that constrains that search space inside.
Yes. So it grabs moon based on what it knows about properties of moons and properties of gardens. So it does kind of have opinions in that sense. It's grabbing these from word association databases and other databases online. But it does have the ability to expand because it's grabbing from the internet and because it's a live process. I do have many thoughts on where that should go. I'm not sure if I should be make a lot of different figure eights with a lot of different opinions, or maybe I should just kind of let it do its thing, and as the internet grows, then so does figure eight. So I'm interested in I guess hearing everyone else's expert thoughts on where I should take this.
Thank you very much.
Sarah.
Sorry.
Oh no. Are you supposed to? That's very
I went twice, then I'm done. Twice and I'm done.
So we have Tony here again, because you asked for him again, so here's Game of Truth, exploring the placebo effect in computational creativity.
Thank you. It's me again, what you might call the dead cat bounce. Okay, so it's great to see figurative language coming to its own at ICCC, by the way. I want to talk about something that goes all the way back to Eliza, and that is our ability to infer the presence of meaning and intent in contexts where computer-generated text is presented in a special way. So in Eliza, the text was presented as coming from a caring therapist, and people really bought it. Okay? And we still have this willingness to suspend disbelief, which is great for our field, because we thrive on that, right? We absolutely need that. And I want to investigate that a bit more. And now this effect is often called the Eliza effect, but I talk about a subtle variation on it here called the placebo effect. And in medical placebos, the placebo effect is when an empty, non-efficacious medicine has an effect because it tricks the body into healing itself, right? And the placebo effect in computer-generated texts is when a computer tricks the human into inferring meaning that was never intended and to attribute it to the computer and to therefore think more highly of the computer. And again, this is something that we all benefit from in text generation. It's a scale rather than a binary condition. So I call it, when we do creative text generation, we're playing a game of tropes. Back to Derrida again, and I want to investigate that a bit more. Okay, so let's start at the low end. Twitter bots that work purely with data. And these are the most popular Twitter bots, by the way. It's impossible to compete with these guys. They're always on. They're always peppy. They never mean anything, right? They're the philosophical zombies that philosophers warned us about. But they're often very funny because we bring our intelligence and our grounding to their interpretation. So here are some of the best examples. If you can read them again, we're going to pervert the natural color scheme because of our twisted projector. Two headlines by Darius Kazemi, a botmeister who's an internet master of building Twitter bots. He takes headlines from Google News and he swaps out the named entities to create new headlines that were never existed and should never have been created. And when it works, it really works well. So Miss Universe attacks Northeast Nigerian city, dozens killed. I imagine a 50-foot woman in a bathing suit stomping on huts, throwing stilettos, people going, aye! It's all very politically incorrect. And of course, the original headline was Boko Haram commits an atrocity. And of course, the corresponding way this could have gone was Boko Haram wins best swimsuit contest, which would also be funny, but many of them are not funny. You have to scroll down. Sorry, that's a Freudian slip. You have to scroll down to find the good ones. Every word, here's an odd one. Something like 100,000 followers at its peak. And what it did is it takes a Scrabble list, an alphabetical listing of the words in English, and goes through them in sequence, tweeting one every half hour. Starting with A and aardvark and all the way up to zygomatic. Right, and then beyond, because there were the diacritics, which everyone forgot about. So on May 14th last year, it tweeted woman, and it was retweeted 243 times. Not because people were shocked on the web that women exist, which I'm sure some people were. How dare they? They're always clamoring for our attention. But that was the week that Jill Abramson, the first female executive editor of the New York Times, was fired in a situation that many categorized as sexism. Okay, so people brought their own context and their own in-the-loop considerations to bear and thought, by retweeting this, I'm telling my cronies I'm in the conversation that matters. I read the New York Times. I am part of the zeitgeist. Right? And it's a really cheap way to do that. Just wait until a word pops up that you can show off to your friends. And it's a very simple word, woman. Horse ebooks is scandalous. It generated random extracts from ebooks about horses. The name is not metaphorical in the least. And people would imbue these with profound sensibilities. So here, if you exceed these time frames, you can kiss your hard-earned muscle. That just came from a book. It's chopped, so it probably should say kiss it goodbye. But by chopping off goodbye, people imagine a muscle actually being kissed. It's all very strange. And this had over 100,000 followers, but then it was bought by an artist who started inserting little adverts for his own affairs, and it ended with "Bravo, Bear Stearns," the final tweet, which was actually a very clever tweet, but it was human-generated. And people were incensed. How dare you replace the bad computational intelligence we thought we were getting with good human intelligence? Which tells you a lot about why people follow Twitter bots. They follow them knowing they're Twitter bots. And you don't mess with them by creating human intelligence. If they wanted human intelligence, they wouldn't be on Twitter. Right? Right, so pentametron is probably the best. It pairs tweets that randomly, picks random tweets that have 10 syllables, so therefore can be read with an iambic pentameter scan, and it pairs them if they have the same last sound. And you get this vital, accidental poetry that when it works, it really works. So, I'd rather be a river than a lake. You have to do this in a whiny college voice. And then even whinier voice from someone else. This whole semester is a big mistake. And you put them together, and you get very profound. I'd rather be a river than a lake. I should have kept moving instead of just lying around, watching TV, SpongeBob reruns. This whole semester is a big mistake on my part, right? And that's a really good example. When everyone's tweeting about the same thing, such as on Super Bowl Sunday, you get lots of really vibrant collisions of meaning. And then there's Meta for a Minute by Darius again, which is more of a thought experiment, I think. But it's still surprising the more people follow it. It generates relatively random metaphors using a template. X is a Y, A and B. So a dividend is a gerund, shovel ready, but not unbleached. And I've no idea how to interpret any of these things. And my head hurts when I try, so I don't. Anyway, these are very popular, but there's no intelligence as much, which is not to criticize them. They are what they are, and they're very good examples of what they are. They don't claim to be AI. They're a form of internet art, if you will, and successful as that. But the fact that people like them and retweet them shows that there's a certain amount of the placebo effect at work here, that they're reading meaning into them that was never intended and valuing them based on that meaning. And they know that there was no meaning intended, but there's a suspension of disbelief as well. People tweet them going, look what the computer said. Isn't it cute? Kids say the damnedest things, and computers do too. So what these things do is they unweave the textual fabric of the online world and recombine it in a new form with a new purpose. And hopefully the people who follow the system will provide the purpose and the meaning, because the system is incapable of doing it for itself. Again, because they're lightweight systems. They're the paramecium, or the paramecia of the AI world, right? They're interesting thought experiments, and they're fun, and they're art, but they're not AI as such. But it's much more interesting to think of them as art, because this idea of unweaving the textual fabric of the online world, repurposing tweets and bits of blogs, putting them together to create new texts, they're very much in the spirit of André Breton and the 20th century surrealists. Breton famously said, art should be as beautiful as the chance meeting on a dissecting table of a sewing machine and an umbrella, right? By which he meant, and let me interpret for the great man here, that everyday objects lose their magic. We just see them in one role, as a container of water in this case. And the way to revitalize the everyday world is to create unusual juxtapositions of mundane elements and to see new meaning because of the juxtaposition. So if you were to see a sewing machine on an operating table, you'd see the sewing machine differently, right? And you might come to some conclusions that you wouldn't normally think about sewing machines. So Breton was encouraging artists in this new surrealist movement to value randomness, aleatoric randomness, or playful, gameful randomness, surprise and juxtaposition that shocked and revitalized the everyday. Reinvent the familiar with novel juxtapositions. By the way, reuse is a big part of this, and he stole that line from someone else. And that's what they did. He actually wrote a book called The Magnetic Fields, using aleatoric techniques, and there's a band called The Magnetic Fields that take its name from that book, and that's how most of us know it. No one reads that book anymore because it was randomly generated. Okay, here's a system called Meta for Magnet. This is my opus. It's a big AI system. It's all the work I've been doing on metaphor generation and simile generation and affect and sentiment piled into one big bot, right? It's a big-brained bot. And my goal is to try to get people to think that it's at least as good as the ones that were written in 20 lines of Python. And it's an uphill struggle, let me tell you. So I should say that the goal of the bot is to be controversial. It has some of my personality, but I should caution that I do not stand over any of the statements made by the bot, because it's playing with ideas. It's got a semantic representation, it's playing with ideas. And if you get offended, I entirely recommend you get offended with the bot, but not with me. That's the goal of AI, right? That we build autonomous systems that we can blame. I don't want to be blamed. This top one here, analysts, it's kind of rude. It's meant to grab your attention. You read into it what you will. It's got a sense of irony. Irony, when some brides carry delightful flowers the way killers carry threatening weapons. By the way, telling someone that a tweet is ironic is a common thing on Twitter, because it's attenuated our ability to detect irony. And in some of our experiments, we found that putting a word in double quotes is much more effective at inducing an ironic effect than actually saying #irony. People ignore the #irony because we accept on Twitter no one knows what irony means. There are n Twitter users and n+1 series of irony on Twitter. I used to think of myself as a spiritual evangelist that bought the Bible. Now I see myself as a soulless heathen that carved an idol. So there's lots of juxtaposition, there's lots of counterpoint, there's lots of ideas being undermined and disanalogy. Would you rather be a god performing an amazing miracle, an entertainer performing a commonplace routine? The idea is to make you think of one as the other. Either that when entertainers are on fire, they're like gods, or God demanding miracles from God is a bit cheap, right? So it's meant to make you think. What you think is up to you. So there's a bit of the placebo effect even here, but it's giving you semantics to work with, unlike random. It's not purely random. And it's very much in the spirit, since I've already mentioned one dead Frenchman, let me mention another dead Frenchman, who I only discovered recently, but which I found out that one of our number, Nick Montfort, who can't be with us this year, actually used as the basis of his work in earlier systems. Raymond Queneau, he won the Prix Goncourt for this modernist work, Exercises in Style, where he took a very boring story about an argument on a bus, a man being jostled on a bus, and he wrote it 99 different ways in 99 different styles. And each style exemplified a different part of the story. Styles were things like subjective, metaphorical, logical, superlogical, lipogrammatic, where you leave out a letter and don't tell anyone. And depending on the style, you read the text differently and you come to different conclusions. He was essentially exploring the power of style to persuade and to induce a meaningful effect. And you can think of the Twitter bots I showed earlier as one exercise in style each. So metaphor a minute is one exercise in style. Pentametron is one exercise in style. I want metaphor magnet to be more like this. 99 exercises in style, a kind of a virtuosity of style, but also meaning behind it. Okay. So, for instance, one of the styles I've been exploring, and there's not 99 styles in metaphor magnet yet, but there's maybe about 30, is dream style. So it will generate tweet pairs like this. A wife calling herself @sex criminal writes, "Last night I dreamt I was an unprincipled criminal receiving punishment." Right? Notice it invents the entire text from whole cloth, but it uses concepts such as what it means to be a criminal, what it means to be a wife. And it invents the name of the caller, if you will. This is like an agony aunt. So it says, well, someone who dreams about being a criminal and there's a sexual meaning, sex criminal would be a great name. And it uses the techniques that I explained in the color talk, using Google Ngrams and interpreting them. And then it responds, in your dream, punishment equals marriage @sex criminal. Marriages are typically entered by dutiful wives. Are you unprincipled or dutiful? Right? Or, I used to think of myself as an analytical academic that joined a university. Now I see myself as an unthinking cultist that joined a sect. Okay, that was a bit close to the bone for me. I used to think of myself as a graceful bride that embraced marriage. Now I see myself as a clumsy buffoon that suffered from confusion. By the way, the system talks a lot about marriage and religion and science and sex. It's got the big themes of life and society in there. And again, it's extracted those from the Google Ngrams by looking for phrases, God of X. If the Greeks or the ancients had a god for something, that meant there was a big part of society, and it focuses a lot on those concepts. So that's why it doesn't talk about quarks or shirt buttons, which would bore the hell out of people. Anything in WordNet, 99% of WordNet is utterly boring. It focuses on the big ideas that excite people, and have excited them since Greek times. Recently, gone into narrative style. Narrative is another one of Queneau's 99 styles. It generates stories. So I like this one on top. This is a script, if you will. 1, fight for reform. 2, become a reformer. 3, launch unscrupulous campaigns. 4, grow a mustache. 5, turn into a villain. So one follower retweeted this with the comment, that's an ambitious 5-year plan. So worker equals giant. 1, apply for a job. 2, become a worker. 3, perform colossal tasks. 4, achieve stature. 5, turn into a giant. So I hope you see there's a logical connection between everything going on. These are well-crafted mini-narratives. And it takes a lot of linguistic search to find a formulation that will fit into 140 characters. seek the truth, become a philosopher, study grotesque theories, develop perversions, turn into a deviant. Okay, there's a story we've seen many times in the humanities, right? So, again, it uses words like deviant, grotesque, and perversion, and charlatan, and fraudulent, irrational, colossal, unscrupulous, and mustache, all to convey shock value, right? It has a highly affective lexicon, and it really searches for the most powerful formulation of words and contrasts in ideas. But how much of this is the placebo effect? There's a lot of logic and semantics, but again, there's a lot of the user's interpretation being brought to bear just as much as in Horsey books. So how much of the placebo effect is at work here? And again, it's a graded phenomenon. It's not like a binary, yes, it's placebo, no, it's not. There's a degree to which every generative system relies on the charity of strangers, right? So, generally in language, this is how it works for humans. We say something, but what we say is a small percentage of what we communicate. So it's the tip of the iceberg. We say enough to allow our listeners to construct something approximating our intended meaning, right? So we say, can you close the window, as opposed to, would you mind closing the window? I'm freezing, and why didn't you close it already, right? We dance around things, but we also use circumlocutions, we hint at what we mean, and the listener constructs the vast majority of the meaning, not from what is said, but what is implied, what is inferred. And this happens a lot in humor. Humor forces us to construct meanings that are not explicitly contained in the text, and we feel complicit in their construction, which is why a dirty joke makes us feel tawdry, because we're the ones coming up with the conclusions. It's not in the double entendre itself. It's in our minds. Let me give you an example. Colorful example. I use OJ a lot. So you may remember OJ. He murdered his wife and his wife's lover and again got off with it. And now he's in prison for toughing up someone who was selling his memorabilia. And he's in prison for a long time because the justice system doesn't forget these things. Anyway, last year, Sony was hacked. It was hacked, and lots of embarrassing details about Sony were put on the web. I mean, it was coming every day. The chief executives, the top echelons of Sony Pictures were making racist jokes about Barack Obama and his choice of movies, right? Turns out that they were hiding, or Ben Affleck had asked that, who do you think you are, this genealogy documentary. He wanted to hide the fact that he was descended from slavers. It released pay packet information, who was getting paid what they really thought about Angelina Jolie. It was very, very disruptive. It cost them billions. And it was all assumed that it was because they had made this really quite an awful film called The Interview with Seth Rogen and James Franco about the assassination of Kim Jong-un. And North Korea was somewhat tight-lipped about this. They wanted the world to believe that they had done the hack, but they said, how dare you say we did this righteous hack? They called it a righteous hack. And then the Americans, the FBI, said, we're going to launch a deep inquiry into who did the hack. And North Korea said, we want to join the inquiry to find the real hacker. Right? And Wag said, this is a bit like O.J. Simpson promising to find the real killer of his wife. Because O.J. looked for that killer up and down every golf course in California and never found him. Right? And he's still looking in a men's prison, yes. And so the implied meaning, of course, is we all know O.J. is guilty. So that, even though it doesn't say it in the analogy, that's the implied take-home. North Korea is guilty of the hack. They're being precious. We all know the truth of what's going on here. The humor of the analogy comes from what's not said, but what we bring to the table. So again, if you build it, if you give people the right syntax and the right semantics, they will come up with the interpretation that brings their world knowledge, their pragmatics and their personal experience to bear. But you do have to build it up here before they can build it down here. Randomness up here isn't enough to stir the deep processes of interpretation and grounding down here. That's the hypothesis. Let's hope it's true, right? Because we're wasting our time otherwise. And one of the ways that we hope it's true is we've built a new version of our bot, which we'll talk about next year. It's called Metaphor Mirror. I think of it as a metaphor sommelier, right? A metaphor wine waiter. It says, would you like a metaphor with your meal? And in this case, your meal is the news. So it's serving up news stories. What happens if Greece defaults? And Metaphor Magnet is looking at it, or Metaphor Mirror is saying, Metaphor Magnet, give me a metaphor that complements this news story that will make people think about it. And it'll say, okay, to some technocrats, government is a reassuring commitment. To others, it's a worrisome burden. Jeb Bush attacks Hillary Clinton. Not all moderates are liberal, and so on. And when it gets it right, it gets it right. Yes, the day before yesterday, it compared the founders of Google to Bugs Bunny. So we gave, to test the placebo effect, this is the real take-home, we took metaphors from Metaphor Minute, which is a random generator using a template with no semantics. And we took metaphors randomly from Metaphor Magnet, which is our bot that uses AI semantics. Don't do it, Raphael. It uses semantics, it uses syntax, it uses constrained heuristic search. And we gave them to people on Crowdflower. We didn't say they were from machines. We simply said, we found these metaphors on Twitter. Help us evaluate them, would you please? So something has, again, the color has gone out of this. Which is just, that's the effect I was looking for. So what we did was we took the metaphors. Now, let me just show you something. We asked people to rate the metaphors for comprehensibility. That is, do you think this is meaningful? And we got what we expected with Metaphor Magnet. 75% of people, 3/4 of people found Metaphor Magnet's metaphors to be medium-high to very high comprehensibility. Yes, I think they're meaningful. However, over 50% of people thought that Metaphor Minute's metaphors were meaningful. How can that be? Remember the shovel-ready gerund? How can that be meaningful? And it rated Metaphor Minute's metaphors as more novel than Metaphor Magnet. Now, that's to be expected because novelty is easy, right? Novelty is randomness here. Creativity is about tempering novelty with meaning. And tempering novelty means reducing the novelty to bring it into the sphere of the meaningful and interpretable. Metaphor Magnet got much higher retweetability scores. Imagine if you got this on Twitter, would you retweet it? Than Metaphor a Minute. But this is really puzzling. Comprehensibility. How can people be thinking that these random concoctions are meaningful? So we did another test. We took out 2 crucial words from each tweet. So here are the words on which the metaphor pivots. So here, reigning and subservient are the words taken out here. Just let me continue for 1 minute. So I think of myself as a reigning chief and chosen by a council. Now I see myself as a subservient minion that bowed to a devil. And we asked people to put in the pair of words that were taken out. And we gave them 4 distractor pairs taken from the same bot's outputs. So harried, pampered, clever, dumb, great, worthless, infamous, beloved. And we did the same here. Can anyone guess what? Well, here it is. Pyramidic retrospective. A flashbulb is a proceeding, pyramidic and retrospective. Okay, and we asked them to put them back in, and we judged them on their ability to pick the original words and not one of the distractors. And we found, much to our delight, that almost 80% of Metaphor Magnet's outputs were apt in this way. They use words in such a way that people could put in the missing words again and reconstruct the whole meaning. They could actually find the meaning when we asked them to find the meaning. 0 and 0, right, for Metaphor Minute. Taking out random words and asking people to put in the random words that we're taking out turns out to be a tough task to do, right? But this is the real take-home. The people who couldn't do this task, same kind of people who found the metaphors meaningful in the first place, right? Is it meaningful? Yes. What's the meaning? I don't know. What's the take-home? They're seduced by form. The metaphor says an X is a Y, A and B. And they say, yeah, that's what it means. An X is a Y, A and B. But what does that mean? I don't know. Okay, so you can fool people into thinking that they understand, but you have to test them to see if they understand. And when you do, you come up short. So this is the test of a bot with meaning and a bot that looks like it has meaning. Does that make the bot more fun to follow? Unfortunately not. But it does show evidence of the placebo effect. And I'll leave it there. Thank you.
We have time for 1-2 questions.
So early on you had a whole bunch of pairs of words. For example, reformer equals villain and then a sequence. Can anything be put in those two? It's kind of in the middle of the slide. There we go. So could I just put in anything I want for the left and right and it will come up with the sequence?
No, it's generating these things itself and then deciding to tweak them.
Okay.
But what it does is it generates an awful lot of them. And its search space is large, but you can search it. So if you wanted to find metaphors about a certain thing, in fact, if you wanted to generate a metaphor for you, just write a tweet, a topic that you're interested in, and add the hashtag #mirrorme, one word. And then metaphor mirror will pick up that hashtag and match a metaphor to your tweet. And you see it on the metaphor mirror timeline.
Okay, just ask this perfectly. In the very end, you interpreted, it's the very last slide. You said that it looked like people saw there was meaning because of structure. I think what might have happened is that people thought that somebody else would see meaning there. Okay.
So you're saying one might find this comprehensible, but
Yeah.
I could not say.
Yeah.
That's a bit vague for people on craft grammar to do. But yes, I can see how they might, because they're not really trying, are they? They're willing to be seduced into thinking it's meaningful. You give them enough of a foundation for thinking it's meaningful by being grammatically correct. And they go, yeah, it's grammatically correct. Why wouldn't it be meaningful? But that is the placebo effect in a nutshell. That you give people a text that they feel is well formed. It doesn't set off any immediate alarm bells as to nonsense. And they go, yes, it's a metaphor. One expects metaphors to be abstruse. If I were to look, and I'm not bothered to, I'm sure there's a meaning. But then when you pay them to find the meaning, and you test them appropriately, they come up really short. And that's the message I want to get out there.
Thank you very much.
You'll want this back. And I'll want this back.
Okay, we have our last presentation for this session. I hope to pronounce it properly. Marman. She's going to present us OMG, You Are Funny. Computer-aided humor with an application to chat.
Hi everyone, my name is Miao Miao Wen. Is this working? Okay. I'm from Carnegie Mellon University. This work was done last summer when I did an internship at Microsoft, so all of my other co-authors are from Microsoft Research. Let's begin with the introduction. So many people are wondering about this question, like since Turing, like many years ago, like can computers be funny? And we have seen a lot of funny bots, or this chat bot, which is called SimiSimi, which is actually our first inspiration. And this is like a crowdsourcing chat bot. When you talk with SimiSimi actually learns from your response, and also they use a lot of hand-annotated, coded, funny responses. But the thing we find is that many people find SimiSimi to be kind of funny at the first place, but you never see any people who talk with SimiSimi all the time, or even say like more than 5 minutes. So I'm thinking that it's too hard, like for me to do a project in 3 months for computers to be funny. So can we do a simpler version of that question? Like computers help us be funny, or help us be funnier. So this leads to our computer-aided humor work. So we decided not to do a better SimiSimi. We want to do a computer-aided humor where when two people chat with each other, we suggest some funny images for one of the person or both of the person to choose from. So here's how we decided to work on this. We first started with text-based humor because there has been a lot of work on text-based humor. So we tried to add some funny puns. We tried to add some canned jokes like knock-knock jokes, like why the chicken crossed the road jokes, those old jokes. And also that's what she said jokes. For example, when one person says something, we build a machine learning classifier to see when should the other person reply with, that's what she said. And a lot of these, like I spent a lot of time on this, but sadly, when we test our system on Amazon Mechanical Turk, we got negative feedbacks. Like they say, like these jokes are not funny at all. They are for like small kids, things like this. And I feel really sad. I'm like, oh my God, like how my internship would end. So we think about the reasons. So we found that one of the reasons is this lacking of context problem. So most of the human humors are usually uttered in a kind of context or a humorous frame. So out of that frame, it's not funny. For example, we put in a lot of Friends scripts, which we think is very funny. We watch Friends, we laugh a lot. But when we use that script in those chatting environments, it stopped being funny. So, but then this dog saved my life, kind of. Like, I'm not sure how many of you know this Doge meme. So I think let's try some pictures. So I add this Doge meme, and I used a very simple rule. So when one person says something, I pick some words and put it around the head of the dog and suggest the other person to use. And surprisingly, people like it, and they they choose it much more often than all my carefully designed text-based kind of humor strategies. So we think about why. Like, what's the difference between image and text? So images are often more open to interpretation than text because text is more fixed. But images, you can use your imagination and interpret in your own way. And also, we think that images are slower for users to input themselves. So in a chat, it's hard for a user to put in an image. So I think it's a good chance for our computers, which can pull out thousands, hundreds of images to insert into the chat system. So it's a good chance for computers, its power. Also, the pictures contain small context on its own. So for example, a picture can usually be very funny in its own place. So it doesn't need much context. So we decided, okay, we are going to work on this images. So this is our interface. So it's very similar to the iPhone chats or Facebook chats. You see, these are the chat histories. And then this is a small input box where you can text your input, or you can select one of our image suggestions by clicking on them or use your keyboard. Okay, let's talk about our image suggestions strategies. So the first thing we did is try to suggest emotional reacticons and GIFs. So based on previous work, emoticons can help people to chat with each other in this nonverbal environment. So we think this is very natural to use. And also, emoticons often are used to display some kind of humor. And many chat apps supply people with this kind of emotion libraries. For example, in Facebook, if you click the emoticon button, you will see a lot of emoticons you can choose from. But it's kind of complicated. You have to choose what your emotion is, and then choose a character, and then choose the emoticon you want to use. But people still use it. Like, I use it all the time. And so we think, can we do this better by suggesting it, like directly suggesting the emoticons, instead of letting people choose them one by one. So here's how we did it. We used some very basic sentiment analysis, nothing fancy, and detect some sentiments here. For example, if we found that the last sentence is a question, we suggest some kind of I don't know kind of gist. And if it's anger, we suggest some like very mad kind of reacticons. If it's disgust, we suggest some gross images. If it's a joy, we suggest some love and win kind of funny images. If it's sadness, we suggest sad. And if it's surprise, we suggest like, oh my God, kind of images. So it's very simple for them to use, like instead of choosing them from a big library. So our second strategy, we call it image retrieval, because you all know there are like millions of funny images online. How we use them? Like we use a very simple rule. So we retrieve some funny images from Bing image search. And the keywords we use is the funny and +1 keyword. How we choose this keyword? For example, if one of the users say, Mechanical Turk is like a desert today, not a ton of great hits, we will choose the keyword based on TF-IDF, which is term frequency and inverse document frequency, which is a very basic IR technology, which is to choose a word that's most representative of the top of the sentence based on the entire documents. So after we chose the keyword, our search API will go to Bing and search funny desert. So we'll got a whole bunch of funny desert pictures, and then we will choose some of them to include in the as our suggestions. For example, it will become something like this. And our third strategy, we use internet memes. So I'm not sure if every one of you know the definition of memes. It's like those viral images where users constantly modify them. So these are all the meme templates, and people can put their words on these templates, and this becomes a meme. And most of these memes are quite funny, like they use them for humor reasons. So because we already see a lot of users generate their own memes through the meme generation websites, and then post it on, say, Reddit or Facebook. So we think, can we help them use memes in their chats? So we do very similar things. When one person says a sentence, we choose a meme template for them and put their sentence on the top and bottom. So you think that's quite a hard job for them to do it on themselves if they really want to use it in a chat. But we do this very quickly with computer for them. So how we did this? Again, we use some machine learning algorithm. First, we download top 50 popular memes, including all those memes that I'm not familiar with, and all those instances from memegenerator.net. And then we use bag of words features, very simple, and train a classifier. So the accuracy isn't very high, but considering it's like a 50-class classification problem, so we think it's okay. And also, people are very so they don't expect you to generate a very good meme that's gonna go viral. So it's just for fun. For example, if one person say, here they are, we put it on the pedal bear meme, which is actually not very good meme, but it always gives people that sense of mocking with each other's kind of feeling. So the other person say, are you mocking me? Things like this. So this way we help people to use memes in their chats. Like some people don't even know memes, but they still find it funny. Okay, so our fourth strategy is to help people to respond to images with images. This is actually a very simple intuition. For example, on Facebook, one woman posts his fat cat, and most people reply with themselves holding their even fatter cat or some fat cat. Like people just want to reply to things similarly. It's some kind of indication of their appreciation of that kind of humor. So in order to do this, we designed some strategies. And the first one is we call responding kind strategy. For example, if one person posts a funny dog, we will suggest other funny dogs to the other person. And we use another kind of rule, which is called rule of three, which is a kind of very popular joke structure, where comedians will use the first two points to establish a pattern, and then they will throw the pattern off with a third element. So this is like a comedian strategy. For us, we will do, first we suggest funny plus the keyword, and then we will suggest no plus the keyword, and then say many plus the keyword. Let me give you an example. So first, if the person say choose an image with many dogs, we will suggest no dog, and then finally we suggest many dog. So we let the person to respond with each other with images. So they usually find it much funnier than using just one funny dog. Another way to respond to images with images is to reply with emoticons. This is very simple to understand. For example, you see a funny picture, we just give you a lot of LOLs for you to use, or just some not amused ones. So if you're not amused, you can choose these to show your appreciation of the images. We also rank these suggestions because we generated a lot of suggestions with our strategies. We use some, we rank the images based on how often the image has been chosen before in our pilot studies. And then if the image has never been suggested before, we will back off, like based on how often that strategy was chosen before. So a more successful strategy will generate more successful suggestions. That's our intuition. Okay, let's show you some experiments and results. We still test all our systems on Amazon Mechanical Turk. We compare 3 systems. So the first set of systems are computer-aided humor systems. Like we try the different number of suggestions. We try 1, 2, 3, 6, and 10. We also test a computer-generated humor system. Like it's very hard to find a comparable computer-generated system. But we decided that we just use the same suggestion strategies, but we automatically insert the first top-ranking suggestion into the chat without the other person to choose it or not. And so we build this as our comparison kind of computer-generated humor system. And then just plain chat. So we pair 2 crowdsourced workers to chat with each other for 10 minutes with no topic limits. It's actually very funny. Like at first we tell those Turkers like try to be fun, but as soon as they said that they need to be fun, they can't be fun at all. Like they are said, oh, how can I be fun with a stranger? Like they hate our tasks. So we decided, okay, just chat. So they actually find it quite funny during their chats. And there are in total 738 participants, and we ensure that at least 100 Turkers have used one of our systems. And after the chat, we will give them a post-chat survey. This is how we evaluate the system. So we ask them 4 questions, like 1 to 7 Likert scale, like whether the conversation was fun, whether you can express your sense of humor, whether you feel close to each other and involved in the conversation. This is the results of varying the number of suggestions. We see that when the number of suggestions increase, generally the funness of the conversation goes up. And when it comes to 10, the Turkers feel like it's too much. We also tried with a system because when it comes to 10 suggestions, you usually need to scroll with scroll your cursor or something. So it may slower the conversation, and the Turker find it a little bit annoying. So we decided to use 6 as our final system design. These are the results comparing different systems. we can see that for fun, it's our computer-aided humor that's the most fun and help people express humor the most. But in terms of feel close or feel involved, it's still the plain chat that's like make people feel most close to each other and most involved in the chat. By comparing this generative humor versus computer-aided humor, we see that like the computer-generated humor is the one that inserts the top-ranking suggestion, where the computer-aided humor is you only have one choice. Like you have the freedom of deciding whether to include it or not, but the suggestions are the same. We see that people feel more involved, more close, and more fun. So they are comparable in whether they can express their humor or not. So this is kind of very agree with my intuition of this. When we compare with the computer-aided humor versus plain chat, we see that it does help people to be funnier and express more humor, but they don't really feel close or involved in the conversation. We also look at which strategies are more successful. We see that being image suggests almost 10 times more than any other suggestions. So basically, because being images, we try not to suggest the same image over and over again. So because being image has this big pool of suggestions, so we use being image the most. But in terms of which one was chosen the most, the rule of 3 is the one that people like the most. And we also find like people use our suggestions 30% of the time. I think based on a previous study, like people use like 10% of people's chats are kind of involving emoticons. So we think like the Turkers are really using the suggestions too often, maybe because they are just lazy and they find it fun. It can be both. We also have some qualitative insights. The first one is that we find that these humorous images bring more topics to the chat. Like before we do this, because we also tested with plain chat, people just talk about Turkey. It's not surprising, they are Turkers. They will talk about how much money you make. They will talk about like what kind of tasks you do, what kind of platforms you go to. But it's not really fun, but it's very involving. But after we suggest these kind of images, for example, this is an emoticon of Bill Murray, then people very naturally start to change their topic, talking about, like, say, Bill Murray. And we see, because we suggested so many funny cats and funny dogs, many people start to talk about their own pets. So we think it's a good way to like add some topics into the chat. Another qualitative insight, is that this yes and kind of situation, which is people will first accept one another's suggestion and try to build them into something even funnier. And we found our system can inspire this kind of things. For example, one user choose a kind of weird Mickey. Then the other person comment like, this is the creepiest Mickey. Then we suggest a creepy Mickey, the other person like it even better. So they find it hilarious. The final qualitative insight is that we find image humor is kind of robust. Because participants had different backgrounds, they understand images differently. Like they are from maybe different cultures and stuff, but they can appreciate images much more equally than text. For example, some participants, they don't know about memes at all. Like for those people who don't go on, say, Reddit, and they probably never used it, but still they can find it funny. And also, we find that because there are these endless funny images online, we are never afraid of running out of content. So people can chat with each other for a very long time without us running out of suggestions. Also, of course, we got a lot of positive feedbacks. For example, they think this should be built into OkCupid, like online dating. And also, like they think we should put this into Facebook and stuff. So we see kind of these positive feedback, and I finished my internship. Okay, so here comes to the conclusion. So we designed this chat system that builds on the relative strengths of people who are very sensitive to context, and the computers, which is kind of very good at pulling out things very fast. And we suggesting funny images for people to use in their chat. So compared to plain chat and the computer-generated system, we find our system is more fun and enable people to express their humor better. Okay, that's all. Thanks for your attention.
We have time for some questions.
Just curious on the meme strategy. Does the system just choose a pre-rendered meme image found on the internet, or does it actually add appropriate text at the top and bottom?
Yeah. It adds the text to the top and bottom.
Right. Okay.
Yeah.
Okay. So how does it decide what text to?
The text is what the other person just typed
Right.
before.
I see. So basically, just repeating the text in the context, but then you select the most appropriate
meme to put on.
Okay.
Yes. Yes.
So now that you have this technology for helping people be funny, can you now translate that into computers being funny? Because now one can imagine that there is an image that comes, and it's the computer which generates the text or annotation on it rather than human being that generating it using the same kind of strategy.
Yeah, so that's why we compare it with the computer-generated humor system, where computer added to, so it's not always funny. Like I showed you the good examples. So if you always input the images, first people find it that it's not like a real conversation. Like you cannot, if you really want to see a lot of funny images, you can just go to, say, funnyimages.com. But if you really want to chat, have a conversation, you do need a human there to make the conversation going.
I think Cass was first.
Yeah. Do you think, it's okay if you haven't done this, just sort of have a guess. Do you think this would be significantly different if you were having a chat with a close friend than with a random stranger?
Yes.
And how?
Yeah. We actually asked the Turkers, when do you think it's appropriate to use this? They rank close friends first, and then families, and then like coworkers, stuff like that. That's a result in the paper.
So I'm wondering about something like the Hawthorne effect here, of the people who you're doing the study with can tell the difference between the normal system and the augmented system, and they know what you're excited about, which is being funny. Is there a way that you could tease out the extent to which they're trying to give you an answer that would make you happy?
Yeah, first of all, like each Turker is only allowed to do our task once. So I don't know if they know about that we have several kind of systems. So the instructions are all the same, like chat with our system, like they use the same interface. It's just sometimes it has suggestions and regards to numbers, but the other things we keep it all the same. Yeah, and we restrict like one Turker could only like do our task once. And they actually want to do more because it's a very fun task to do. So we try very hard to limit this effect.
No? Thank you very much.
Okay, because I like to stand up and talk about, thank you. Dumb logistical things, I will say a couple more. First of all, I haven't seen nearly enough people wearing their little buttons. You all got one of these in your bag. I hope, I know there's a few people wearing, and I'm excited about that. These are harking back to our meeting in Dublin, at least, so I expect to see lots of these on tomorrow, just out of principle. Now, yeah.
Can we get another badge if we disagree?
No, you have to just wear this.